Sylvain's conference. I think it's a very timely conference. I'm very happy that you had this idea and brought together so many great people, and I'm very excited to listen in. Also, I'm very happy and pleased to be able to present this talk. It's called Generalizability Crisis Meets Heterogeneity Revolution. And many of you might already know that those are two different debates who are kind of debating a similar topic, though. So the generalizability crisis is a debate that has happened, I guess, in personality psychology in any case, last year, following a publication by Talia Koni. And the heterogeneity revolution is another kind of catchword, another debate that is happening also mostly in psychology. And I'm happy to have Elizabeth Tipton as the discussant today of this talk, who is one of the co-authors on a paper about the heterogeneity revolution. What I want to say with this title is there are different presentations or different discussions that are kind of rotating around a similar topic, and our goal today is to bring them together. And I would like to start with two quotes, which you already see on the slide, starting with Imre Lakatos, who, among other things, said intellectual honesty consists rather in specifying precisely the conditions under which one is willing to give up one's position. So that's about boundary conditions. And the other talk by Brian Tipton and Yeager 2 years ago is this heterogeneity revolution will be defined by the recognition that most treatment effects are heterogeneous. So that the variation in effect estimates across studies that defines the replicability crisis is to be expected as long as heterogeneous effects are studied without a systematic approach to sampling and moderation. So in other words, there's a lot of heterogeneity, which is another way of saying there are lots of boundary conditions that limit the generalizability of our research findings. And unless we study them precisely, we don't really know whether a research finding failed to replicate or if it was actually replicable, but just not generalizable. We're going to go into definitions of replicability and generalizability in just a moment. And there's a third quote, a third statement that I would like to start out with as an introduction. And there was a discussion almost 10 years ago already in a conference of the German Society of Psychology. And there was a panel discussion. One of the key meetings of this conference was about the replicability crisis, as I said already almost 10 years ago. And one of the members of the audience, the in Germany much known personality psychologist Hans Westmeyer, kind of raised his hand and meant that the question, he didn't really understand the question and the fuss about the replicability crisis, because according to him, the question should not just be whether something replicates, but under which circumstances something replicates. And that question, according to him, wasn't new. And the answer to that question wasn't just the method artifacts and the flawed methods that were being discussed in the wake of the replicability crisis, but there are lots of different boundary conditions, and all of them need to be studied systematically in order to overcome a lack of invariance across studies. So those are just different thoughts that I would like to start out with. And so that you don't get lost in my talk, I gave you a summary. So these are some take-home messages, and I'm going to discuss and give you the arguments, give you the reasons leading to those take-home messages as I speak. But so that you don't get lost, I would like to give you this outline. And what I would like to talk about today is the need to rethink our research epistemology. So this is an epistemological talk. It's not just an empirical finding. It's not just focusing on one aspect of generalizability or external validity, as some people use those terms exchangeably. But I would like to talk about the hypothetical deductive nomothetic approach that we find in much of the social science, and why I believe that we need to transcend it. I'm going to explain what I mean with transcend. So this talk lays out a new maybe not new, but an epistemological claim. And that is that I would say that understanding heterogeneity and generalizability requires us to transcend the hypothetical deductive nomothetic approach and allow for at least some exploration of unknown boundary conditions, causing potentially meaningful patterns that go beyond a one-size-fits-all trend as the nomothetic approach looks out for. And I aim to connect different points that are related, that kind of rotate around the same topic, but that are being discussed currently in very different separated debates. I would like to bring those debates together, and that includes the debate about the heterogeneity revolution, the generalizability crisis, the possible integration of idiographic and nomothetic approaches or methods, and the debate about within-person versus between-person methods, and related to that, claims about ergodicity and the lack thereof. And in a nutshell, I propose that social scientists tend to assume generalizability without testing it. And when testing it, if they ever test it, they tend to use methods that systematically overlook limitations to generalizability and heterogeneity, and therefore systematically ignore evidence that could prove the assumed generalizability wrong. And we are only starting to theorize and hypothesize more systematically about boundary conditions causing heterogeneity within and across samples. We are only starting to use the research methods, the analysis methods that are suited to actually detect heterogeneity, that look beyond overall trends or one-size-fits-all trends. And these methods and these methodological approaches need to include exploratory and idiographic methods that look for patterns that go beyond a one-size-fits-all trend. For instance, go beyond an average or go beyond an average treatment effect. Generalizability, I would also say, cannot be proven. The absence of an unknown boundary condition cannot be proven. Instead, boundary conditions need to be ruled out step by step by examining all that come to our mind. And this process is never really logically complete. So we can never make a logically infallible conclusion about whether a finding was non-replicable or if it actually was non-generalizable but replicable. That means that inferences about generalizability will remain an educated guess, but an educated guess is still better than an uneducated claim of certainty. So this is in a nutshell what I would like to say today, and now we are going to go into more details and explanations. And also, in a nutshell, this is what this presentation is about. Usually, our hypothetical deductive approach to finding out whether a finding is trustworthy or not is that a researcher attempts to replicate a finding that was previously published, for instance. At least since the replicability crisis, this is what we try to do. We try to determine whether research findings are trustworthy by trying to replicate them. But what happens if we fail to replicate a finding, meaning if there is variance between the first study, original study, and our replication attempt? So this can happen. A replication attempt fails. The findings differ between samples. And what usually happens in a deductive theory-driven hypothesis testing framework is that the null hypothesis stating replicability, or in other words, invariance between samples, is considered falsified. The researcher concludes that the original finding is non-replicable, and that this must mean that it was either not trustworthy and or that the replication attempt was not trustworthy. So if there's a variance between two studies, either one is considered mistaken, at least one of them. What we suggest should happen instead is that researchers systematically search for reasons that explain the differences in the samples. Why did we find different things in two samples? Was it because, and this is mostly assumed, flawed research methods in one of the samples, or maybe problematic elaboration on a theory? So is either the theory wrong, or is it that flawed research methods were used? Or could it be that there are hidden moderators? Could it be that the findings were time sensitive, time dependent, and have changed over time between the first and the second study? or where they're context-specific, person-specific, culture-specific, and those factors differed between the two samples. That's very different from saying there were flawed research methods or their theory was wrong. And C, another option is that we were wrong. We made mistakes when we came to decisions about replicability, because it's not always straightforward to decide whether something replicated or not. What does it mean to replicate? What does it mean that a finding is sufficiently similar in a second study for it to be considered replicable? So we suggest that those different options should be considered, should be compared, and that only after comparing those different options, we know more about the replicability and the generalizability. And if I talk about A, B, and C, we have here a table that outlines more specifically what are boundary conditions that can limit the invariance across studies. So in a replication, we hope to find the same, an invariant finding across studies, but sometimes we don't. And then the question is why? And here we compiled a list of different options that can happen, that can limit the invariance, the replicability across studies. The first section in gray is all about flawed research methods. That's mostly what has been discussed since the replicability crisis was discussed. In other words, flaws in concepts, the theory crisis, lacking conceptual clarity about what exactly we want to study and what exactly is it that I try to explain, what is my estimate. Flaws in design and instruments of data collection, which has been called a measurement crisis, or flaws in the procedure of recruiting participants, measurement occasion and situations, flaws in, actually I forgot to write that down, but there's also a thing called the construct validity crisis. So there are different things in the process of translating a theory into my method and measuring the constructs that I try to infer about that can be problematic. This has been much discussed since the replicability crisis. Most of the time, we talked about small samples, underpowered samples, p-hacking, hacking, and so on. But in the meantime, there's also much debate about the theory crisis, the construct validity crisis, the measurement crisis, at least in psychology. However, there is a second set of things that can cause variance between samples, and those are what we call here the boundary conditions that cause discrepancies between an original study and a replication study, despite of both studies being as such trustworthy. So assume that everything you could do with your methods, with your theory, with your translation of the theory into measurements, imagine that all of that went state of the art and your sample is large enough. You don't do p-hacking, you don't do hacking, but still there can be a variance between one sample and the next. And the reason is that findings can be person-specific. They can be time-specific, meaning they might have changed from the first study to the second. We call it non-stationary effects. They can be context-specific. There can be statistical analysis that just simply fail to detect heterogeneity that hides behind an overall trend, which some people have called a validity crisis. I would argue it's also related to the generalizability crisis. And there might be other unknown or poorly understood boundary conditions. This has been discussed among other points in the hidden moderator debate. In other words, findings can be well described in the first study and they can be well described in the second study. So both studies as such can be trustworthy in terms of the methods really telling us what is going on in our sample. And still there's variance between the first study and the second because unknown boundary conditions are not known and they are not necessarily balanced between two different samples. And we're going to discuss why they might not be balanced. And there are two more options. In the blue section, you see logical fallacies, meaning problems that can happen in the decision-making process when I decide, was my previous finding replicated or not? Did I find something that is sufficiently similar to my previous finding or not? I can make mistakes that would be the mistake of the researcher. And finally, there is what we actually think we find when we have a failed replication attempt. That is unexplained non-replicability, meaning something that remains after we rule out flawed methods, we rule out everything that we can about boundary conditions, and we make sure that we don't make any mistakes when coming to a conclusion about replicability. And you see that there are many, many different things that can limit the invariance of a research finding across studies. And thank you for going to the next slide. We have here a slide that shows you, and if you could go down a little bit, yes, thank you, the working definitions that I'm using today. And I would like to direct your attention to the last 4 quadrants: the direct replicability, conceptual replicability, direct generalizability, and conceptual generalizability. In a nutshell, I call it replicability if new data were collected in a second study, but the boundary conditions were kept invariant, meaning we collected data in the same culture, about the same time, in the same sort of situations, in the same sort of persons. If all of those boundary conditions that I could think of are similar, but I'm dealing with new data, then I call it replicability if I have invariance across the different studies. But if I have different boundary conditions, for instance, a different time, different types of individuals, different types of contexts, then I would call that generalizability. So the difference between replicability and generalizability is, in a replication attempt, I try to really get similar data as I had in my previous study. In a generalizability attempt, I use this similar methods. I study the same research question, but I do that, for instance, in a new culture or in a new set of situations, time points, everyday life situations, etc., etc. And if we go to the next slide, I would like to make more transparent from which perspective I'm talking. I'm talking from the perspective of somebody who does a lot of intensive longitudinal studies. That means I usually deal with studies that have many measurement time points per person, more than 30 at least. That means that I can look at variance, and covariance within a person across the different measurement time points. So each person is its own sample, consisting of many different measurement time points that allow me to look at within-person correlations, effects, and etc. And I can compare within-person findings to between-person findings. And often enough, we find striking differences if we, for instance, look at correlations or factor models within persons compared to between persons. Intensive longitudinal studies typically are used to examine phenomena that are time-sensitive. That's why we do longitudinal research, that are context-sensitive and maybe person-specific. And what we have there is studies that have a diverse, multi-layered, clustered, and largely uncontrolled set of sources of variation. If we go to the next slide, this gives you an illustration. If you could please move to the next slide. Here you see one example of such multi-layered sources of variation. We have multiple situations nested in individuals. Those individuals may be nested in a classroom where we have multiple individuals with each of them have their own sets of situations and time points. But then these different classrooms can be clustered in schools, and overall in our sample, we might have different schools. And we ask people usually in everyday life, they get a beep on their phone and the phone asks them, what are you doing? How do you feel about it? And it does that 8 times a day for a week or 2. So this is the kind of data that we have. We ask people in everyday life what they are doing, how they are feeling. And that means that unlike in lab setting, we have lots of different time points, lots of different contexts. And there's a lot of variety and sources of variation that we don't control well because we want to learn about them. And that leads us to a lot of tricky questions that are particularly relevant in such studies that contain uncontrolled sources of variation in their data, but not only in such data. Such questions are, what if the effect that I'm studying changes from one study to the next? In other words, is non-stationary. That would mean that whatever I'm finding may differ between my first study and my replication attempt, but it doesn't mean that either one of those effects in either study was not well described. It just changed over time. So I might have a good estimate for the first effect in the first study. I might have a really good estimate for my effect in the second study, but they're still going to differ. So the invariance between the studies cannot be the only criterion for figuring out whether my research is trustworthy or not, which makes everything more difficult. Or what if the effect that I'm studying is dependent on an unknown context characteristic, and the frequency or the nature of these context determinants that are unknown to me differs between samples? In that case, I might also describe the effect well in either sample, and it might still differ between the first study, the original study, and my replication attempt, despite of it being well described in either study. How can I be sure to balance unknown determinants if I don't know what I'm looking for and how can I make sure to have the same set of contexts, the same set of time points, the same set of individuals, if I don't even know what exactly I'm looking for, what I have to balance across samples. The same applies to person-specific determinants. If I have different people in my different samples, some people would argue, well, random representative sampling would fix all of those problems. I would say it doesn't, but we can discuss that. And if findings can differ due to such unknown boundary conditions, and I cannot guarantee to balance them out across samples, then how can I use a failed replication attempt as evidence for lacking trustworthiness, leading to the rejection of a hypothesis or a theory? If I may have properly described the effects present in either sample, but there are systematic differences between the samples, then I would say invariance between samples can't be my only criterion to figure out whether something is trustworthy. We need to learn more about such boundary conditions or such causes of variance between samples. So how do we do that? And I would say that unknown boundary conditions have implications for our deductive theory testing strategies, that we can never rule out methodologically control all unknown sources of variation across time, context, individuals, cultures, etc., implies that a failed replication attempt may be due to the finding not being trustworthy, failed methods, or due to the effect systematically differing between two samples without me knowing exactly why, due to time, due to culture, etc., etc. For our decisions about theories and future research methods, however, this distinction is really crucial. I want to know whether previous finding was just spurious, was a method artifact because I didn't do the methods well or I didn't replicate them well enough, or if it actually was properly described in my first study and in my second study, but differed between the samples due to time, context, person, or other boundary conditions that need to be further studied. I want to disentangle flawed methods from actual boundary conditions. At the same time, we do not want to water down rigorous hypothesis testing. We do not want to allow to immunize theories against failed replications. We don't want people to say, well, there was a difference in my second study to my first, but it's probably not because I used flawed methods. It's probably because there might be some boundary conditions, but I don't know which, because we can never know everything there is about boundary conditions. We still need hard tests for our theories and for the trustworthiness. So we don't want to go beyond the insights that we have gained through the replication crisis or replicability crisis. However, the problem is that it is a known fact that many research findings are quite heterogeneous. We just start to understand that. They do systematically differ between cultures, between persons, contexts, and time points. We're just finding the right methods to start studying that. And these sources of heterogeneity have been systematically overlooked and understudied. They need to be studied more systematically, which is the point being made in the articles about the heterogeneity revolution. Leads us now to the next slide. There have been recently different publications that have suggested many different approaches for how to better gain knowledge about generalizability and how to systematically invest heterogeneity. And we have compiled an overview of such different suggestions that have been recently made. If you would like to see the overview, please go to our paper, because there are too many different approaches that have been suggested, but all of them are really useful and I think will be very useful to this conference. In a nutshell, however, or in summary, they are both deductive and inductive approaches to learning more about the boundary conditions. And deductive is not that groundbreaking, because this is what we do most of the time in social science, hypothetical deductive research. But induction, exploration, is somewhat going beyond what we usually do in our research epistemology. And here's why I think that some exploration and induction might be needed to shed more light on unknown boundary conditions. Leading to the next slide, please. Thank you very much. The traditional approach is nomothetic and deductive. We expect that one law of behavior applies to all or most individuals, and that we can learn more about that one law that applies or affects everybody by looking at an average or another trend in one-size-fits-all trend in our sample. And we start with a hypothesis and we test that hypothesis, and the hypothetical deductive falsification works really well with the nomothetic approach, because the nomothetic assumption of universal generalizability can logically be falsified and therefore be insightful to test. So this is what we usually do. However, there are other recent approaches that kind of go a little bit beyond that. And since we're running out of time, I can only give you a quick overview, but you can read the details in both the slides that you can download or our articles. If we please go to the next slide.
Andrea, let me tell you that you have 5 minutes, okay?
Yes, thank you. There are points being made within the discussion about the generalizability crisis and the heterogeneity revolution that suggest that we should systematically explore boundary conditions, including using different methods, considering sample characteristics, Due to time, I'm going to skip a few points, and we can actually go to the next slide, please. And now the next slide again. What we suggested in our article is that the traditional approach, which is the nomothetic approach, and the idiographic approach, which is the antithesis to it, can be integrated in joint approaches. For instance, it is now possible to first estimate whatever effect I want to study within each person separately, and then use different methods to figure out which of those person-specific findings that I might have found can generalize across individuals and which do not. So in other words, I first examine, for instance, a within-person effect, within-person correlation, or a treatment effect for each person separately, and then I figure out which of those patterns that I find within persons can generalize across subgroups or even the entire population and which do not. This is much more insightful methodologically than just claiming generalizability without ever examining it, or then just examining the effect in a between-person method, which may overlook a lot of heterogeneity between individuals. And in the same sense, we can come to an integration of, if we go to the next slide, nomothetic and, deductive and inductive approaches. As I said, usually in social science, we follow the deductive approach, which starts with a theory, then tests the theory. And if I can't, whatever I find is the end of my research cycle. But when it comes to understanding boundary conditions that are unknown to me, then I need a little bit of exploration, a little bit of data-driven research. I have to systematically compare what I find in different star samples, how they may have differed in boundary conditions. So some exploration is needed, and that doesn't mean that we get rid of the deductive research process. It doesn't mean that we go back to before we had it and to all the mistakes or all the logical fallacies that we might have risked to fall into before our discipline adopted the deductive approach, but instead it means that we can integrate deductive and inductive approaches. In fact, in machine learning and data science, this is done all the time by, for instance, distinguishing between the training data set, which I use to come to a conclusion, and a test data set that I afterwards use to test my hypothesis that I have created in the first step in an inductive way. So some induction may be possible if some deductive hypothesis testing follows that induction. So it's not it's not a dichotomy. I don't have to decide whether I'm a deductive researcher or whether I do just exploration. We know that both approaches have their limitations and their upsides. And if we integrate them systematically while applying the safeguards that already exist, we believe that we can learn much more about boundary conditions.
To wrap up.
And this is in fact leading me to the end. We can skip the conclusions because I started out with them. This is just a repetition. And as I said, if you want, you can read all of my points much more in detail with much more time in our article. And now I'm looking forward to the discussion. Thank you.
Okay, I don't have slides to share, so I'm just going to look across these because I don't need that much time. I really appreciated getting to read this paper. It's something that I've been thinking a lot about for a long time. And so I wanted to sort of make some connections and then sort of make an argument. The first thing that I want to connect this to are evidence clearinghouses. So I do a lot of work in the field of education, which in the US environment involves the What Works Clearinghouse, as well as a clearinghouse called Blueprints for Healthy Youth. There are other clearinghouses. There's the Cochrane Library, for example, in medicine, and the Campbell Collaboration. Oh, I'm supposed to hold this the whole time. And the EEF in England. And all of those operate in a funny way. I think that I've started to argue that they all assume homogeneity underneath everything. And you can see this in weird things that happen. So you get one study that shows a positive signal, a positive effect from a good study, and we maybe put it in the clearinghouse and we say this thing works. In some clearinghouses, they have more stringent requirements that you have 2 studies showing that something works. So then 2 studies get in. But then you end up with this perverse problem. Once you get to 3 or 4 or 5 studies, once they start showing null effects, do you take it out of the clearinghouse? What does that mean? Does that mean that we no longer give this evidence? And so I would argue that we might see this happening with most interventions as we accumulate evidence. And it becomes a real question and problem for the power of clearinghouses, because if clearinghouses are supposed to tell you what works and it's always jostling around, it doesn't look good for the stability of the information. So I wanted to just connect that because I think that's fundamentally kind of one of the problems that we're seeing here. This slide's not advancing. Okay. So I want to put that together with this just to say that the other thought that I had in reading this is I was part of a report in the US called by the National Academies of Science, Engineering, and Medicine on the future of education research recently. And in that report, one of the things that we sort of took a step back and looked at was the goal structure for how research is supposed to be conducted. And so the idea that underlying education was built upon the ideas in medicine, that you explore, that you develop interventions, then you check their efficacy, so see if they work in the ideal, and then you check their effectiveness. So again, we see homogeneity is built into that, right? That you're supposed to assume it works, in the narrow sense, and then it's going to generalize out. But what we find, first of all, is that very few people do effectiveness studies. So we're stuck at efficacy, and then the efficacy ends up in the clearinghouse. But also that they often don't make it, like they don't generalize out. So it's the idea that we were contending with there is, why are we saving this question of generalization for the end of the research and not at the beginning? So we sort of proposed in that report that we need to start with the assumption of heterogeneity in our research pipeline instead of ending with it. But the place I want to end, sort of focus my comments on, is the word disgust, because I've been trying to figure out what the right word is for what I think is going on here in some reactions that I get. I think that science may be fundamentally at odds with generalization, our definition of science. And the reaction I get from people is, when I mean, I've been talking and sort of doing this work for over a decade, is sort of, people are not happy with me when I talk about generalizability issues in a way that is emotional, which is sometimes surprising, right? So I think that in addition to this being an epistemological issue, I think this is an issue of political power. Evidence-based policy is a movement that sort of said, hey, we can do science and tell us what policy is. And I think that the dirty secret of it is that it hinges on an assumption of homogeneity, that that's the way it works. And if you don't have that assumption of homogeneity, if we start saying, oh, well, the effects might vary, it really pushes back on the power that this holds. So things I've heard people say to me are things like, well, first of all, I don't believe treatment effects vary. So why would you think that they vary? Like, show me the evidence, basically, which is impossible because we built an entire system of evidence that has sample sizes too small to show the heterogeneity. I heard somebody once say to me, we need to watch out. If we allow for heterogeneity, then people won't trust us. It's kind of an opening to the anti-science that, if we kind of admit that this is kind of thing said in a hushed tone. Another thing I've heard, we're not the same as qualitative research. That we're quantitative research, we generalize, unlike qualitative research. And the last one is a little smaller, which is really this preference for sort of simplicity in our models, right? Sort of the Occam's razor thing that, well, it has to be the most simple. Why would you assume it's more complex? It has to be simple. So I think there's something in these comments that, in these reactions, that points to, it's like you're getting at the core of an issue, that there's something that you're getting a knee-jerk reaction that makes me think that there is something in our definition of science that is off. So I'm just going to leave us there and say, I'd like us to think a little bit about, is that true of modern sciences in the natural and physical sciences? Because I think we might be reacting to a definition of science from the 19th century that the social sciences were built upon. And my guess is in the natural and physical sciences, that there is more room for heterogeneity now than there was then, but that we're not interfacing with that in the social sciences. Thank you.
Thank you so much. If I may add, I agree with everything you said, but at the same time, we see both in our society and in our science a trend towards personalization. There's personalized medicine, there's personalized learning, there's personalized advertisement. Every suggestion that you get in Netflix and Amazon is personalized. And all of that is based on the idea that things are not homogeneous. Just because everybody bought, or many people bought that bestseller, doesn't mean that you like that bestseller, because based on everything we know about you, you have different interests. And so I think it is a matter of time until social scientists realize that the trend of the day is going towards more personalization, and that our methods don't lead us there. If you assume homogeneity, you will never be able to personalize a treatment or to personalize even the diagnostics, the assessment that you need to find the right treatment for the right person at the right time. So I think there is a clash coming, and thank you very much for everything you said. I agree with everything.
Any reactions on the floor?
Thank you. I'm Jim Hammett. I was just going to comment
much of this, as you all know, has been discussed a lot in the past. And a lot of the discussion here has been, as it often is, the simple case of whether a hypothesis is true or false. But there's a different approach, of course, which is confidence intervals and point estimates. And that sort of recognizes our understanding of something at any point in time is always provisional. There's some uncertainty around it, and we revise our estimate as new data, new studies become available. But the focus on just binary testing of hypotheses tends to exaggerate the extent of disagreement when you could have different studies with overlapping confidence intervals, or even if they don't overlap, you know, the combined evidence is a broader confidence interval or something of that sort.
Was that a question or a comment? I take it as a comment. I understood it was a comment. If there was a question in it, then please repeat the question.
Well, I had another question to follow up thing. Ray, yeah, my name's Ray. So I really like this idea that there's this sort of notion of political power in science, but and then that sort of is a barrier to thinking about heterogeneity. Although I think I have this vague sense of, even in medicine, the point of departure is increasingly heterogeneity. Given the sort of new technologies, I think, at least in medicine, you have this sense that people are now thinking about personalized effects. So I think there is sort of might result in a more of an emphasis on heterogeneity.
Yeah, I think people are starting to understand that personalized treatments are necessary. Everybody who had children during the pandemic, who went to school or didn't go to school and just got one generic textbook or PDF from their teacher, has this experience that not the same instruction works for the same person at the same time. Just because you're in the fourth grade doesn't mean that you benefit from the same kind of input that other students would in the same school or in the same grade. So we know that. We know that out of our own experience. We know that in business, as I said, Amazon, Netflix, everybody's doing personalized advertisement these days because we know that people function differently. And that if you want a better effect, you better take into account what you know about individuals. So there is, and we are starting to use methods. We are starting to figure out how the between-person methods that look for overall trends actually overlook systematically a lot of people in your sample. Recently, in the within-person versus between-person debate, we even found out that the between-person methods, the analytical methods that we usually use to examine overall trends, can fail to detect and discover and describe everybody in your sample. So in other words, just because we told ourselves for a very long time that we look for overall trends that we can then use to inform policy, doesn't mean we ever did a good job. And just because we now understand our methods better, and we understand that there's more heterogeneity than we ever acknowledged and wanted to study, just because we have learned more doesn't mean we do a worse job at informing policy. I think it's a better job to say, well, this one treatment works, but it only works for people who are on average intelligent or above. It doesn't work for people who need more input from their teacher or who have social, emotional learning needs that aren't being met yet. So, and for those students, we need a different instruction, which is similarly effectful, but it's a different treatment for a different kind of student. So in other words, acknowledging that students can differ and that they might need different instruction at different time points or even at the same time point to get at the most of their potential doesn't mean we do a worse job at policy instruction and information. I think it means that we do a better job. And I think it's just going with the time to, acknowledge that heterogeneity exists, that we do have methods that can describe heterogeneity better, but we don't use those methods yet as often as we should, and we can do a better job at doing that.
So yeah, thank you, Yulia. It's we're out of time now, but really cool paper, and yeah, I want to ask you some questions later, so I'll come back to you. But yeah,
yes,
really
please.
Nice job. All right, hi everybody, welcome. For those of you who don't know me, I'm Mike Denley, and I'll be presenting a book manuscript today on external validity for social inquiry, which is joined with Mike Findley, who's here, and my other co-author, Kyosuke Kikuta, who couldn't make it today. But he's getting married this week, so I think he has a good excuse for not being here. But just sort of briefly, our goal in this book is really to take all of the work that a number of you are actually doing in this room here and to really provide a framework for us to really understand how this all fits together. So if we've forgotten to cite you or anything like that, just let us know. We're happy to cite you and really bring whatever you're doing into the fold here. So yeah, modern social science right now has been very much focused on this idea of all else being equal, which is done through randomized experiments and natural experiments. So here on the screen, you can see Banerjee, Duflo, and Kramer, who won the Economics Nobel Prize in 2019 for their work on experiments, and then Card, Angrist, and Kruger, and Immens, excuse me, who won the Nobel Prize for natural experiments in 2021. And this idea of randomization and exogenous variation through all else equal has very much been driving social science recently. And it is very, very useful for internal validity. We're not going to say it's not, but for external validity, it is often very much counterproductive and misleading. Oh. How come? How did you? Oh, okay. So thus far we're going to be having. Oh, why it's so annoying that there's, excuse me, this thing here. Okay. Anyway, so we'll keep moving on here. So as a running example, we're going to be using the Mediketa work, Mediketa 1 on information and accountability to be able to illustrate some of the points that we're making. So there was some very influential work, in particular in economics, showing that audits in Brazil affected incumbents' electoral performance. And this result was sort of based on this all else equal assumption. So what the folks led by Thad Dunning and co-authors did is they tried to test whether information affects political accountability more broadly. And the idea is that they ran experiments in all of the countries you can see in the map right here. And the idea was by running multiple experiments and thinking a little bit more about external validity, you could really see whether these results traveled. And what they found is that there's little evidence that information affects political accountability. So yeah, to be able to get to external validity, we really need to define it. And here we define external validity refers to the extent to which mechanism-based inferences from a given study sample apply to larger populations or other target populations. And here in our work, we make the distinction between generalizability and transportability. So generalizability refers to when the unit within a sample is a member of some sort of larger population, and then you're trying to make an inference from that sample back to the larger population for which the sample unit is a measure. By contrast, this contrasting approach is transportability, and the idea here is that maybe the units in the sample aren't part of the population for which you're trying to make an inference, and in particular, field experiments, which are generally considered the gold standard for causal inference, tend to generally make transportability inferences, and that's particularly the case because often these units are not within the sample. So as far as we see it in terms of generalizability and transportability, there are 4 existing approaches to external validity inferences. So in a single study, when it's trying to do generalizability, the modal approach is random sampling. And I have random in parentheses here is because this is not always the case where you actually have a random sample of the population for which you're trying to make an inference. And when you're also doing a single study here, and you're trying to do a transportability inference, a lot of this involves just some sort of projection, and most of this happens in a post hoc way. Now, once studies are looking at multiple samples or studies, often there's meta-analysis, and that usually happens within generalizability, but admittedly, it can also happen within the context of transportability too. And then finally is this idea of purposive synthesis, like the metacata that we talked about just a minute ago. All right, so but random sampling, one of the issues here is that random sampling mostly neglects heterogeneity. And this projection always sort of happens post hoc. It's thinking about external validity after we've done our study as opposed to before. And meta-analyses, while it can be very useful, often relies, or it definitely relies on the universe of studies or samples available. And usually we need to have replication files for that to happen, which is another problem here. And the purpose of synthesis, like the Metacata 1, and I want to emphasize here, Metacata 1 was really a great study. It still uses convenience samples within the actual countries. So the way that we're doing science, every single way is affected by external validity. So we want to really sort of focus the discussion of external validity about mechanisms. So, and why do we focus on mechanisms? Because, so some of you might be familiar with this UTOS framework, units, treatments, outcomes, and settings. The idea here is that in our ARPS article in 2021, we added a fifth dimension to external validity, which was time. And I think Yulia made a very strong point in the earlier presentation that time really matters for a lot of these effects in terms of context dependence. But the only one of these dimensions that actually travels across all of these different settings, treatments, outcomes, units, and time, we refer to this as MSTOUT, is the mechanism. So I think that this really has to be the basis for our inferences going forward. And a lot of statistical work in particular is really focusing these stout dimensions over mechanisms, and we want to reorient the discussion in another way. Now, the above was kind of a simplified presentation of these MSTOUT, of these settings, of these stout dimensions, including mechanisms. But in reality, the problem is that these happen at different levels of analysis. So there's a theoretical population of interest, and from that theoretical population, you usually have some accessible population, and only from that accessible population, you can sample from it. And then in particular, let's just give the example of a field experiment, often you have some sort of planned sample, but you also have an actual sample. So oftentimes in field experiments, they're plagued by attrition, non-compliance, and spillover, and this is altering the sample from which you actually plan to do your analysis. This also happens in observational work with missing data, etc. So in this book, we really try to make the distinction that these MSTOUT dimensions are actually happening across different levels of analysis. And then finally, on the left-hand side of the screen, at least my left, I guess it's your right, I guess your left as well, is this idea of the target population. So oftentimes a lot of inferences are made back to some target population, and this is based on the actual sample, which may have attrition, non-compliance, or spillover. And there's some really nice work by Daniel Westreich and colleagues showing that the actual samples that we're analyzing very rarely correspond to these target populations of interest, but nevertheless, we keep on making these external validity inferences. So we want to get people thinking about these different levels of analysis here. So also in our work, we show some of these biases mathematically. So whenever we're looking to make some sort of generalizability inference, we're usually looking at the population average treatment effect versus a transportability inference, we're usually looking at the target average treatment effect. And whenever we make some sort of estimate, it's usually this PAT or TATE plus some sort of bias. Now, I'm guessing many of you in the room will be very familiar with these internal validity biases that have been around for a long time about assignment selection bias, which can be overcome with randomization, and then also treatment effect heterogeneity. What we want to get people thinking about are these external validity biases relating to sample selection as well as variable selection. So sample selection could be, for instance, if I don't have a random sample of the population for which I'm trying to make the inference, that could be one form of sample selection bias. And then in terms of variable selection bias, there could be all sorts of measurement issues, including construct validity type issues. I see Jörg Peters over there who's going to be talking about this later today. So yeah, these are all within the realm of how we conceptualize biases from internal, external validity. And usually most studies, even if they don't talk about external validity in particular, they're going to be making some sort of externally valid inference. So we need to actually think about these. All right. Not so easy. All right. So our evaluative framework for external validity is based on 3 dimensions: model utility, scope plausibility, and specification credibility. So I'll define these in a second, but basically what I want to make the case here is that all of these can have different levels within individual studies. Maybe some studies are very strong on model utility, but maybe a little bit less on scope plausibility. And this triangle here really captures this strong dimension that you need to really have all 3 to make a very strong external validity inference. But that doesn't necessarily mean that even if you don't maximize on all 3 of these criteria, that the inference or the study is not worth undertaking. We just need to report on it accurately. So in terms of model utility, for us, a useful model captures mechanisms, their causal structure, and their levels of abstraction. So we make this point about mechanisms here because most existing research nowadays is really focused on research design, treatment effects, and point estimates or specific empirical findings. And I think Julia made a very strong point in the last presentation that there are boundary conditions to all of these issues, and we really shouldn't be focusing only on point estimates, which may not be have some sort of generalizability inference or a clear transportability inference. And I want to mention here, there's some new work by Aaron Hartman and Naoki, which looks about how to generalize inferences under some very, very strong assumptions. And I think we should use these, but we should be careful when we use these, because maybe when we're just thinking about, oh, does this translate, then we're not actually thinking about the mechanisms that really facilitate these types of inferences in the first place. So causal structure. So we want all studies to think about causal structure. And the extent to which X, our independent variable, is going to cause our dependent variable always depends on these support factors. So, and here I'm echoing Nancy Cartwright, and you could think of support factors, for instance, in economics. A lot of work from Acemoglu and Robinson, for instance, has talked about how you need some institutions to be able to have some effects to be able to translate. I mean, it's the same idea with these support factors here. And we really want to have people thinking about these support factors in terms of mechanisms, as opposed to just approaching the problem statistically through our stout dimensions, these settings, treatments, outcomes, units, and time. So abstraction. So here I'm going to repeat the diagram that I had earlier. Basically, there are different levels of analysis that we need to look at whenever we're making our studies. And to be able to just say that, oh, I have like a very low level variable that's measured in one little space. And it's often a big assumption to assume that that abstracts way back up to theory. So a quote here from Nancy Cartwright: a mechanism seldom operates on its own. We sometimes pretend they do when trying to describe their natural outcomes, but that makes no sense. Mechanisms don't operate in some kind of platonic heaven all by themselves. They operate in real settings, and in real settings, other things have influence as well. And I think one point that we really want to make here, especially because our presentation has been very much empirical going forward, is that many theoretical models, including equilibrium selection models such as game theory or structural inference, tell you to make the simplest model of the world and then just assume that because you've made all else equal, it's going to translate upwards. And we think that that idea needs a little bit of revision. And there's some really nice work on this, this area from Annie Liang and co-authors that's really looking about this. So here, going back to our running example of Medicata 1 and this heterogeneous causal structure, what are these conditions that we need for information campaigns to be able to affect political accountability? Well, you need some sort of salient information about performance to exist. And that's often reliant on having a free media or an NGO to be able to facilitate this information. We need some sort of educated or literate population to be able to process the information. And we also need people to be able to vote or protest, to be able to express their political preferences. And often in authoritarian regimes, we don't have that. And then we also need to have people free from poverty, because otherwise they're going to discount the future a lot, and they're just going to be subject to these clientelistic handouts and be bought off. So here we have a very simplified version of a directed acyclic graph, a DAG. And these are the steps that voters would take in order to potentially have this information translate into some sort of voting outcome. But the challenge is that the information is a selected form of information. That's what this selection node is. That's what the box with the S is on the top of it. And then whether voters actually update their priors is going to be dependent, again, on some sort of selection process. Maybe people have some sort of partisan leaning, so they're willing to let the incumbent get away with some bad performance. And there could be all sorts of additional moderators going on here that could affect our causal structure. And then in addition, whether people actually vote is also selected, right? You could think just in terms of regime type. So, so next we want to get into our next criterion, which is scope plausibility, which refers to the extent to which samples or population reflect the mechanism's operation, including in Stout selection and potentially weighting and bounding. So with respect to the target of inquiry, we really want to characterize these targets, not just declare them, but characterize them in terms of their theoretical and accessible populations. For all Stout, we want to look at whether the goal is generalizability or transportability, and then we want to look at the estimate. So the estimate is a really important thing that's very much been neglected in this causal inference revolution, where you have, for instance, some sort of instrumental variable that's looking at some sort of local average treatment effect, or for instance, some sort of RDD, or even some of the diff and diff that's only looking at an average treatment effect on the treated. It's really not even applying to this whole sample that you have in the first place. So, so yeah, we really want to focus attention on these issues, and we need to make sure that our population average treatment effect is really focusing on the sample in some way. So we also need to focus on selection, and we need to make sure that they really correspond to the causal structure and not just only looking at random sampling. So so yeah, we need to make sure that our sampling is thinking about structure. There's also sort of shielding concerns. So if I design a field experiment, maybe the funders are only willing to finance certain areas, or maybe some areas of a country are not accessible via the road network. There could be all sorts of things that go into the decision about which sample you select. I spoke earlier about planned and actual samples due to attrition, non-compliance, and spillover. But one thing that actually we really want to focus people's attention on is case selection. So if I choose, I don't know, Uganda instead of the US, basically what we're trying to say is that these monocausal approaches to everything are very much subject to a lot of caveats. In terms of weighting, we want to have some sort of pre-specified weighting to achieve better correspondence on Stout, settings, treatments, outcomes, units, and time. within thinking all the while about this causal structure and the theoretical population. So there's quite some adjustment methods. You could talk about inverse propensity weighting from a covariate approach, or inverse propensity scores. You could talk about model-based adjustments such as outcome regression, or some combined approaches such as doubly robust or multi-level regression with post-stratification. But even more broadly than these methods, we want people to think about weighting ahead of time. So yeah, this is going to be very important to ensure that there's no sort of weighting hacking or EV harking, whatever you want to call it. And then finally, in terms of bounding, we want to generate bounds in our inferences to really test the mechanism's generalizability and transportability across these different stouts. And you could do sensitivity analysis, you could do partial identification, any sort of sign generalizability exercises to look at this. So here we're going to go back to our metadata again. We have the selection of countries in our sample. So what we did is we looked at these 5 characteristics of causal structure, or 4 characteristics of causal structure, and then we plotted to see where all of these countries were on in terms of getting data from the Varieties of Democracy project or the World Development Indicators. And you can see that the coverage of these countries across the different distributions in the world in terms of information or participatory democracy or GDP per capita or secondary schooling outcomes often has some holes. So I think even in this really well done study of the Metadata 1, we need to be concerned about some of these causal structure points and how we're selecting our countries. So I'll move on now to the final criterion, which is specification credibility. And this refers to the extent to which theoretical and empirical correspondence is achieved, including through stout exclusion and attention to credible learning. So what do we mean by theoretical correspondence? We want to really figure out whether the mechanisms that we're looking at really match in terms of just relying on the similarity of stout conditions. And again, we have some tools at our availability. So I went over directed acyclic graph earlier. There's also these causal cakes or causal pies from Nancy Cartwright. Often game theory or structural inference or agent-based models can help us think about these things as well. But obviously, a lot of the work in the social science happens through informal frameworks too. And whenever these informal frameworks are in place, we really want to make sure that they are focusing on mechanisms. So again, in terms of empirical correspondence, we're thinking about mechanistic similarity. And here, really, really important, something that I guess Jörg will talk about later is construct validity. We really want to make sure that we're measuring the concepts that we think we're measuring. And one thing that we'd advocate for, and this is happening to some degree in social science, is that every paper try to assess mechanisms as well. It's not going to be enough to just look at treatment effects and assume that we have perfectly measured everything. We really want to make sure that every social science paper is trying to find some mechanistic evidence as well. So finally, or I guess I have 2 more. So we want to develop some sort of stout exclusion strategy to isolate the role of one of these settings, treatments, outcomes, units, and time, and see if things change. So you could do this via non-random holdout samples, some sort of synthesis, such as the Metadata, right? Because it was keeping the treatment and the outcome consistent across time, and then it was just varying the setting. So, and then you can obviously achieve this with some sort of robustness analysis too. Robustness definitely still has a place here. Then finally, we want to focus everybody's attention on learning. So learning requires a falsifiable model of updating free from this post hoc EV harking about the external validity targets of inquiry. So one sort of main point here that we want to make is that external validity is not binary. It's not that one study has external validity versus another. They're all going to have different degrees of external validity. So going back to our Metadata here, they have approached the Metadata through a Bayesian multi-level model. And the idea here is that once you have some sort of sample and then you keep adding information to it, you're gradually going to be able to come closer to the true estimate, and you'll be relying less on the prior each time. But that assumes that you have selected cases in the first place that are going to preserve that causal structure that you're trying to get at. So, so yeah, here's just a recap of our evaluative criteria. And yeah, one thing, one thing that we're doing in this book as well is we're not just giving you the criteria and then saying, oh, implement it yourself, try to figure out how this applies to your experiment or your natural experiment or your qualitative method or your meta-analysis. We're going through each one of the criteria and then showing you how to apply it for all types of experiments, whether it's field, survey, or lab, natural experiments, RDD, IV, standard natural, quantitative observational. I mean, we're going to deal with the regular regression model-based, but also some of the other ones like matching. So every time we're going to be able to tell you exactly how to implement our criteria in every single method. And here we have like a form of a consort diagram and some things to be able to help you as you move along and try to design more externally valid studies. So from the top, what is your population? Are you looking at generalizability or transportability? What is your estimate? But yeah, I mean, you can sort of read a little bit on the screen here, but I think these are the questions that we should be asking ourselves no matter what study we're running. And in terms of conclusion, we show this a little bit more in our ARPS paper and in the book, but the biases from external validity may be just as important as those from internal validity. And I think Julia made this point very well in her last presentation. And one thing that I think we should really be thinking about is, yes, we should try to strive for this all else equal to the extent that we can and integrate experiments and natural experiments. It's not that we're saying that like experiments and natural experiments are not useful. They definitely are. But there's going to be a lot of instances in which we only enjoy some sort of partial identification of the causal effect. And I think we should be open to learning from those situations as opposed to saying, oh, I don't have a perfect randomized experiment. And then let's just not even research the question. Again, to iterate from above, we need to always think about the mechanisms that we're analyzing in all of our studies. And then we need to be able to test those, in particular in empirical work. And we're also quite worried about what we call type 1 and type 2 errors. So type 1 is a false positive, right? This would be an issue primarily for field experiments. In particular, sorry, I'm picking on the field experiments, but often you have some sort of monocausal relationship, and then you have random assignment of your independent and variable of interest. So people just assume that this effect is going to transfer, and that's not going to be the case a lot. But actually, an even bigger problem is going to be type 2 errors. So, so we're worried about the instances in which studies don't even talk about external validity at all, even though they could actually have some. And hopefully we would hope that people are using our model utility, scope plausibility, and specification credibility criteria to be able to think about those. And yeah, it's like a main point here to really build on the last point about type 2 errors is we want to make sure that every study is really talking about external validity in some way or another, because otherwise it's just going to be more of the same. We're going to be learning less from studies than we should. So, so yeah, that's what I have for today, and definitely welcome any thoughts or questions.
Hi, everyone. My name is Anna Wilke. I'm the discussant in this panel. Well, first of all, thank you so much to the organizers of the conference. This is a really cool thing to be part of. And then thank you so much for giving me the chance to read this very interesting book and to offer some reflection. So there will be a book workshop tomorrow where we will talk about things in more detail, but I will give sort of an overview now. So there's a lot going on in this book. So the first thing I'll do is I'll give you sort of my take on what I took to be the main elements of the book. And then I'll just give you sort of 3 high-level reflections that came to mind while reading it. So in this book, you first define external validity and give us sort of a new definition, where the idea is that something is externally valid if there is a mechanism that produces a treatment effect in one context, and that mechanism is also operative in another target context. And context here is defined by setting, treatment, outcome unit, and the point in time. So I want to highlight that there are sort of 2 new things in this, right? So one is you're shifting away from treatment effect estimates to specifically estimates of indirect effects or mechanisms, and then you're adding point in time to the usual dimensions that we are looking at in terms of external validity. Then you're giving us a definition of two different kinds of external validity that differ in terms of how the context that we are studying relates to the context that we're interested in ultimately. And so you're calling generalizability a situation in which we have a sample drawn from the target population, and transportability a situation in which we don't have that. Now, this is not exactly how you describe it in the book, but I think another way perhaps to think about this is the first one is a situation in which we have a design basis for inference, and the second one is one in which we have to rely on model-based inferences. And then you're giving us three criteria to evaluate studies in terms of their ability to generate externally valid inferences, though you're also using that later on to evaluate sort of methods in terms of their ability to generate external validity, so field experiments, lab experiments, observational studies, etc. I won't go through these in so much detail since you have explained them just 2 seconds ago, but the idea, as I took it from it, is model utility sort of refers to how helpful the underlying theory is in terms of assessing or predicting the operation of mechanisms in the target context outside the context where we conducted the study. Scope plausibility asks, well, does the paper actually define a target context, and what was the study context selected to facilitate inferences towards this target context? And then specification credibility is sort of about whether the empirical design more broadly, apart from sample selection, facilitates inference about the theoretical target. And finally, you use these criteria to think through the external validity challenges that arise in different kinds of studies, observational ones, experimental ones, and how these can be addressed. So there are lots of things to like about this book. I'll just highlight 3 of them. So first of all, I really like that you take cross-context heterogeneity as something that's important and worth studying, rather than just sort of a nuisance to our ability to say that something is externally valid. So I think that's a really good starting point. And it's also nice to see such a serious engagement with external validity dimensions other than units and settings, which I think is what we typically think about when we talk about external validity, or most people would have something about that, or at least some conjectures in their papers, but in terms of outcomes, treatments, and so on, we see less of that. And then finally, you offer us quite a rich characterization of the limitations of different kinds of designs in terms of generalizability. Okay, now 3 thoughts on 3 things that the book made me think about. So the first one concerns the role of theory. So I would say perhaps the main theme of the book, as I read it, was that causal models, theories, mechanisms are really central to externally valid inferences. And so I think you could do a little more in the book to characterize the specific roles that theory can play. And so I think there are basically 2. The first one is we can condition on the model and use the model to transport results to a different setting, kind of in the spirit of the Pearl and Bereienbaum framework, right? So we have a model of how we think that effects or mechanisms operate across these different contextual dimensions. We do a study in one context, we transport the results. And so the difficult question, of course, is what if the model is wrong? Well, if the model is wrong, then likely our inferences will be wrong also, right? Now, the second way in which theory comes in a lot of the applications that you discuss is that we want to learn about the model that we are using. So we want to learn about whether the theory that we have about how context conditions, treatment effects, or the operation of these different mechanisms vary across how these different contextual dimensions affect how the mechanism operates or how treatment effects work. And so there are lots of examples in your book about how we can leverage variations in context, either within our studies or across different studies, to learn about these causal models. But of course, the challenge here is dimensionality, right? We will never be able to study all contexts. And so the question becomes, which ones do we select to study, and how do we make sure that they are probative for our model? And so I think one thing you could do in the book is distinguish a little bit more clearly about these across these 2 dimensions of how to use theory. So treating it, conditioning on the model, or learning about the model, to give some guidance on how we can do perhaps both of these things at the same time, or how we do balance the concerns that both of these ways of using theory raise. So that's the first point. The second point, is about this switch towards mechanisms as central to our external validity inferences. And so I think the challenge here is that we know pretty well of how to estimate average effects in a given place, right? But we have big trouble identifying indirect effects or mechanisms even in a single context, right? And so I think in that sense, your definition of external validity is quite demanding because it asks us to switch our attention to a quantity for which we have quite limited internal validity. And so I have sort of two questions that I would like to hear a little bit more about. One is, if we do focus so much on indirect effects, what is the role of average treatment effect estimates in this framework? What remains to be the role for that? And sort of the conclusion from that, I think, would be, as scholars who study external validity, we should really study mediation, right? So we should pay much more attention to designs that can identify mechanisms. And maybe this is a good conclusion, but it would be interesting to hear whether this is sort of one of the main take-home messages that you intend the book to have. Last point, what is the relationship between internal and external validity? So you have this perhaps a little bit provocative statement in the book that says there's no a priori reason to believe that internal validity is more important than external validity. And so I'm guessing you will receive some pushback against the statement, perhaps even including from the people in this room who probably are most interested in external validity among sort of the scholarly community. And so I'm not so sure that you're sort of winning by pitching these two things against each other so much. So it's certainly the case that some of the examples that you discuss in the book highlight a trade-off between internal and external validity. So for example, if we design an observational study, maybe we can just condition on covariates, and that gives us a really big sample size, or we could use an RD design that limits the effect to some area around the cutoff. And maybe we believe the RD designs assumptions more in terms of identification, but it's more local, the effect that we estimate. But that's not necessarily always the case. So you actually discuss many examples where there's no trade-off between internal and external validity, right? So one of them is attrition in experiments, where likely we want no attrition for both internal and external validity reasons. And so I think instead of pitching these two against each other so much, which will give you pushback, you could focus more on where do we see these trade-offs, where do we not see these trade-offs, and how do we deal with that? And so finally, also in terms of your focus on mechanisms and learning about them, right? If we want to do that, if we want to test our theories about how contextual factors affect treatment effects or the operation of the mechanism, then likely we want our tests of these theories to also be internally valid, right? And so from that perspective, I think internal validity really helps us learn about external validity as well. And so I think conceptualizing these as complements rather than substitutes could be a winning way to go. Thank you so much, though, for giving me the chance to read this.
Thanks so much, Anna.
Mike, do you have any preference, or I don't know? I mean, I feel like we can open the floor.
I think we should
Yeah.
really open the floor.
Yeah.
Anyone has a comment or a question?
Thank you. Those are really interesting talks. And I find it a really interesting point that you touched on about external validity. It's not black and white. It's definitely a continuum to which the results are valid. It's a bit of a misnomer in itself that if something is valid or not. And that Anna's raised that issue of oh my God, gone blank. About this trade-off. And I was just interested to ask, is internal validity not a prerequisite to external validity? If we're focusing on mechanism, that directionality of that effect has to be internally valid before we say anything about its external validity.
Questions? I don't know. I mean, I'm happy to answer. Do you want me to answer now or collect more questions? Okay. Yeah, I'll just answer now then and say that I think internal validity helps with external validity. I'm not quite sure that it's a prerequisite though, because we might, like as I try to make the point, there might be causal structure points, and maybe there's some sort of internally valid study that's on a very selected sample, and we haven't really thought through our causal structure and all of these selection nodes that can really happen. So I wouldn't say it's a prerequisite. I would say most of the time, social scientists are designing studies carefully, and they try to think about these things to at least some extent. So I would say internal validity helps most of the time. I would prefer an internally valid study. And then also, I think we should be engaging in this identification, even if we can't be 100% certain about having a causal effect. So yeah.
Yeah, thanks, Mike. So yeah, I mean, this really sounds like a book that at least the social sciences have been waiting for, or should be waiting for, actually. So I have a question. I'm going to frame it as an either/or question, but you're free to give a more nuanced answer. I think it's so the framework sounds excellent, but it also sounds like a megalomaniac endeavor, basically to basically live up to what you are asking for. So my question is, do you think that's the one either? Do you think this will only lead to a humbler presentation of results? So will it make people humbler if they basically account for your framework? Or is there actually a way to live up to that standard, right? So do you believe the methods, so the epistemology we are currently using can actually picture the heterogeneity in this world or not, right?
Yeah, really, really awesome question. I think yes to both. I think that we do need to be a bit more humble in terms of, for instance, saying that things are monocausal. They're really not. And I think Beth's work in particular has really helped us understand that quite a lot, and many others in this room. But I do think that we have the toolkit necessary to be able to analyze mechanisms. Maybe sometimes some of these indirect mediation effects that Anna is talking about are a little bit more difficult to estimate. But I think that we can really try to think about these things even qualitatively if we have to. And then we can also make ourselves a directed acyclic graph, or we can even just list. We don't even have to, if you're not familiar with the DAG methodology, you can just list like, hey, if like information is going to affect political accountability, we need to make sure that people can vote. I mean, I don't think you even need to make a graph for that. So yeah, I mean, I think we do need to be a little bit more humble, but I do think that we have the toolkit, thanks a lot to the people in this room, to be able to address that. So
can I just respond as well real quick? Sorry, am I good? Or do I?
Yeah, go for it.
Oh, sorry. I just want to respond to Jörg real fast. So on this, I mean, my sense is that like a lot of studies are doing most of what we have in this evaluative criteria, just not explicitly and not like in any sort of like disciplined way or accountable way, right? So, I mean, studies always talk about selection, right? I mean, you look at like the Medicata, it's fantastic in so many ways, right? But it's like littered with like these, you know, just sort of comments about possible moderators here or there, right? But never sort of listing them, never sort of saying where they go. I think the only sort of core ones that show up in the causal framework are like existence of information, right? And then like an updating process, right? But like a whole bunch of other things kind of show up all over the place. But just not in sort of like a disciplined way, right? So I think a lot of what we're saying that people are sort of doing, but we want to push people to say, like, actually tell us, like, is this core to the structure that's gonna, you know, that needs to transfer in some way, or is it not, right? I mean, and I guess some of it goes to like, are we learning about this inductively or deductively, right? But unless we start pushing ourselves to be more disciplined on these things and how we deal with them all, I think it's just gonna be really tough to like make progress, right? So I don't know. So I think it's doable, but we just got to like give it more attention.
Thanks, Mike. Yeah, Beth.
Yeah, so I was thinking at first, I've had sort of dueling thoughts. One was, oh, wow, it seems like this will never know anything, right? So I always worry about this, that when people have started going down paths of replication studies, that we could study the same intervention from now until the end of time and never know, right? If we feel like we need to study it in every possible place. But I don't think that's what you're calling for. I think you're calling for people being strategic and thoughtful about where, you know, the design points, you know, we have all of these spaces, which points do we need to study carefully? And so as I was starting to feel a little overwhelmed, I was reminded that, you know, I do work in meta-analysis, and meta-analyses are increasingly large, that you'll have 100 studies on a topic, and it's kind of anarchy. Like, we hope that those 100 studies are somehow going to cover those design points and fill in a theory for us. And they may not. In fact, most of the time they don't provide the information necessary to even know if you were covering the sort of space of all the possible studies out there. And so to me, this becomes a question of coordination, of how do we coordinate our research across research teams in ways that test theories, so that, yeah, in my study, I can only do part of that, but in 10 studies or 50 studies, we could collectively actually really be testing a theory and a mechanism, but what are the sort of necessary conditions to make that happen? How do you coordinate across studies? Some of that may be reporting, some of that may be syntheses that are not just collecting study information, but are sort of thinking through the general theory and which things have been tested and which parts of that theory have not been tested. So that we have a sense of what the end is, like when do we know, when would we know enough, or what are the things that we would need to know to really feel like we understood these boundary conditions?
I mean, I can just say I'm full agreement. I take all the points. Anybody else, or we're out? Okay, we're out of time. So thanks a lot, everybody, for your really thoughtful comments. She will.
Okay. Yeah. So what we do in this paper is we review the microfinance literature, and for sure we are not the first to do this. I'm going to refer to this in a second. We focus on RCTs published between 2010 and 2021, and we do this to better understand empirically, actually, how important construct validity is for generalization. So the review is based on 36 RCTs, and we use these 36 RCTs to conservatively, we argue, identify 19 design elements that are constitutional, basically, for what microfinance is in the literature. And as an intermediate result, if you combine these, or if you calculate the combinations that are theoretically possible from these 19 design elements, you end up with 524,000 possible combinations. Of course, we don't argue that the world is that complex, but I do think it's interesting to basically visualize this number, if you will, to kind of feel and sense how important construct validity is. But we do also demonstrate that even if you are a lot more conservative than this, and just take the design variations that you find in literature, that you can already constitute that the implications these design variations have for the results are very consequential. So even just looking at this limited number of design elements. And then in the next step, we also show that most papers in our review do not provide enough information to assess construct validity. And yet, no surprise, most nevertheless do generalize their results in their conclusion or even in the abstract beyond the construct that they are actually studying. Yeah, so why microfinance? One simple reason is it's certainly the flagship topic of the RCT movement. Also, Esther Duflo referred to it in her Nobel laureate speech. And it's certainly a literature that is very rich in RCTs, which is good for our purpose. There was a recent review, that's 2021 in VoxDev, which is something like the clearinghouse, or you might argue that it's written by people who are the clearinghouse of our profession. And there was an update actually in 2023. And by the way, in this literature review, there are quite a few things that I will raise in this paper also appear, but I will try to argue why we are making a different case in this particular project. So yeah, where if not in this literature should the pointillist painting actually appear or take shape? And of course, as some of you will also know, there was also a very influential special issue in the American Economic Journal, Applied Economics, that bundled, I think not the first six, but very early, few of the very early RCTs in that area, and it claimed, I would say, external validity to a very far extent. but it has also been hotly debated, not least with regards to external validity. Sorry. So the reason for why we study microfinance is it's a very deep literature with many RCTs, but it's also very controversial. By the way, I'm happy to take, I think I agree with Sylvain on many things, but I'm happy to take questions if you like to intervene. Yeah, as I said, there has been quite some controversy around this this AEJ special issue, and of course also already a few very important meta-analyses of the results, among others by Eva, who is also in the room. And these meta-analyses, I think your paper has, I don't know, I know that your paper did not focus on microfinance, but it also covered microfinance. And there's Rachel Meager's work, which focused on microfinance. And I think so the first package of papers on the top of the slide basically criticized the AEJ special issue for not being externally valid. The second package is a bit more, let's say, complex. I think Rachel's work concludes that the initial findings were pretty externally valid. Eva's results are a bit more skeptical. Both meta-analyses also included, at least implicitly and to a certain extent also explicitly, construct validity, but they do not make this point very strongly. So our purpose here to, if you will, to push further is to really show how important, on top of external validity, also the design of the treatment, so the construct validity actually is in this literature. So here's what we do. So we try to review literature systematically. It's not a hardcore systematic review. So we start from the VoxDev literature review in 2021. We added a few papers that we believe are also very well known, and did some backward snowballing using these papers. So it's not, so at least at this point, it's not, I would say, a hardcore systematic review. We will try to make it a hardcore one in the next couple of weeks. We don't expect the results, the outcome of this review to change a lot. In any case, I think it's fair to say that the sample we have already covers the very influential or the highly influential part of that literature. There is certainly a lot more out there if you don't focus on RCTs. But even if you include RCTs, we believe there's not much more. But the part that we are covering here is the most influential one if you look at author affiliation or journal ranking. So that's basically what is shaping the prior in the literature in terms of knowledge about microfinance impacts. So in part one of the review, we try to let the literature speak. So basically let the authors of those studies tell us what they believe, which design elements matter for the construct microfinance, right? So we do this by looking at those studies that vary. That's a slightly complicated little matrix. So we do this by first looking at which design elements are varied in studies. Like, a certain study might extend the grace period or the interest rate or whatever, like these typical classical design elements you might come up with are varied randomly in certain studies. So that makes a design element in our definition. And if there's no design variation in the study itself, we look at the feature that the paper makes most salient in its title or abstract. That's more or less what we do. And of course, there's a lot more if you are less conservative than that. There's a lot more if you really look into the papers. They do emphasize design elements somewhere, or they do not emphasize them, but they mention them somewhere in the paper. And you would easily you could easily inflate the number of design elements that we find. So by doing this, we find, I think, 56 or so, and some of them overlap, of course. So we have 19 in total, 19 design elements that do not overlap, And this is just to give you an overview of what we're talking about. So these are loan features, of course, lender features, also borrower features. And this very right column here is certainly the shade, the blurred area between construct validity and external validity. We believe you can argue that these features over here determine what the construct microfinance is constituted by. So loan features and lender features. And it's the same result still, now in different visualization. So these purple dots are the different design elements we found in literature using that conservative methodology. And this is now just to visualize like how this easily fans out as you use different variations that these design features can basically take. And this, of course, does not stop at the first layer, so you can easily really fan this out into a myriad of design elements. So in here we try to we do more than this. This is now to show how important, how consequential actually the design elements are. So to show that the impact of the construct microfinance changes a lot depending on how you basically build the construct. And these are studies that vary the loan type basically by one or several design elements. And just to show that even these you might say subtle changes in the construct lead to very severe or to severely different treatment effects, right? And all of this, so all these studies are of course happening in the same context. So they randomly change the design element in the same context. So this is basically ruling out that external validity here is driving the results. So the difference in results here are arguably driven by construct validity. Related dimensions, you might say. So in part two, we go a step further and now assess each paper as ourselves. And now we do this with respect to researcher involvement, arguably also one dimension of construct validity. And yes, of course. Yes.
Exactly okay, sorry. Are you saying if I take two studies that have the same construct design, so they have flex repayment, collateral, and maybe group lending features, one in Bangladesh and one in Senegal, the only difference is actually is due to the context, to the external validity on the environment?
Right. Actually, I mean, this point has been made and is very important, right? So of course, the same construct, totally the same construct might have obviously different effects in Senegal versus Western Kenya, right? That's external validity. So here we do not change the literature of these papers do not change the context. Yeah, so they are operating in the same context, same country, same region, right? So within the same RCT, basically.
Okay, so you're doing within RCT's comparison of construct design.
Yes, exactly. That's it. It's nothing more than this. So these studies change the design of the construct.
So you're adding group lending to a treatment arm?
For example, yes.
Okay.
Yes.
And again, are we assuming if we do this in Senegal, it will give you the same result if we do it in Bangladesh?
Exactly. So of course. So this comes on top, right? So the fact that changing whatever group lending scheme you do in Senegal vis-a-vis India, some region in India, of course, also leads to changes, right? But even not changing the context leads to changes of the results.
Can I just follow up too and say, you keep saying that it's attributable to the treatment construct, right? So, but it could be the outcome construct as well, right? Because like some of these, flex repayment, those first 4 times, they have different outcomes and in some cases different results, which would hold constant the treatment, right?
I think yes, of course, in general, that's true as well. But here we hold, I mean, they hold constant the outcome as well. So they look at the same outcome for different design variations. right?
Mm-hmm.
I think it's much more trivial. Probably I presented it in a too complex manner, right? It's much more trivial than you currently think. I think so. These papers there are just RCTs that randomly varied the construct, the design element. That's all. Yeah.
So if I am to understand the first line says this is the impact of high repayment frequency versus low repayment frequency.
Yes, totally. That's it. So in the paper, we will try to make this argument, or to basically look at the argument from different additional perspectives, also to convey that even simple and nuanced design variations matter. That's all, right? And I guess one criticism we will for sure get for this is that it's trivial, right? It's certainly a trivial point, but so is much of externality we were discussing over coffee earlier. So many, or the vast majority of people out there wouldn't argue with anybody claiming that externality matters. So I believe the mission of this paper is to make this more salient, right? To raise awareness for how important it is, and hence to argue that it should be made more salient. Maybe that's the right way to put it. It should be made more salient in our work, right? So part 2 now. So now we look at a further dimension. So far that we let literature speak. So we let basically authors decide which design elements they believe matter, and also let their results speak. We now also look at researcher involvement as an additional feature of construct validity, and then also assess to what extent the papers we reviewed generalize. So we argue that researcher involvement itself is also a hazard to construct validity, or relevant to construct validity, you might say. So treatments, I believe treatments in RCTs, and that's now a term that Mike and Mike coined in their paper, not the book, the paper. Many RCTs lack mundane realism, so they do not basically reflect what real-world interventions look like or would look like. And this is certainly something to think about further. And this, I believe, the whole discussion about external and construct validity is trying to push for, right? In the RCT toolkit that Esther Duflo and others published in 2007, they referred to this as special care in treatment provision as one part of external validity. And it's true that here again, the demarcation is not totally clear whether researcher involvement is actually a problem related to external validity or construct validity. We argue that to the extent it becomes part of the treatment, like basically researchers engage with how the treatment is being delivered, how effective it's being delivered. I don't know which extension workers are being hired, you know, and how they are trained. Like all this can be affected by the presence of international researchers in an RCT. And we argue that this can then also be considered or arguably be considered as a part of construct validity, and hence it's a separate design element. So to ponder this further, we now look at how the RCTs, the published RCTs, deal with this. So first of all, the question of, that's just a filter question, is the intervention that is being studied, the microfinance intervention, is it an existing intervention? That's a yes for 10 papers out of the 36, and a no or a kind of no for the rest. So for the majority of papers, the researchers were basically engaged in developing a new intervention, and then we asked whether. So we asked the paper basically in the review whether whether it makes clear to what extent researchers got involved in the design of this new intervention, and in many cases, it's simply not clear. So the papers do not really talk about the extent to which they engaged with the new intervention. Right, so that's both figures more or less convey the same thing. So so takeaway is, yes, researchers do design or co-design the intervention, but they hardly discuss the extent to which they did so, and also not to the extent to which they were involved in the implementation then of the designed intervention. This is just in case Dean was in the room. I thought that's a candy for him. So just to basically show how this could be done. It's also only from there, I believe, from the appendix of the paper, but in one of their RCTs, they do clearly convey or state that they did not engage in the design and the implementation of the treatment. I believe these kind of declarations are important to make this topic, this issue of construct validity and researcher involvement in particular more salient. Right. So all this, you might say, is trivial. Microfinance is of course not a monolithic construct, but perhaps all the RCTs that you have reviewed only generalize to the very construct they are studying. So we try to ask this question to the papers we reviewed. So do the papers describe actually the concrete construct they are studying? And the vast majority does not. So we found only right, and also the vast majority of papers does make policy recommendations that go beyond, that certainly go beyond the construct that they are studying, and they certainly make or try to make policy recommendations that are that can be labeled generalizable. Right, so I'm going to rush through this. I think the point has come across. So to wrap up, so we have shown, we believe we have shown that for microfinance, the construct microfinance is highly dimensional. That's probably not very controversial. We have also provided some evidence that already minor design tweaks are very consequential for the impacts. And I believe we provide quite some evidence that there is not much sensitivity for the relevance of construct validity out there, and certainly not for the term, right? So I haven't come across a paper in economics that actually uses the term construct validity, as I said earlier. And I guess, as we all know, no matter which epistemic model we apply, construct validity is crucial, right? So even if you are one of the strawman generalizers, you're making basically deductive inference, then that's fine. You can do that, but you have to really make clear which assumptions you are using about the construct, and then this includes also the construct that you are speaking to. And the other epistemic approach, the pointillist painting generalization, let's say, for this approach, it's equally important to think about construct validity because it determines basically how many dots are required, right, to make sense of the pointillist painting. Takeaway messages: we need more sensitivity for how we design treatments, but also for how we generalize, so how we write them up. The papers in our papers, and it's certainly an open question to what extent this also applies to other non-microfinance literatures. Thank you very much. Merci beaucoup.
For a long time, so I'm sure Julia has some things to say here.
I do. Thank you very much. I also have prepared some slides which I sent to you via email, and I can also put them to the chat if I may ask you for support showing them. That would be much appreciated. Otherwise, I can just talk. Maybe give you 2 minutes to figure out whether it's feasible, or if you would prefer me to talk without the slides.
I'm pulling up your slides now.
Thank you. So first of all, thank you, Jörg, for this really interesting presentation and paper. I very much enjoyed reading the slides and the paper and find them very helpful particularly because you found a way to empirically prove something that is something that I would often address in a conceptual paper. I think construct validity is something that is a matter of discussion and theoretical work, construct mapping, thinking about definitions, but theoretical work and conceptual work is really hard to publish. And you found a way to kind of empirically make your points more salient, which I find very interesting. Thank you for putting up the slides. And I have a few points that I prepared as a discussion, 3 actually. It starts with one size does not always fit all. And at use of, I would like to start with the use of meta-analysis as a way to study heterogeneity across studies, which is not at all a criticism of what you did. It's just another limitation beyond all of the limitations that you also already pointed out. And let's start with this recent comic by the XKCD comic author who suggested that bad news, they finally did a meta-analysis of all the signs and it turns out it's not significant. It's funny and a good illustration of the point that I'm trying to make, because obviously we are all here in this room today, or you are all there in this room, because you are scientists and you believe in the possibility that doing science might increase our insights about what's going on. So some science is not generalizable or not replicable even. Sometimes science is or might be. We need more research to figure out what is what, but certainly we wouldn't agree on science being nonsense and we should not do that. So in other words, a meta-analysis might or might not get us an average treatment effect or an average effect, but it doesn't necessarily describe groups within the overall distribution of studies that are included in a meta-analysis very well. Meta-analysis are analyzed with methods that look for overall trends. There's one, for instance, overall indicator quantifying how much heterogeneity there might be in your set of included studies. There's also one overall effect size estimate, which is the thing that you see below this first plot, here indicated by the red arrow. But that estimate, this overall effect size estimate, represents some sort of a weighted average across all the studies in the sample. And an average requires a normal unimodal distribution. But if there is a unimodal distribution, for instance, one set of experiments in which a treatment, if there is a multi-bimodal distribution, for instance, one set of experiments in which a treatment did not work and another in which a treatment did work, then the average might not be informative. The average might be 0, which doesn't mean that nothing is going on. It might be that some studies really did a good job at finding situations, boundary conditions in which a treatment worked, and the other might not be. Which leads us to the next slide. Elaborating a little bit on, or illustrating the problem with the average here, using the example of a faucet from Edinburgh, where one side gives you boiling hot water, the other side gives you freezing cold water, and there's no way whatsoever to get at the average moderately tempered water that you might want. So sometimes the average is not the best description of what's going on, which leads us now to the next slide, please. And that happens, for instance, in bimodal or multimodal distributions. And actually, at least my statistics, introductory statistics textbook from my first semester says that the requirement for interpreting an average as a measure of the central tendency of what is going on in my group is unimodal distribution, also no mixture distribution, no outliers, and interval scaled or binary measures. But whoever tests for unimodality before interpreting an average as the one indicator of a central tendency or group trend, at least in psychology, many people just take an average and never look at a distribution, which is a problem in a bimodal distribution, such as the one that you see here, in which the average here in the middle indicates the point where nobody is at, and not where most people are at, which is what we usually expect if we deal with averages. This is an issue. It seems like a trivial point. As I said, it's actually pointed out in my first semester statistical textbook, but most psychologists I know ignore the point. And it seems that much of the clinical and medical research is based on average treatment effects without us knowing ever if that average even describes the central tendency or if there was a multimodal distribution. So that was my first point. One size does not always fit all. Next point is, how can we actually make sure to establish construct validity during, before, during, and after cumulative research cycles? As Jörg already pointed out, there is much debate about the construct validity crisis. It is also currently being discussed in psychology, and I would like to point out 2 recent publications that I find quite helpful to start thinking about ways how we can, as a discipline, increase construct validity in our research processes. And steps towards more consensus about construct validity before empirical studies might be better theory work. There's also much debate about the theory crisis and the measurement crisis recently. Some authors say that, or suggest that, one way to move forward would be to be more precise about what exactly is your estimate. What is the thing that you're trying to explain? What are its facets theoretically? How can you measure those facets? What exactly are the causal mechanisms that you think you are studying? And what are your theoretical points that you can make to justify why your operationalization, your measurement, is actually capturing all of those facets that you want to theorize about and generalize about? One second, please. If we stay on the last point of this slide for just a second, it might seem trivial to some, but determining a good measurement model, meaning a good translation of what our theory says into what we measure, and a model, an analytic model, is actually not that trivial. For instance, there's a current debate about what is a good measurement model for a multifaceted construct. We heard Jörg say...
if you could wrap up, that'd be great.
I will. We heard Jörg say that he was dealing with a multifaceted construct, but oftentimes the reflective measurement models that we're using to model those constructs might not even be the most suited. If I have to wrap up, let's quickly go to the second last slide, which is this one, which are the obstacles to establishing more consensus about construct validity. Since face validity is hard to quantify, it can be considered unscientific to even write about it. That is one of the obstacles. Discussion sections are usually kept short. Some authors have suggested to be more systematic in discussing constraints to generalizability, including construct validity. The problem is that many people keep their discussion sections very short and are trained to avoid topics that are hard to address or might be controversial, which makes it more difficult for the research community as a whole to understand the limitations of studies, including limited construct validity or other studies that should follow up in order to examine other aspects of a construct. And there's a lack of communication formats for controversial debate about, for instance, construct validity, where experts can really exchange ideas and come to a consensus. I don't think that writing articles allows for that forth and back. On conferences, we're always or often polite and don't really argue very much. We need some format to really argue forth and back in order to capture all aspects of a construct. And my last point, my last slide, is that cumulative science doesn't always happen when everybody does what they do. There are biases, there are certain topics that are rarely being addressed. Cumulative science needs to be directed, as the previous discussant pointed out, and that makes a difference between a pointillist painting in which all dots create a picture and a collection of drops that are unrelated, like in a Jackson Pollock painting. Thank you.
Thank you, Julia. Very insightful comments. Does anybody have any comments or questions? We have can give a couple of minutes. We're running low on time, 3 minutes.
Thank you. So again, it's a quite general question. I'm just thinking about, this microfinancing, and I put myself in the shoes of a policymaker. do I really care that, you know, I can find a common lesson from RCTs from different countries? I think what I really care is, okay, I start from a construct that I think makes sense for idiosyncratic reasons, maybe anecdotal reasons or knowledge of the field. And then I'm essentially worried about whether they can scale up and give result at scale. And maybe that's, I mean, of course, it's a different issue, and I'm not saying, you know, we should disregard the external validity question, but, you know, isn't that, because we're talking about a topic which is really about, it's policy relevant. I mean, it's the final objective is policy. It's just, I understand knowledge is important, but knowledge has to be useful and relevant, right?
We'll allow one more question, given that we have limited time. I know Anna had her hand up.
Thank you. This was super interesting. My question is, so given that we see that these treatment design variations matter so much, what do we do with that now? So do we go and like study all the different treatment variations? Probably impossible. So what do you think is sort of like, is the next step to say, for example, what we should do is find the most effective treatment? And so can, for example, adaptive experimental designs that re-randomize based on how people do in different treatment conditions, would that be sort of a solution to that problem, at least from the policymakers' perspective, where we are kind of going full on, like, you know, we're just finding the most effective thing, and that's kind of what we do? Is what, yeah.
Yeah, no, I think that's not what we should do. Certainly not, and certainly not by generalizing again, or making the same mistake again, right? Generalizing the large effect wherever it was found, and then to the next, to other contexts. So I believe, actually, also to Stefan's point, I believe research should try to basically, let's say, maybe to increase the policy relevance, I guess, we should maybe do more what policy makers are interested in. And I don't think they're interested in reading papers that generalize big time from specific context A to all other contexts on a certain specific construct, because they, in my experience, it's not so much coming from that field, but from energy policy. But policymakers are much smarter than this, basically, and they certainly care about evidence, but they're not stupid enough to believe that whatever we see in West Kenya also applies to some region in India, right? So my own personal model that might work is the local tinkering approach, we like to call this internally so far, and that's working in a specific context with policymakers, and then try basically to build RCT, or if you will, RCT, but also other methods, obviously. But let's say RCTs, build RCT on RCT to make policy learn, right? And then tinker as we design the next RCT, tinker maybe the intervention, but also other elements, right, to help policymakers to improve policies. But that probably requires to stay within a narrower context, I guess.
All right, we'll end it here. That was fantastic, Jörg. Thank you so much. So Bex's paper is called Addressing It Depends in Applied Ecology.
Okay. So it's weird holding a microphone. The only other time I've held it is when I've been singing karaoke, which is a very different situation. So sorry if I break out into song. Okay, thank you very much for having me today. This is really exciting. I've really enjoyed the talk so far. I'm going to be talking today about a question of it depends in ecology. Oh, thank you. So we're currently facing a climate and an extinction crisis. So biodiversity is currently plummeting. This is happening globally as a response to human pressures, namely habitat loss, which is mainly driven by land conversion, the conversion of our natural habitats into agricultural land. So there's been several international agreements where the governments of the world have called to action the need to reverse these trends. And by 2050, we hope to reverse these trends. We want to bend this curve of biodiversity loss. So there's been a range of scenarios that have modelled plausible futures if we are to call to action. And if we carry on with business as usual, biodiversity will continue to plummet. In contrast, if we actually radically change our policies now and we start to vastly increase the resources we put to conserving biodiversity, conserving our ecosystems and restoring them with initiatives like tree planting, we can start to bend the curve. However, as you'll see here from the green line, it's still too little too late. We're still going to vastly reduce biodiversity by that time, and not by 2050, which is when we need to start to recover by. And finally, the alternative scenarios show that if we implement these radical conservation and restoration measures, in addition to radically changing our patterns of consumption. So increasing the efficiency of our production systems, but also reducing our demand. So incorporating more plant-based products into our diet so we can actually bend the curve. So I'm an applied ecologist, and so is many of my colleagues, and I focus on this middle line. So trying to identify how we can conserve and restore ecosystems and target limited conservation resources to where they will work most effectively. But there's a challenge to doing this. And that's that many studies in ecology will conclude that the results of any intervention, so conserving a conservation action like protecting an area or restoring an ecosystem through tree planting or reducing the level of grazing to that ecosystem, we'll make the conclusion that the results of the study are context dependent. It depends. It's the answer that we often answer most ecological questions, and we've long lamented this issue. So the answer to all questions, it depends. So I don't know what I'm doing here. So much so that a famous ecologist, John Lawton, once argued that ecology is assimilating essentially a stamp collection. We can't draw these generalities between each studies, and on its own, each study is simply a stamp collection. So if we observe some kind of effect in one study, how do we know whether this will generalize to other taxa, other groups of species, other geographic locations, or other points in time? So to understand what we mean by this criticism of context dependence, let's pull out one of these studies of the stamp collection. So we have a huge literature measuring the effectiveness of interventions. So of X, so that might be a conservation action or a restoration action like tree planting or removing the a particular environmental stressor. And we might measure its effects on some kind of response variable Y, like an ecosystem service or functioning, so how much carbon is sequestered in the system, or the levels of biodiversity in a particular type of forest, for example. So the question faced by policymakers and scientists alike is, well, how do we generalize across taxa, ecosystems, geographic locations, etc.? And one of the most prominent ways that ecologists are doing this at the moment is through the use of meta-analysis. So meta-analysis, generally involving the steps of expressing for each individual study, we will calculate an effect size for each study. So we express differences in the means between treatment groups. We might express this as a mean difference like Hedges G or a log response ratio, or maybe the slope of a random effect, a random slope in a multi-level meta-regression. And then, as Julia explained earlier, the overall effect and the heterogeneity of the effects across the study sample is then assessed. And the hallmark of meta-analysis is this application of weighting, precision weighting. So different studies will contribute different weight to this overall estimate based on the inverse of their variance, based on the idea that the more precise the study, the more weight it should have. And then this final step is to attribute variation in the effect sizes to meaningful moderators that can help us, I guess, upon which we make these conclusions about external validity. We try to transfer the effect sizes to different contexts based on these moderator analyses. And the reason why I'm talking about meta-analysis now, because there's other approaches to generality too, is because it really has exploded since its introduction in ecology in around the 1990s. From its different origins in medicine, social sciences, it really has exploded, as you can see by this line, in ecology. They're proliferating, and they often attract quite a lot of high media attention for their apparent global reach of these syntheses, and often they can stimulate a lot of debate in the scientific literature, and it can get quite heated. So it's quite interesting to see. So this led to my colleagues and I wanting to write a paper on this issue about how meta-analyses actually, we're missing the target following current practice in ecology. It seemed to us that there's almost this insidious myth that exists that the very act of quantitatively synthesizing studies in a meta-analysis is enough to warrant some kind of claim about the generality of the effects. So what we did in this paper, we just wanted to go through these different stages of what constitutes a meta-analysis, and then just showing how it is actually missing the target. So why are we missing a target? Well, the first thing is that we don't actually formally define external validity or generality in ecology. We use words interchangeably like extrapolate, apply, generalize, transport, direct, relevance, transfer, transport, etc. We use these without actual definition to what our target context is, and we don't really talk about what we're trying to generalize as well, the results, the conclusions, but we need to be more specific about the S-demand that we're wanting to do. So the first step is to actually talk about what we want to generalize, the S-demand. And in meta-analysis, what we're implicitly trying to generalize is the effect size, this mean effect size that we estimate. And as Mike showed earlier, that we can classify these as the generality is to generalize from a sample of studies, and to generalize them to the population, this hypothetical population from which we sampled, or to transfer or transport is to transfer our inference to some other population or setting. So in a meta-analysis, which is often criticized for combining apples and oranges, when in reality there's a whole load of fruit on the diagram because we're combining more than apples and oranges. When we generalize them from some kind of sample of primary studies to this hypothetical superpopulation of studies. And when we transfer, we might be going to a different target site or a target population of sites. So I think visualizing it like this is quite helpful to see that we're not really hitting any of the targets. So the first step is generally this estimating the mean effects across a sample of primary studies. These mean effects are implicitly generalized to some hypothetical global population of studies. So generalization rests on high sample size and randomization if we're going from the sample to the population of interest. But in reality, this isn't feasible in ecology because we know that the studies that we do have are geographically biased. We don't have a lot of studies, for example, in much of sub-Saharan Africa. We know that we're taxonomically biased because people like to study birds rather than worms. We know that we have various sorts of publication biases. The language that the study is published in is going to influence the journal it's published in and whether that's open access, etc. So we know that this just isn't a feasibility. We can't generalize our effect sizes. The second is that this weighting procedure, that's the hallmark of meta-analysis, can amplify biases across studies. In ecology, the way that we sample the world, the way that we measure biodiversity, for example, sampling the number of plants in quadrats, we tend to have high replication of small plots or low replication of larger plots. And we tend to get this inverse relationship between accuracy and precision. So we can have, when we apply weighting, we end up with precisely wrong answers to the question, to a kind of vague question, to be honest, that we're asking. Then the second step is estimating this heterogeneity, as Julia mentioned earlier. It usually goes unreported in meta-analysis. We tend to focus on that mean effect, like it's had a lot of weight. When it is reported, it's usually super high, like 90% is the I-squared statistic that refers to the amount of variation between studies that's not due to sampling error. And this high heterogeneity is unsurprising, given that we combine studies on multiple taxa, ecosystems, and interventions. So if we're combining all these apples and oranges and pineapples or whatever, it's unsurprising that we can't actually transport the inferences from these meta-analyses to any given location. And then the final step, which is arguably the most useful, is attributing variation to useful modifiers, done through subgroup analyses or meta-regression. So the idea is that these moderators can specify the conditions under which we can transfer effects. But in reality, these modifiers serve as very coarse characterizations of target contexts. And we usually use like a one variable at a time approach, but we know that target contexts are multifaceted, multivariable. So again, we're missing a target because it's not specified. The other crucial issues is that often in ecology and these are all mistakes I've made myself as well, is that we overlook the analytical scale of our inference. So colleagues and I recently wrote this paper about understanding it depends, and highlight the importance of turning our attention to the analytical scale when we're making any kind of inference about how effect sizes change from one context to another. So when I say analytical scale, what do I mean? It's the scale used to measure and model relationships. So transformations are ubiquitous in ecology. We deal with all sorts of different data types, count data or numbers of species, biomass, etc. And we often use transformations to satisfy assumptions of normality, or we fit generalized linear models with some kind of link function to satisfy the assumptions. And we often then don't relate this back to our question of interest. So when it comes to meta-analysis, we often describe results as, oh, the effect got stronger or weaker in different contexts. So biodiversity loss was stronger for worms than it is for birds, or the effect of this restoration action is higher at lower latitudes, things like that. So we make inferences about effects being stronger or weaker across different gradients. But we just give a couple of examples in this paper about the importance of the measurement scale for doing so. So for example, imagine this meta-analysis that's been done to collate studies that have measured biodiversity or abundance of butterflies in control and treatment plots. So with assisted restored land in purple versus control plots where there's been no active restoration implemented. And then studies might track these over time. And together, if we put these studies together, we can ask the question beyond the scope of the original study, how does the effect of restoration depend on time since the restoration treatment? So we can see from this example that both lines generally increase over time. So biodiversity following a major disturbance event, for example, the abundance of the taxon will increase in both restored and unrestored forest plots. And we can, if we express this as a mean difference between the two lines, literally just the difference, this is increasing over time. But the two most popular effect size metrics used in ecology are Hedges G, which is a standardized mean difference where you divide it by the pooled standard deviation, or a log response ratio, representing a proportionate difference between control and treatment group means. So for all three effect size metrics here, we have a positive change. So we say the effect gets stronger over time. For this taxa, it's the same, maybe slightly weaker. So we have a mean difference that increases over time generally. If we were to analyze this using Hedges G, we'd see a different relationship. There's not really any change over time. It's slightly hump-shaped. If we look at a proportionate difference, it goes down. So it declines. The effect of restoration declines over time. Now, this is really trivial, obviously, but in my experience of reading studies, as we don't make reference to the measurement scale, we will still conclude the effect is stronger or weaker over time. And we don't make reference to the baseline, how that can change over time as well, and how that changes the need to refer to the measurement scale. So we proposed a few solutions to how we might be able to improve the generalities from meta-analyses, because they're going to continue to proliferate in ecology. I'm seeing quite a few meta-analyses come out even now, which is like blows my mind. Meta-analyses, and with the COVID-19 pandemic stopped a lot of fieldwork projects being carried out, that a lot of PhD projects are now doing meta-analyses. So how can we avoid misinterpretation? So we try to split the paper into what we can do now in our publications that we can easily do, and what we can do next. Because at the moment we're lacking a transferability science, a science of generality in ecology. So this needs to be developed, but there's things that we can start to do now. And this was mainly just learning from other literatures, from what I guess a lot of you guys are very familiar with these methods. So the first one was to define the estimands and the target context, because that will allow us to actually define the assumptions that underpin any generalizations that we make. In constraints on generality statements. So these just force us to make more modest generalizations and formalize those assumptions that underpin transfer. So the COG statements come from the psychology literature. The next would be to quantify the transfer domain for full data syntheses. So for analyses like individual treatment, individual patient meta-analyses, those are becoming a bit more popular in ecology. Now we have like an open data revolution and we can actually analyze raw data. We can start to ask questions about cross-validation and quantify the transfer domain. The third is to use interactive graphics. So the way that we published figures in scientific papers has remained unchanged for centuries, even though the complexity of our models has vastly increased. And these conceal the complexity of the model. We can't see underlying data. We often just present overall means with enormous confidence intervals. We need to encourage people to start to actually be able to interact with the underlying data and be able to really see the heterogeneity that exists. So we're putting together a Shiny app, a toolkit that allows us to make interactive figures alongside publications to try and change that standard. So you can change the scale of interpretation. You can view the effect size asymmetrically. If the effect of X on Y depends on Z, then the effect of Z on Y depends on X. We need to view that asymmetrically to get the whole picture. And to specify target parameters, this could start to allow us to see how the average treatment effect does not actually reflect the different combinations of the effects we see with different combinations of parameters. So what we need to do next is develop these qualitative and quantitative criteria with which to evaluate transferability of an estimand. So these really need to go into our protocols for when we do meta-analyses before we set out to do them. Can we identify these criteria with policymakers? Can these refine our inclusion criteria for the studies that go into our meta-analyses? And then develop the quantitative methods to transfer estimands. So we just touch upon these in the paper, but it's very much using methods like developed by Issa, who's going to be talking tomorrow, to be able to transport quantitatively effect sizes from different populations. And then the last one I think is quite interesting is to conduct interdisciplinary research that seeks to understand how different stakeholders perceive generalizability and transferability. If I was to ask many of my colleagues what do they in science, what they would think generalizability meant, I think I would collate a lot of very different answers. And the same if I was to ask policymakers. And we really need to understand the different constructs that are formed by people on how they perceive how results or estimands are transferable to a given context, so that we can start to present results in a meaningful way. Because a reader, if a conservationist or a policymaker, the question is this going to work for me? And we need to be able to present information in a way that allows them to, I guess, change the question in a way, so that they can adapt it or infer, will this effect be observed in my system, in my ecosystem, with its given climate, soil type, etc. So that is, I think, what we can do now. So in conclusion, meta-analysis does not lead to valid generalizations, as current practice is doing. Other disciplines can help us a lot. Ecology has much to learn. And transferability science is a scientific field in itself, and it's very much in its infancy in ecology. So it's a really exciting time to be an ecologist. Thank you very much for listening, and thanks to my colleagues for their contribution.
Okay, so I'm going to start over my own introduction. I'm Ilaria Pretelli. I'm a research fellow here, a postdoc researcher here at IAST, and I usually wear the hat of the anthropologist, but I'm going to try to fit the ecologist one for this discussion. And I'm going to start this by saying that I really liked Rebecca's papers and talk, so I'm not going to delve too much into criticizing it, but I will actually rather try to contextualize it within the general field of ecology versus other disciplines, because this is a multidisciplinary conference and this is a multidisciplinary institute. So I think it helps to see what are the different problems that each of this discipline is facing when talking about generalizability. Because as Beth said earlier, certain sciences actually struggle to think about the existence of multiple sets, and this is not the case for ecology. So this is a typical ecological landscape. People go there, collect data. They also go here and collect data, and nobody thinks that these two places are exactly the same, or that, you know, studying a tree versus a grass or an animal, things should generalize between one and the other. And there's an additional aspect that allows ecologists to think of generalizability in a different way, and is that nothing in biology makes sense if not in the light of evolution. And so we are always called to make trade-offs and think about phylogeny. So for example, if you want to study how cranial shape of animals depend on their diet, you have to include phylogeny. You have to include the fact that organisms that are related are more similar than organisms that are not related, and that this is a boundary condition to their shape that the cranials can have. So this kind, like the idea that there are differences between systems is built in ecology, but we also struggle to think about how to generalize and move from one system to the other. So this is a very low quality picture. I probably could have asked Becca to give me a better quality. I'm sorry, but I downloaded this from the web and I was projecting on the whole screen. So, but the idea is that, you know, these kind of problems. So phylogeny is not, I mean, you could think about like history as an aspect of phylogeny if you want to contrast different populations, but you know there are certain aspects of generalizability in ecology that apply much better to other disciplines. And so there's, you know, in ecology you're always thinking about the organizational level in which you're working, and you're also by nature setting at a certain spatial scale. But you know it's much harder for, I think, ecologists to methodologically, appropriately transfer from one setting to the other. And I think, you know, we often, like, we tend to have confusion in how a mechanism that acts on a certain scale might not generalize to another scale, let alone to a different, I mean, probably like things generalize or not, even at different scales of organization. And you can look at it between populations, but you can think about it at different scales of complexity or spatial scales or temporal scales. So I think ecology here has some strengths in the sense that ecology rests on pretty solid hard sciences. There's biochemistry that is informing ecology, evolutionary theory. These are all strongly quantitative sciences that are fundamental to interpret ecological mechanisms and ecosystem mechanisms. But I think ecologists often struggle to move up from theory to generalization, and like both in terms of theory, actually, like in terms of generalizing a mechanism that is proved in a certain context to a more general life law, like laws of life context, but also, and even maybe more on in terms of like how to generalize to applications and policy. And I think I will call us partially guilty for some sort of lack of mathy skills sometimes, but more in general, I think there are lots of tools that we have to, like, and methods that we have to implement in ecological research that are generalizable to other disciplines because they're not just specific to ecology. So these are 5 points that I really like from Rebecca's talk, and I think that we should all think about that are not just an ecology problem, but like from everybody. And I'm going to add one because I realize that there is definitely reporting boundary conditions in studies is important. So I think but that's a point that Rebecca makes in one of her papers, and I think that is interesting. We should do it and have it as like a compulsory element in discussions and so on. But also I really like the idea that we should report less coefficients and more counterfactual as results. So, you know, we're often writing papers for policymakers who might not understand the analysis, even when the analysis actually makes, like when reporting coefficients make sense. But if we're reporting anything more complicated than a linear regression, then coefficients might really not be the best output to you know, provide to the readers. And we should really think about the relevant outcome scale. And this is the second point. So if when we're writing and thinking about results, as Becca in one of her papers really points out, the outcome scale that we're reporting is not irrelevant, and we should think about it, and we should think about it in terms of who's the audience, and when we should report counterfactuals that are relevant for the audience that we are addressing. And well, this has happened multiple times, so we should definitely think causally and report causal structures or the causal underlying thing, the elements that we are thinking supports our analysis, to lay out the assumptions of our analysis. Also, I think we should always think about the finality and the fact that different processes can generate the same outcomes in terms of the measures that we can pick up, and we should always think that the mechanisms we are assuming might not be the only one that generates the observed pattern, and we should think about this and be more humble, I guess. And then finally, and this is the point about meta-analysis and full data analysis, I will encourage people, and I think this is important, that we think more openly about sharing data, making data available, because meta-analysis obviously work on results, and different studies have different causal structures, and when we are comparing results that come from different papers who have different causal structures, the results are not comparable. So I think full data analysis are definitely an improvement over meta-analysis, and if we can think more about working with original data, I think we can move forward and generalize. So these are my points, and I will leave the discussion.
Yeah, thanks a lot, Ilaria. Great points.
I just wanted to say thank you. As somebody who works in meta-analysis more in the social sciences, these problems are the same. And so, I think your point that during the pandemic, people couldn't do lab work. And so they're going to do meta-analyses. I've been saying this too recently, that I think we're going to see a lot of really bad meta-analyses coming out soon. I've seen in psychology, I just wrote with some colleagues a paper about 2 dueling meta-analyses. So 2 meta-analyses of the exact same literature that came out in the same journal that came to very different conclusions because of the methods that they were using. And so I think we're in a space in which people think that meta-analysis is just like, oh, we're just going to average them and there's no modeling decisions here. We're just going to do them and the results will it'll all be empirical and rise to the top. And sort of what we're showing is that depending on how you interpret the analyses that you do, but also, a lot of it is the interpretation. Do you focus on that average or do you focus on the heterogeneity? Do you, where do you put the emphasis in your results? That you could take the same findings and then interpret them differently at the end. And so I think there was this idea that meta-analysis would solve the dueling expert problem. And I think instead what we're seeing is that it's just creating a whole new layer of the dueling experts. So thank you.
Isa, Sylvain, do you want to get Isa up there?
Let me ask, is this part recorded too? The questions and answers? Is this being recorded?
Yes.
The Q&A? I'll be careful what I say. No, that's fine. So thank you for the wonderful presentation. I think, conventional meta-analysis, like a dangerous thing, should probably be banned. Doesn't mean anything. I'll say more about that later. But I'm struck by the enormity of the task here. I come from a biomedical background. We study one animal, basically, very narrow settings, the humans. And it's really hard. And now you're studying ecosystems and different species and stuff. And so I wonder if the words are failing us when we say meta-analysis and synthesis and all that. The causality here, it's not clear to me that the goals of all these synthesis approaches should be the same, given the enormity of the task. And so, for example, I would take the position that when the space of treatments is vast, as in the previous talk, or when the potential settings of application are so different, we can kind of give up on causality. And instead, what you have is you'll have, maybe if you're lucky, a few hundred studies, and the best you can do is some kind of descriptive response surface kind of thing over them. And then you could say, if you run another study in this setting, if my model were correct, which I cannot really test because the space is so high dimensional and the model is so simplified, I predict you'll probably find such and such. And so maybe my question is the causality too much of an aspiration for a domain so large and complex?
Yeah. I suppose that we try and isolate the variable of interest in ecology. It's quite common because of the complexity of ecological systems. Individual studies will try and constrain their scope to some degree, so try and minimize variation in all the other conditioning variables like elevation, slope, climate, whatever, and try and focus on a causal variable of interest. So it might not be within a study. So within the studies. Yeah, I don't think they'll claim to be causal, but implicitly, that is what we're doing when we interpret the results. I think it is very dangerous. I agree with you. Yeah, the variables is common to explore how maybe effects of different interventions vary across taxa, across latitudes, across climatic gradients, and then maybe extrapolate those to say what will happen in the future with climate change, things like that. But from the various reasons, those trends that we find are often artifactual of our design decisions when we conduct the meta-analysis.
The same events. Just because it's individual estimate as potentially for the interpretation doesn't mean that any sort of power is involved.
What did you mean by the focusing instead on response surfaces?
Well, I mean, again, our problems tend to be massive modest, but if you have what people call population interaction, very easily you can blow up a space of 3 million. So the position to take in the problems like this is basically there will never be enough time. So they will address it.
Mm-hmm. Thanks.
I just wanted to say, Isa, I think you point to, first of all, good to see you. I think you point to something that I keep seeing again and again when people move to meta-analysis, which is people who do causal studies, RCTs in particular, don't trust models. I think implicitly, right? So I want the randomization to know that it's causal, but then we put them together in a collection of studies and we want to talk about variation across those, and that is no longer causal and it requires a massive model. And so there's, but people who are used to doing the individual studies almost like fall into these models and this model-based world kind of without realizing it, almost like they bring with them the idea that what they do is causal and doesn't require models, and they bring that to the meta-analysis and kind of forget that they've treaded into like quite different territory here.
Yeah, I'm wondering whether did we talk just together about what you talked after the end of the other session, or did you say it to everyone? But I think everything that what you're saying brings back to what we were talking about, like the fact that it looks like we need a lot of more systematic approach to the analysis of stuff. So if you start analyzing stuff with like very complex response surfaces, probably you need to have a lot of teams working on that, very large sample size and coordinated effort, trying to really get at the most important facets of that. Like we were discussing, like physicists, they have done that. They have coordinated and built like a huge particle accelerator. It costs a huge amount of money, and there are 5,000 people on each publication. Probably we are heading that way because I don't think it's feasible to have everyone choosing his own degrees of freedom, the way they like the study to be run. And then we try to combine all of that in a haphazard way afterwards, right, ex post. I think probably where we are heading next is trying to coordinate much more, which is going to be fun but hard, I guess.
I found the fuzzy figure that Ilaria showed that included the temporal dynamic quite compelling. I was just this week learned of a sort of theoretical model from evolutionary biology that suggests that when you consider the long-term effects of processes, you can actually get orthogonal interpretations than just what is going on within one generation. So behavior at time one can actually create a different selective process when you consider the downstream effects. So is it sort of a problem with no solution to think about interpretations within a sort of cross-sectional framework might be the exact opposite of what you might consider when you're looking at things long-term, and we can't really model those in a theoretical sense in the same way, and we can't empirically measure them at the same time. So do we need to just be careful with language, or is there a better solution to these differences between cross-sectional effects and long-run longitudinal effects?
Yeah, it's really, I think in ecology, we often use space for time substitution, where we know that temporal processes are really important, but I'm a forest ecologist and we don't have time for forests to grow during our lifetime of our PhD or our own lifetimes. So we use space for time substitution, and we know there are issues with that, but there's not really any, I guess the ways that we can overcome that is using simulation models, things like that, where we simulate processes, but then they lack realism. So we always have trade-offs with realism, generality, and what's it, the third dimension.
Great. It's really a pleasure to be here. I'm really excited to share this work with a new set of audiences. I'm going to change the tenor of the discussion here from thinking about how to generalize our knowledge from a methodological point of view to an applied project that aimed to develop evidence using a multi-site trial design to, from a design-based perspective, increase the generalizability of the findings from the start. So I'm going to try to reflect on some of the design choices that we made, try to enhance the generalizability of the findings, and also some of the challenges that we came across in doing so. So as the debate was roiling in the US after the Black Lives Matter protests in 2020 about police violence, a set of parallel debates was taking place around the world in places like Colombia and Nigeria. And activists were demanding two things at once. They were demanding a legitimate police force that didn't engage in extrajudicial violence and a reduction in crime. And one of the problems that policymakers face in responding to these twin demands is that many of the policies that we have that are designed to reduce crime have this negative externality of undermining citizen trust in the police. So there are examples from all over the place, from stop and frisk policies in New York City to militarized policing in favelas in Brazil to broken windows policing efforts in many countries in the world that are designed to enforce the law, but end up either targeting civilians or targeting people who are innocent. And so sorry, this is not really working. And so this ends up undermining the trust that police agencies believe that they need in order to reduce crime. And so why is that? We develop a kind of really simple theory of change here about how police agencies try to reduce crime. So we're interested in this outcome of the crime rate. And so one of the main tools that most societies have is a set of police actions. Police have been a uniformed, regulated authority in many countries for several hundred years, and in some countries more recently. And they generally have two tools. They can arrest perpetrators, and they can go on patrols to try to prevent crime. And the kind of core mechanism that I'm going to focus on here is the idea that citizen input is really critical to the choices that police agencies make about how to allocate their efforts in those two actions. They need to know where to go, whom to arrest, and where to go to prevent crime. And so citizens have a range of information that's useful to police in making those decisions, including evidence about the perpetrators of past crimes and kind of tips about dangerous places or future crimes that they think will take place. And so the policy problem that our study tries to address is that there's simply not enough citizen input, that citizens are not willing to collaborate with the police to provide this information that might make police, the allocation of police effort more effective at reducing crime. Is it possible to hide that or not? And so this is what we're going to try to address. We're going to try to great. We're gonna try to increase citizen input into police decision making, and to do that, the mechanism that we're going to invoke addresses the fact that there are really high costs to individuals providing information to the police, that you may be retaliated against by criminals. The police may victimize you when you're trying to share this information, but there are, on the other hand, really diffuse benefits that you may only reap a very small proportion of the benefit from sharing that information that all of the rest of society also is able to benefit from. So if we dive into this individual calculation about whether individuals decide whether to share information with the police, you're making a cost-benefit calculation. What are going to be the costs if I decide to walk into a police station and share information about a past crime or the possibility of a future one? And what are going to be the benefits to me and my family? So in terms of the cost, there are a range of them. Might think that there are costs to gathering knowledge about actually how to do this. In some places, like in the US, it's pretty straightforward. You can call 911 to report a crime, and you can go into the police station. In other places, it requires more information to understand what are the laws that are relevant, what are the laws that the police might be willing to enforce. Second, it simply takes time. You have to leave your job often and go into the police station to report it the first time, and then you often have to participate in the law enforcement process, even through a court case. This can be quite expensive to you in terms of your time, and you also may be worried about, again, retaliation for sharing that information. On the benefit side, you expect that maybe there's some justice that you get from this, but also that crime will be reduced. And so what does that mean? As a citizen, when you're making this decision, you have a set of beliefs about whether crime is going to be reduced. You don't know whether it's going to be reduced. And so there's a set of perceptions that go into your assessment about whether sharing that information is going to lead to reduction in crime. And so you have to believe that police are well-intentioned, that they're able to act, that they have the capacity to act. And so if you think all of those things are true, then maybe that pushes in the direction of sharing the information. If you don't think they're well-intentioned or that they're not able to act, then even sharing the information is not likely to lead to any benefits for you. This is often, all three of these are often kind of lumped together. We'll look at them separately, but they're often lumped together as kind of trust in the police. If you trust in the police, you're willing to share information. Otherwise, you're not. So this is kind of the basic theory of change that we're going to draw on to try to test a particularly popular intervention, police reform, called community policing or community-oriented policing. And the basic idea here is that this is a strategy for encouraging the public to partner with the police in preventing crime based on the specific needs of the community. And so the idea is to create opportunities for citizens to come into contact with the police, share information about past crimes and future ones, and that will lead to a virtuous cycle in which the police will be able to more effectively take action, reduce crime. That should increase citizen trust in the police and encourage even more action. What does this actually mean? Community policing means many different things in different places. That's an issue that will come up here again and again. There are typically 4 elements of the intervention. There are frequent local beat patrols, where cops are assigned to a particular geographic area and they're asked to patrol there on a regular basis, get to know citizens and business owners, learn about their concerns, and try to address them. Decentralized decision-making, which is basically taking the decisions about how to allocate police effort from a higher commander level down to these beat cops and their supervisors so that the information they're collecting can be directly used. Community engagement, which is a set of mechanisms for increasing communication between citizens and the police. These often take the form of community meetings where supervisors and beat cops come and talk to the community on a weekly or monthly basis, learn about concerns, develop an action plan for addressing them, and then report back on actions the police took. And then problem-oriented policing, which is a set of related strategies for how to address the underlying causes of crime and solve problems in the community that should lead to a reduction in crime. So where does this fit into the theory of change? This is going to intervene on, we're going to intervene on the costs of sharing information. So we're going to provide through these community meetings, community policing provides citizens with knowledge about how to take action. It reduces the time to take action because it provides a much more direct connection to beat cops and these community meetings to actually share the information. And it's also meant to change these citizen perceptions about whether the police are well-intentioned, whether they're able to act, and whether their action is effective by putting people in touch, and also through these community meetings, giving citizens information about what actions police are actually taking and whether they're leading to a reduction in crime. So we're going to test this theory of change and this intervention in a set of cluster randomized experiments in 6 countries in the global south. We're going to estimate the intent to treat effects of introducing community policing and increasing community policing practices. And then before and after the intervention, we're going to collect a set of standardized surveys that ask the same set of questions about citizen attitudes towards the police, police attitudes towards citizens, cooperation with the police, and crime rates. We'll also collect some kind of secondary administrative data from the police about crime rates. So we have a kind of behavioral measure of crime. To preview what we're going to find, we find no evidence that community policing reduces crime or builds trust. This virtuous cycle does not seem to be kicked off in any way. Essentially, none of the major outcome families, none of the major outcome families that we pre-registered had any effects in any context. We conducted an ex post qualitative analysis to try to understand this. We pre-registered a set of alternative hypotheses about why this might not work. There were so few effects of any kind that it didn't shed a lot of light onto why there was a null effect. And so we talked to our police partners. We talked to enumerators that had been collecting data and tried to unpack why that is. And I'll talk about some of those conclusions right at the end. So community policing is one of the reasons we want to focus on community policing is it's really used all over the world. Essentially, all police agencies in the US and the UK use some form of community policing. It's been implemented on every continent in most countries. And it's been introduced as one of the key policy changes in response to Black Lives Matter in the US and to these protest movements in Nigeria, Colombia, and a number of other places. We did a systematic review to try to understand what the existing evidence base for this was. We found that most of those trials were in a really limited set of geographic areas. They were almost all from the US, the UK, and Australia. They focus on limited parts of this intervention. They didn't focus on the basket of community policing practices. They find generally that increased patrol frequency and the introduction of problem-oriented policing strategies seem to reduce crime, but that there's really limited evidence about whether those same interventions have an effect on citizen trust in the police, which is this really core part of the mechanism of why community policing might work. So almost none of this evidence comes from the kinds of places that are now implementing it all over the global south. And again, none study this bundle of practices as it's actually implemented. So the motivation for our design is to address some of those shortcomings of the existing literature. We wanted to build evidence in the global south to inform policymakers who are trying to decide whether to implement community policing. And we wanted to improve the generalizability of these results by implementing a comparable intervention across these multiple sites and to increase the comparability of outcomes by measuring the same set in surveys and administrative data across the 6 sites. Finally, we also wanted to test this common bundle of practices rather than looking at one or another where there might be complementarities or substitution between them. So we worked in 6 quite diverse study sites. These were not randomly selected. These were generated by a set of generally existing partnerships between academics and police agencies. Some of them were new partnerships that formed after we identified police agencies interested in learning about community policing and about what would be effective in general. they vary on a number of different characteristics. Some are dictatorships, some are quite open democracies. They range from middle and high income countries in Colombia and Brazil to some of the poorest in the world in Liberia and Uganda. And there are some places that really have quite high levels of corruption, including in the police, to places where that's really not much of an issue. So the intervention that we implement is what we call locally appropriate increases in community policing practices. And so the idea of the study is that if we find that this increase in the strength of community policing practices did or did not work across this set of quite diverse contexts across the Global South, that we might have, either this might be informative about whether this would be an effective tool across a broader set of places in the Global South. I want to emphasize that we use this kind of odd phrasing of locally appropriate increases. I think that highlights the fact that what we were trying to do was to target this mechanism of increasing the contact and ability of citizens to share information with the police. The way we do that is slightly different in different places, and that was generated from a practical, mostly practical reasons, which were that police agencies wanted to be able to select what they thought would be the most effective set of increases. And so it'd be interesting to talk about kind of the connections between this and the construct validity talk before. So we standardize these interventions to a certain extent. I'll show you what the across the 4 dimensions that I mentioned, what we did in each place. But we started out with detailed discussions with the police about what they thought would work, trying to implement this mechanism of community policing, creating this virtuous cycle between citizens and the police. We then held a standardization workshop where police, basically each research team came with a proposal from the police agency that they had worked with. Here are the dimensions that we want to increase. And we tried to first classify what was going on in status quo policing, what we would be comparing to. And second, we tried to increase the strength on some dimensions so that this was a relatively comparable increase. Then it kind of went back to the police partners and they decided whether this was actually something that they wanted to implement. The end result of that was that there were 4 dimensions that we standardized. The first was town hall meetings between citizens and the police. The second was increased frequency of foot patrols. The third was the introduction or the marketing of existing citizen feedback hotlines, like 311 in some places in the US and the UK. And community watch forums, which were similar to the community meetings. They were meant to formalize existing local security groups and bring them kind of like neighborhood watch groups, and try to formalize them and bring them into contact with the police rather than acting extrajudiciously. So this is the set of interventions by site. So you can see that there's some variation. The town hall frequency was approximately monthly or bi-monthly across most of the 6 sites. In 3 of them, we increased the strength of the frequency of foot patrols. In 3 of them, we introduced or marketed these citizen feedback hotlines. In 3 of them, we introduced these watch forums. And these interventions went on for between 6 and about 12 months. I want to mention before kind of jumping into the research design that one of the things we thought really hard about was the ethics of working with the police. We felt that we had obligations that went above IRBs and institutional reviews to try to figure out whether our research was going to lead to negative consequences for people living in these areas. So we, with the help of our funder, the UK government, we conducted a unit-specific assessment of the risk of kind of extrajudicial activities of the police. And we set up a set of risk monitoring and mitigation plans in each site that called for kind of halting the intervention if kind of negative outcomes happened, which fortunately they didn't. So our experimental design in each setting was to randomly assign geographic areas to either receive this increase in strength of community policing practices or not. And so in some places that was neighborhoods, in some places that was villages, in rural areas, and in a couple of places that was police beats that were randomly assigned to receive this increase in strength or not. The outcomes that we measure in each of these places at baseline and endline include 4 major families. First, the crime rate, which we measure through a gold standard crime victimization survey. we measured perceptions of the police of citizens, whether you think that the police are going to take action on your complaints, whether you think that you trust them generally. We also measured police perceptions of citizens, because I think one view of this intervention is that it should also make police feel more connected and warm towards citizens and be more open to the information that they would share. And finally, we measured this kind of key outcome of cooperation with the police. How often are people sharing information about past crimes or the future risks? So we're able to look into parts of this theory of change and not into other parts. We're going to be able to measure the crime rate directly, citizen input directly. We'll measure some of these costs, knowledge, and we'll measure a bunch of these citizen attitudes that go into your assessment of whether you think sharing information will lead to change. We're really going to have to black box police actions. We don't have good measures of what the police did in response to that, and I think that probably is going to be one of the stories at the end about why this wasn't effective. Our measurement design was to conduct face-to-face surveys, again at baseline and end line. Generally, they were randomly sampled citizens. So one thing, Anna Vilka was also on one of the country teams. We were talking yesterday about how it would have been nice if we had oversampled people that had participated in these community policing activities. We didn't do that, unfortunately. And then we collected administrative data from the police that were either daily or monthly police blotters that we aggregated into an alternative measure of the crime rate. One of the unique features of the study was the standardized measurement that we developed across these 6 sites. So the goal was to ask the same question that measures the same concept across all of the sites. So we came together and drew on past surveys from countries in the global south that were measuring crime and citizen perceptions of the police, came up with the best questionnaires that we could, and then took them into the field, localized them, translated them, and then came back and adjusted the common questions so that we could best reflect the what we learned from the context about what kinds of questions worked and didn't, and then could still at the end more or less measure the same set of concepts. And so a choice that we made here was to really focus on a coordinated set of items. I think that we probably did a better job at coordinating the survey items that we asked than in measuring the concepts, because we really wanted to have exactly the same measurement tool. And so I think that's something that we've thought about afterward. So we did this coordinated data collection. We interviewed about 17,000 citizens. We interviewed officers in most of the jurisdictions that we worked. In some places, in 3 of the sites, officers are randomly assigned to participate in the community policing intervention or not. And so we're able to compare officer attitudes and measure the causal effect of community policing on those officers. And we have this crime data. So we analyzed this using a standard and simple meta-analysis design, a standard random effects estimator that's weighted by the precision of the effect estimate from each of the 6 sites, as well as the across study variance. In each of the sites, except for one, which I'll describe in a second, we're going to be estimating the intent to treat effect of introducing and increasing community policing practices. And so we'll be estimating through this meta-analysis the average ITT effect and the standard, how much that effect varies across the sites. So to give you a flavor of this and to highlight this one study that was a little bit different, we're going to have an estimate for each of these outcomes. For example, the intent to treat effect of community policing on crime tips, how often citizens are sharing information for Colombia, and then we'll have 5 more for each of the other countries. And then we'll construct this random effects estimate, the meta-analysis estimate. So I'll show you this for each of the main outcomes. And this is going to, yeah. You'll notice here that the confidence interval on the Brazil site is extremely wide. The reason for that is that there we had to use an encouragement design rather than the standard design that we were using in the other sites. So what happened there was that one community meeting would be held, and they encouraged people to join this existing community policing program, which was basically a set of WhatsApp groups in which police and citizens interacted on this WhatsApp group, and that's where information was shared. Unfortunately, the take-up rate of this encouragement was extremely low. One reason for that is probably that when we started the study, they hadn't really rolled out this program very widely, but by the time we actually implemented it, it was much more widespread, and so the room to grow, the room for people to join this was relatively limited. So there's a low compliance rate, and so as you'll see in all the graphs, we just basically learned nothing about the complier average treatment effect for Brazil. Okay. So again, the overall findings here are that there's really no impact on crime, trust, or cooperation. We have some limited positive results on some citizen attitudes in some of the contexts, in secondary outcomes. They only take place in some of the contexts, and so I'm going to suggest to you that they're not very informative, and that the overall picture here, based on our pre-registration and based on these main outcomes, is that there really are no main effects of this intervention. Okay, so first, I'm just going to run through these results. The first is, does community policing change your trust in the police? We measured this in a number of different ways. Your overall perception of the police, that's the question that is, do you trust the police? We measured perceived police intentions. Do you think police are on your side? Perceived police capacity, police responsiveness, and then separately from this police officer survey, police perceptions of citizens. So these are the average ITT effects. You can see that there really are no substantial effects of these interventions. There's a lot of variation in the perceived police intentions. This is one of the measures in which there were very different effects from the different sites. In Pakistan in particular, there was an increase in a couple of the secondary measures of perceived police intentions. We also measured some of these costs and benefits to reporting to the police. So knowledge of the criminal justice system. Do you have enough information to report? Perceived state legitimacy. Do you think that the state is legitimate overall? And communal trust. Does this build trust within communities? We don't see any results, any positive effects or negative effects there. In all of these cases, we can both rule out an improvement and a large backlash. I think there were some worries among policymakers that there could be backlash effects, and so we're largely able to rule those out as well. In terms of cooperation with the police, we don't see any increase in crime reporting, in the reporting of police abuse, or in citizen norm perceptions about whether other people are reporting to the police. In terms of the kind of ultimate outcome of interest in crime and insecurity, we look at this from our crime victimization survey, from our administrative data from police blotters, your perceptions about future insecurity. Are you worried about going outside at night, for example, and rates of police abuse. And we don't see that community policing changed any of those. So starting to try to interpret this null effect, one thing we looked at was the level of implementation of this intervention. We have some imperfect measures of the intensity of implementation. This is a compliance index, which measures a set of perceptions from citizens about whether they were aware of community meetings, what they thought the frequency of foot patrols were, and what they thought the frequency of vehicle patrols were. We do see a statistically significant increase in the implementation of community policing between treatment and control. It varies across sites. In all of them except for Brazil, there's a statistically significant increase. But we think kind of relatively small, especially in terms of the frequency of foot patrols and vehicle patrols, which we can't distinguish from zero. So one part of the story here may be simply that community policing was not implemented at a high strength by the police, and I'll talk about some reasons why we think that might have happened. So diving into the country level results, it's not the case that we see any of these effects across any site. So this is just taking all of the main effects that I showed you before and showing you them by country. I've dropped Brazil to avoid those giant confidence intervals. And you really see that there's really not much going on here. In some secondary measures, we do see these small changes. But overall, it's not the case that these average effects are hiding really large improvements in some contexts and no improvements in other places. We do have these mixed attitude results. So these are the secondary measures of citizen attitudes towards the police, or assessment of whether the police are going to take action. So we see that in Liberia and Pakistan, there's an increase in the secondary measure of perceived police intentions. And in Colombia, there's a small but precisely estimated effect on perceived capacity of the police to take action. So again, these are secondary measures. These were pre-registered as secondary measures and are inconsistent across the countries. And so don't tell us a consistent story that perhaps there's an early effect on attitudes that didn't translate into behavior. We really don't think that that is what's going on. To say something briefly about inferential threats to the experimental design, one risk in policing studies is crime displacement, that you're very effective at reducing crime in treatment areas, and it all just moves to control areas. In that case, you might mistake a null effect for actually quite effective intervention that just moved crime. We don't see in some imperfect tests of looking at trends in treatment and control any evidence of crime displacement. One thing you might think about is whether community policing should have an effect in the relatively short duration that we implemented it here. We implemented this again from about 7 months to about 12 months. Perhaps it's the case that you need these norms in this virtuous cycle to develop over a longer period of time. And finally, we don't see evidence of differential attrition. This is not causing people to stop responding to our surveys. So why did community policing fall short? On the basis of our experiments, we really don't know. So we went back to our police partners, to enumerators, to the transcripts of community meetings to try to understand what might have happened here. And we identify 3 structural features that may have held back its effectiveness that I think just open up areas for future research. So one is a lack of prioritization or an erosion of prioritization by police leadership. We saw in several of our contexts that police leaders who are initially really interested in this, this is kind of like the best case scenario here for police buy-in, because these were self-selected police leaders who wanted to run experiments with researchers to find out whether community policing was effective. But their interest in a couple of cases really eroded over time. And that meant that station commanders and beat cops learned that this wasn't a priority among the many priorities of the police, of police leaders. And so that may have eroded implementation of the intervention. Second, we observed that there was really very rapid rotation of officers and commanders across the sites. The most kind of egregious example was in Pakistan, where our main police partner who had decided to work with us on this was rotated from the original site 3 times during the experiment. And so we 3 times came up with a new experimental design in that case to work in the new place where he was stationed. But in all of these cases, beat cops were rotated between jurisdictions on the order of 1 to 6, as frequently as 1 month. And so you can imagine
if you could wrap up.
Yeah. You can imagine that if this is, if part of the idea here is to generate trust between citizens and the police, that if these officers are just being switched out, that there's not a lot of opportunity to do that. So we suggest on the basis of this that it may be the case that structural reforms are needed. And so future experiments should tie community policing interventions to larger changes to the incentives of officers to implement these tools. It also suggests that exporting innovations in police practices from the global north to the global south may fail. We found that there was limited capacity in some contexts to implement these, that this rapid officer rotation seems to be higher in some of these contexts. And so there may be these structural conditions that make it impossible for community policing to be effective. I think that was kind of our initial read of these results. And since then, we've been doing a systematic review of evidence from the US and the UK that has motivated the adoption of community policing around the world. And I've come to be a bit more skeptical about the quality of evidence from there. And so I think the jury is kind of still out about even whether that transportation of effect estimates from the US, the UK, and Australia was really warranted to begin with. So I'll leave it there and looking forward to your comments, Ray.
All right, thanks a lot, Ray. So we switched these things in between the sessions, so we're trying to keep it clean here. All right.
Thank you. Thank you very much. So this is a great project. I've had the pleasure of seeing it presented a couple of times. So I've seen a couple of these country studies presented, and I really think it's an advance in terms of how we look at policy implementation. And evaluate policies. And so what I'm going to do basically is give a totally different perspective on the project, one that I think speaks a little bit to the overall theme of the workshop. So basically, I think we can think about the project as having three different versions. One of the versions, and basically the three different versions are based on this notion of what is the treatment effect here, right? And one way to think about the treatment effect is to simply think about the treatment. My version one is a US community policing policy initiative. That's the treatment. It's a simple policy initiative. And we can think about it as being defined by the population of US, UK community policy or policing policies, what I call CPP. So let's assume there's this population of these policies out there, right? The treatment really is a random draw from this population, right? It's a random draw of the policy details from the population of community policy details, maybe weighted. We might want to weight these policy details, or we may want to think about this as 6 treatments because there are 6 teams, and we can think about each team as making its random draw from the population of community policy details in the US. And that then is the treatment in each of the 6 different countries. Because I think this is the most, in my opinion, the most persuasive representation of the study. And I think it's the one that holds up most. The policy initiative, we have to assume, credibly reflects a US-UK community policy initiative. Not necessarily the implementation, but just the initiative. And we can think about it as a random draw from this population of CPP details. And roughly, this is how an NGO or a government agency would go about designing or funding a global South CPP, right? So that's the way I would pitch the whole project. We have precise measures of outcome success that were used in the UK trials, or we may want to think about the outcomes as being, again, a weighted draw from the population of outcome measures that are typically used by these agencies to evaluate outcomes. Or maybe it's simply just what NGOs expect, right? That's the outcome. And I think the pitched in these terms, this project is really important because this is the external validity of the project, right? And I think if we just think about it as replicating the policy initiative decision by an NGO, I think it's very informative. And then I think the results, of course, are also quite informative. It basically suggests if there's so if we have an expected treatment effect, we're in a real comfort zone, right? But if we have no results, we're in a little bit of a different zone, right? We can't recommend interventions on the basis of the RCT, right? And something about the intervention that went wrong, right? So it's a gamble, but I think pitched in these terms, I think it's really informative, and I think that's basically what Graeme was sort of suggesting. But there are different versions. We can also think about the treatment as a well-defined basket of policies, right? Hotline, police patrol, community meetings. Once we go in this direction, I think the external validity becomes a little bit more dicey, right? Selling external validity. Because the most positive spin would be that this particular narrow basket of US, UK defined policies possibly has a treatment effect, right? Basically, this is sort of saying something along the lines of there's three things that they did in Baltimore, right? As part of the community policing policy initiative. Can we take those and implement them in Medellin? And do we get a treatment effect, right? But it's important to recognize that the CPP basket, right, is not necessarily a community policy, a policing initiative, right? The community policing initiative that might be taken up by the police in Medellin may not look like that CPP basket, right? So I think the version 2 more problematic in terms of validity. And finally, version 3 is thinking about the mechanism, right? Which I think is a very difficult task given the way that the Medicare people designed the study, right? I think it wasn't designed really to talk about the mechanism, and it shouldn't be judged in terms of the mechanisms. So those are my three sort of broad comments on the project. So thank you.
Thanks, Ray. Any comments or questions?
Yeah, thanks, Graeme. I mean, I'm a huge fan of all the Medicare and think they've really pushed us in very good directions here. One question I sort of have on all of them, I think, is trying to think about from the setting perspective or country perspective, like what's the population of interest here, right? Whether it's somehow, something within the countries, I guess, right? So you sort of have certain areas within country, is it aspiration to have some sort of within country population, I guess, right? And then, is it the 6 countries themselves define the population for the synthetic side of it, or some larger, I guess, set right here. So, and I don't know what you guys did in this particular context, but I guess in the Medicare one, right, they did kind of 2 meta analyses, right? One, we're just sort of averaging the treatment effects, right? And then just assuming all 6 were the population. And then kind of the larger one that was based on some questionable assumptions, I think. I mean, and acknowledged by the authors, right? That this sort of constituted some sort of random draw from the larger set, but it didn't really sort of go much further when maybe they could have, I guess, right? In terms of thinking about different distributions and different assumptions and stuff. So I was curious in this one, what this one, or more broadly in the Medicare, is how we're sort of thinking about going beyond the 6 countries, if at all, or what could happen within country. I sort of feel in the Medicare is, sorry, I'm going on and on, but with there's so much emphasis on a cross country, but there could have been much more within country, I guess, right? Sort of to define, because I think at least in a bunch of the cases, right, there's random sampling of municipalities or within municipalities. So there's all this possibility to sort of think about within country generalizability or transportability, but maybe not examined all that much. So anyway, there's a whole bunch of stuff that I was kind of rambly, but I'm just sort of curious your thoughts about how you guys thought through this and worked through it.
Yeah, I mean, I think that we're limited by the practicalities of the fact that these are not random draws from anything. So I guess we've been trying to think about kind of more from a transportability angle in the terms of your book to a set of police agencies that are in a position to implement a change in their community policing practices. So we looked at in the 6 places we have different levels of police agencies. So in 2 of the cases, it's a national police agency. In one case, it's just in the capital city. In the other case, it's just not in the capital city. It's in rural areas. And So I think it's yeah, it's a little bit hard to say, I guess. Police agencies that could implement this in the global South, in places that where it's sort of like feasible to do research, because obviously we're excluding lots of places, or maybe right at the edge of feasibility in the Philippines study, where the police is involved in all this extrajudicial violence, and so we weren't able to work in some parts of the Philippines where that was going on. So I think there are a bunch of scope conditions on that, and we kind of talk a little bit about characterizing them in the paper, but I think it's ultimately kind of hard. Yeah.
Okay. So just one quick question. I'm thinking that the community policing is very much dependent, obviously, on the specific political traditions and the political institutions in place. And here, like pitching it as some sort of exportation from the global North to the global South, may be not so precise, because the US and the UK and Australia in particular they are very different in a way. They have this community-based governance in some sense, right? So I would expect these policies to work over there, at least in ethnically homogeneous communities. But if you're like, I'm not sure, for example, in countries in continental Europe, in Germany, in France, in other parts, even within the global North, would this work? And then like I'm just thinking about the variation across these countries in the initial conditions, essentially in their along these dimensions. Like if there is no tradition whatsoever of community based governance, then I cannot see how the community policing would work in that regard.
I guess I'm not sure that the term, like maybe the terms are conflating like community with community governance. I don't think this is an intervention that's about community governance exactly. In fact, it's maybe better. It's maybe better thought of as a change to the way these kind of centrally organized police agencies work and solicit information from citizens. And so citizens are not direct in these community meetings, are not directing what people do. It's very much the police commander comes and is organizing this conversation around that. But I think it's a totally valid possibility that one of the reasons why this didn't work is simply that there's a different set of political institutions, histories of police violence, histories of violence in these places that make this kind of intervention not possible. You can't really speak to that with the evidence, and I think what we found is that there really aren't any great experiments, even in the US, the UK, or Australia, to compare this to. But I think that's something that is totally plausible. And I guess to come back to your question about the within countries, in each of the countries we are, in almost all of them, we're randomly sampling from a set of beats, neighborhoods, or villages. And so I guess within each of the countries, we are targeting the population average intent to treat effect by, in some of the cases, like weighting by the design of weighting according to our sampling design.
Sorry, real quick, do you unpack these like within countries, like comparing some of these? Like within country, like compare some of the treated areas with control areas, I guess, right? I mean, if they're sort of randomly sampled, like trying to make these like explicit comparisons to sort of see, what you can learn about like your ability to generalize here. I mean, it seems like all this is like all the country level comparisons, right? So I'm curious like how much is unpacked, because it feels like there's a lot of opportunity within country, but maybe it was uniformly null there as well. So I don't know.
We thought about, we tried to elicit what dimensions of heterogeneity practitioners and researchers in this area thought would lead to higher and lower levels of effectiveness. So places that have high trust, you might have to have a sufficient level of trust in order for this to be effective, or maybe you need to have really low trust. We looked at about 6 dimensions and found no evidence of heterogeneity and basically find no evidence of heterogeneity. And so I think it's the case that this is a null within each of the sites. There is that possibility. I think if, yeah.
All right, we're going to have to cut it here, but great discussion. Thanks a lot. And we'll have Ray Duch presenting next.
Thank you. So now, right, people wondering, why is he still standing up here? Thank you very much for the invitation. I have marching orders here to present something that is vaguely relevant to external validity. So that's what I'm going to try to do. Mike saw my title and said, Ray, you're missing the whole point of the workshop. Well, I'm going to try to link this to external validity. And it's sort of a narrative. The idea is to present an initial study that I conducted in actually both in the US and in Ghana, and then talk about how that has transitioned into an effort to sort of think about generalizing experimental treatment effects. So first of all, just to acknowledge the variety of people have funded this, but Oxford and HIS and Santiago and University of Ghana. So we've been very fortunate to have super sponsors on this. The background publications on this are varied, and you'll see why in a minute. One of them is, of course, this project in Ghana, which was initially described in Nature Medicine. And then a project with one of my postdocs on measuring public opinion via digital footprints. And then finally, an effort to sort of use machine learning to explore experimental measurement of error with a number of my postdocs at Oxford. So those are the three bases for the stuff I'll talk about. The original policy question had to do with COVID vaccines and basically trying to figure out how to encourage vaccine uptakes in the global south, particularly Africa. And this basically illustrates the problem. Basically, we're now post-COVID, but most places in Africa have COVID vaccination rates that are less than 50% of the population. So it is a problem. I'll skip all of this. We initially thought about exploring solutions to this by conducting an online incentivized experiment in the US and working with the vaccine people at Oxford. Our original idea was trying to understand whether we could incentivize vaccine uptake using cash, basically. And we thought, well, we would first explore this in the US before we decided to explore this in Africa. And the US outcome, basically, this is a 2021 study, basically suggested that cash voucher incentives would be an effective way to incentivize individuals to at least consider the COVID-19 vaccine. So this was the sort of point of departure. There were actually other trials that were conducted in the developed world that pointed in the same direction. This is a classic sort of vaguely meta study. This summarizes a number of studies that were done over the basic 2 or 3 years, looking at the effects of incentives, cash incentives, and most of them suggested that cash incentives would work, right? We then had conversations with a number of NGOs about trying to think about how we could implement cash incentives in Africa to promote vaccine uptake, because it was by then a very serious problem. The NGOs wanted to have nothing to do with cash incentives for vaccines. They clearly said no. This is not something they wanted to consider. And we then decided, well, let's at least explore whether cash incentives might work in Africa. And that was the catalyst for this project in Ghana. So we basically had 3 goals, and I'll really focus on the first one. We want to know whether cash would affect take-up. We were also interested in whether there would be spillover effects. I won't focus on that too much today, but that was the concern of most of the NGOs, right? Like the Gates Foundation basically said, we don't really want to encourage, start giving cash for vaccines because it would have these unintended consequences. And we were interested in understanding whether they would. This is basically just the consort layout of the project, but we had treatments. We treated. We had 6 villages in Ghana, in rural Ghana. We basically had a number of phases. We had a treatment phase, a post-treatment phase would measure outcomes. We then had a phase 3 where we measured spillover, and then we had phase 4 where we actually verified the vaccine, the vaccination rate of the subjects in the study. We had a total of 8,000 initial people participating in the study. We had 4 treatments, a basic CDC health type treatment, video, 45 seconds. We had a placebo 45-second video where people basically saw a video about solar charging devices. Then we had 2 cash incentive videos. These were basically the CDC video that ended with a note that they would get money if they got vaccinated. 60 CDs is about $10 and 20 CDs is about $3. Those are I won't show you the videos. Actually, they may come on. Let's, yes. So and then we had 3 different outcomes. We had vaccine intentions, which were measured right after they saw the video. We then had reported vaccine outcomes, which were measured 2 months later. And then we actually were able to verify vaccination rates using administrative records from the 6 health districts. That's just the basic sampling plan. There were basically a total of about 340 villages that participated, about 50 to 60 in each of the districts. And then there were 4 treatment treatment arms, the cash, low cash, high cash, placebo, and the health control. So this basically, you can see where the 6 districts are. By the dots, obviously they were rural, a little bit, not that far from Accra, actually. This is also not relevant. So the results. So in terms of vaccine intentions, basically you can see that we had about 6,000 subjects. About 71% in the placebo case said they intended to get vaccinated. And as you can see, about 83% in the low-cost treatment said they would get vaccinated. And this is a result that persists throughout all of the outcome measures. The really well, first of all, cash matters. It has an effect. But what's even more interesting, or most interesting here, I think, is that low cash consistently had a higher effect on vaccine incentives than high cash. So paying people $3 had a big effect. Paying them $10 made them suspicious. And that's not entirely inconsistent with other findings. And so there are a number of plausible explanations for this. These are just Mike recommended balance tests that we did. Everything seems to be reasonably well balanced. So this is just the summarizes the result: low cash, big effect; high cash, somewhat less effect. Then we had reported behavior. And basically, reported vaccines, we see essentially the same. Obviously, there's lower numbers. But again, we see that the low cost had a bigger effect than the high cost. But cash clearly had a positive impact on reported vaccines. Well, this is another Mike inspired attrition test. Okay, so these are reported vaccines. Again, low cash, bigger than high cash. And then we had verified vaccine rates, which this was quite challenging, both from an IRB and also from a collection perspective, because actually the record keeping is not all digitized, so a lot of it had to be done by, of course, I just assumed we could just go and get this on Excel sheets, but no, you have, it's more challenging actually in these rural districts. Again, we get a positive treatment effect. About 40% of the people in the low cash reported having or had verified vaccine rates, and about 32% in the high cost, and about 30% in the placebo. And again, what's impressive about this is, of course, the health officials have no idea what the treatment status is of the individuals they're checking on. They're given a list. They're asked to simply indicate which individuals on the list had been vaccinated. So they have no idea what the treatment status is, right? So that's, it's a pretty robust finding. And again, vaccination, low cash really has the big effect and the most significant effect. So spillover, I'll just briefly review the spillover. We had two strategies for measuring spillover here. One of them is that within each treated village, we reserved 25% of the subjects for the placebo videos. So in other words, 25% of the subjects in a high cash treated village actually received the placebo video. And again, 25% of the subject in a low cash treated village saw the low cash video. The idea here is that by comparing the placebo to the treated, we would get, by comparing the placebo within a treated village to the placebo within a placebo village, we can get a measure of spillover effect. And then we also, within all of the village clusters, post-treatment, we interviewed non-treated subjects to see whether, to evaluate their reported vaccine, but also we looked at their verified vaccine rates. So we have a pretty good measure of the extent to which the proximate cash incentivized subjects would affect either positively or negatively the vaccination behavior of individuals within the village. And the punchline is basically that in terms of reported vaccines, in fact, the people in the cash, these are the spillover subjects in the cash, actually had slightly higher vaccination rates than the placebo, suggesting that if anything, if you saw a neighbor getting cash for a vaccine, that would have a positive effect on your vaccination behavior. And that's consistent with reported, and it's also consistent with verified. So the punchline here is that low cash financial incentives have a big impact on both intentions, reported and verified vaccinations. High cash versus low cash is consistently higher than high cash in terms of its impact on vaccination outcomes. And there's no spillover. And if in fact there is any spillover, it's positive. Okay, so then this was my remit to think about generalizability, right? So we are doing this wave 2. In fact, I'm just starting, we just started last week, the pilot, and we just got IRB this morning, finally. So the wave 2 is looking at primarily spillover, because we're going back to the same 7,000 people we interviewed 12 months ago, and we're basically providing them or giving them an opportunity to get a tuberculosis screening. And the idea here is to see whether the people who got cash for the vaccine 12 months ago whether their behavior 12 months later in terms of a different health behavior is affected, right? And of course, 12 months later, they're getting no cash. So the question is, does that sort of make them less likely to get vaccinated, addressing the sort of concerns of the Gates Foundation, basically. But as part of this, I'm very interested in exploring whether or how to think about whether these effects generalize to a broader population. And so this part of the project is an IPA funded supplement, right? And we're implementing as part of this wave 2 of the Ghana Financial Incentive Project. And we want to know how we can build on these 6 rural districts to say something broader about the overall population. How can we make a general statement about behavior based on these first 6 districts within Ghana? And so the goal is an optimal design or data collection strategy for generalizing treatment effects to the entire Ghana population. And so here's the picture of the geography of our wave 1 experiment in Ghana. So we obviously, these are the red, the dots there, green, blue dots, all represent the districts that we've estimated treatment effects for in Ghana. Obviously, we've missed most of the country, right? So Accra in particular. And then the question is, okay, if we do this initial experiment in these 6 rural districts, what is the strategy for generating a robust estimate of treatment effects for the whole country? That's the question. And the phase 1 part of our effort in this direction is basically to create a geocoded spatial census of Ghana. And we're doing that by basically using as much data as we can, geocoded data, so satellite luminosity, health surveys, LSMS is a survey that's conducted by the World Bank. We're using cell phone mobility data, and basically we're training a machine on those data to basically create this geocoded spatial census of Ghana. The village neighborhood units are all defined by these geocoded longitudinal, latitudinal tags. And the experiments that we've done in Ghana to date all are geolocated, are all geotagged. So the 8,000 people that we've already treated have these geotags. And so we, of course, can map them to this, spatial census. We've also conducted a series of online experiments, right? And again, these are just online national experiments. And again, all of those participants are geocoded, and we have estimated treatment effects for all of those online subjects. So we basically, the modes are in-person, the rural, online, national, and in this IPA funded project, we're looking at 3 outcomes. We're looking at a simple identity treatment associated with a cooperative investment game. We're looking at the identity treatment associated with a dictator game, and we're looking at some economic preferences. And the identity treatment is people play the CIG with a co or non-co identity, or they play the dictatorship game with a co or non-co identity. And our interest is estimating the treatment effect of those identity treatments. So, and again, we're doing this in the 6 rural districts. We've done it now with 2,000 people online. So we'll have about 10,000 estimated treatment effects for our initial sample, right? And for each of those individuals, they're of course geocoded and they're mapped to the spatial census. And for each of them, we have a conditional average treatment effect. Again, we're using BART to generate conditional average treatment effects for each of the individuals within each of those 10,000 individuals, and then they'll be mapped in this spatial census. Subjects and individuals within those geographic units or spatial geographic units with no subjects will have missing values. And we'll also tag these individuals according to their mode. So the idea, the final idea, final slide here is we're going to basically use MRP on these 10,000 subjects, right? Spatially coded and spatially mapped into the census. We're going to estimate how experimental treatment effects vary across spatial units, probably using BART estimation of CATs across spatial units. And then the last part of this exercise is to use machines to figure out where additional data collection would be most informative. So basically extending the initial experiment trial to a machine-targeted augmented subject pool. And the idea here is how can we optimally identify where we should conduct additional experiments or administer these experimental treatments in order to optimally define the treatment effect for the entire Ghana population. So that's the final sort of goal of the project. That's it.
That's right. All right.
I'll take the right. I'm going to announce it.
Yeah, thank you very much, Ray. I have no slides, but hopefully I'm nevertheless well prepared. At least for the first part of your presentation, I'm not well prepared for the second part because there was not part of your paper. But let me try to link my comments to this as well. So I've got 4 remarks, 4 points. 2 are rather remarks, 2 are then potential questions for further discussion. So first of all, that's just maybe a side note remark. So my home turf is energy access. So if I don't muse about meta-scientific topics, I do research on energy access and energy consumption in the global south, especially, only actually. So it was nice to see that your placebo is my home turf. Yeah, but that's just a side note. So now, a slightly more serious remark, but that's still basically to applaud your paper. There's a lot to like about the paper, many dimensions to emphasize that are likable. I just thought it's maybe to put it like this: if you guys were economists, probably you would have pre-specified what you did. So pretty much focused the whole story about spillovers, then you see that spillovers do not really happen. I mean, there were these slight, maybe very subtle effects, but not interesting enough for top econ journals. So you would have readapted your story to that, to that effect for the low cash treatment and then the vanishing effects for the higher cash treatment, and probably you would have called the paper something like the suspicion incentive hump shape Kuznets curve or something, and put that at the center of your paper. But it was just now my kind of introspective remark about my home profession. So now two points that I have. No surprise. That's no surprise that they circle around external validity or construct validity. So from now on, I'm going to police papers on the construct that they are measuring. So not to police you, but maybe just to raise the question. So to what extent do you think, so you pitched a paper, and rightly so, across the around the cash incentive, right? But then the cash, of course, comes along certain, other features, right? So especially, I mean, you have the placebo, which is also a video, so that's already good. So right, so you can really compare a video to a video plus cash. But still, also the videos are delivered by by enumerators coming from Accra. These are students from University of Ghana, so I suppose they were like dressed like people in the capital are dressed. They come into the villages by car. So does this kind of co-determine what you observe, and if so, what would that imply for like a scaled version of the program, which would probably not be delivered by University of Ghana enumerators? That's question one. And question two, and that's potentially that this links to the second part of your presentation, and it's maybe a specific type of external validity, actually. So this is a COVID paper, obviously, and it's not the only COVID paper. We have many of them in the literature out there now. So what can we actually learn from this for the post-COVID or the next COVID or whatever, a future, right? So you are training now this machine learning-based big data kind of, tool. So how could you incorporate, I believe the very important dimension, which is not in the LSMS data, I guess, so how will the next pandemic look like, or how much is it transferable to other public health challenges, right? Non-COVID related. Yeah, thank you.
All right, do we have any questions?
Yeah, super cool project. Really interesting the way you're using these kind of greedy data mechanisms to then extrapolate. I have a question about the fact that you're combining these different samples. So you have some people who get this treatment in person and some people who get it online. And that's not random, right? So you're deciding who gets it in person and you're deciding who gets it online. So I'm wondering, do you see treatment effect heterogeneity across these two delivery mechanisms? And if you do, how do we deal with that later in your extrapolation exercise, right? Because this algorithm will basically think that certain kinds of people get this treatment online and other people get it in person. And so the scale up that we are sort of imagining is then one where that's the case exactly in the way that you have done it now, even though that's probably not particularly, that's like a practical constraint that made you do it in this precise way, right? So I wonder, what do we do with that?
So that's a very good question. So ideally, in the design that was part of the IPA project, we would conduct the experiment both online and in person within urban and within rural areas to try to capture what you're talking about, because I think that's really important. I hope we will be able to do that. It's sort of a funding contingent, but that is the optimal design, and you're absolutely right. And I can tell, and it's even a little bit more, I mean, there's an even more interesting or additionally interesting feature that we observed in what we did in the actual incentive project, because so there was, we did the treatment to the 7,000 people in person on templates with enumerators, fine. And then we wanted to do post-treatment measure of reported vaccine. And so my idea was simply to do all of that on the telephone. And then, of course, this was my first, I should sort of point out, this is my first RCT in Africa, anywhere, but in Africa. So I said, well, we'll just do it on the telephone. Let's just call them and do it. And they said, so they tried it, and they got about 40% of the people on telephone recontacted. And so we actually had to do the other 60% in person to get reported vaccine. And that's fine. The results that you see are for the reported are basically combining the telephone plus in person. But if you look carefully at the data, which obviously, I did somewhat, the people who were contacted in person rather than on the telephone have very different reported vaccine rates and treatment effects than the people on the telephone. So it's not just online versus not online, but there's clearly even subtle differences in the modes, particularly in the rural areas, as far as I can tell, can have very significant effects. So ideally, we'd like to capture this. We'll see whether we have enough resources.
Thanks. I was also really excited about this way of selecting new data sets. I'm worried your algorithm is going to select a set of kinds of places that have no overlap in the characteristics with your data. So, for example, places that are urban. I'm not sure what those other characteristics are. Maybe places in the north. And so your algorithm, because it's in one shot, is going to spend all of your data on those kinds of places, and then you might decide ex post that wasn't actually the best way to spend your money, and that you would have liked to spend a fifth of the money, find out whether places in the north have kind of similar treatment effects to places in the south, places in Accra have kind of similar treatment effects to these places, and you would have been better if you had spent more of it on some income groups that you had relatively small sample from. And so it seems like a great setting for an adaptive design where you're doing 7 rounds of it and just keep updating it so that you don't overspend in some places that currently you just don't have enough sample in.
Okay, so that is the other. So yeah, I agree 100%. I think, the notion of an adaptive design here maybe this is already sort of an adaptive design, but it doesn't explicitly, and this might be really cool, it doesn't explicitly incorporate an adaptive design into the definition of the sample, so over different waves. So that would be a great idea, and I had not thought about that, but that would be. I'm doing this in another project on the adaptive design, but bringing this in here would be very cool. I think you're right. Yeah.
Just as another potential suggestion to follow up on that.
Get on with your talk.
Okay, so the slides are visible now.
Yep, perfect.
Fantastic. Okay, so thanks very much. So this is joint work with Mike Gechter, Rajiv Dehejia, and Christian Pop-Elekesh. There have been various iterations of this. I will kind of lay out the problem that we're trying to address, where we are with the theory and an illustration, and then kind of update on progress. There we go. So we have a lot of recent work on policy learning methods. So there's a whole stream of research now on the use of agnostic machine learning tools to kind of characterize effect heterogeneity and then feed that into policy learning decision frameworks, a lot of new theoretical results about that, and a lot of algorithms to support that work. And then there's also been recent advances in the structural analysis of RCTs as a way of deriving actionable insights from RCT data. So in fact, there's this new, JL, the best of both worlds paper that is talking about the updates in that. And so insofar as you have a collection or a given randomized control trial and you want to translate it into a policy, there are different options available to you. And so the question is, which one should you use? And so in order to answer that question, you have to have some way of evaluating models for treatment regime optimization. Usually a policy learning analysis is trying to come up with a way of defining an optimal treatment regime, which is typically characterized in terms of targeting of treatment. So basically prioritizing the individuals or clusters or whatever that would be the targets of policy intervention. And the problem here is that the best performing model or method for deriving an optimal treatment regime is going to depend on the criterion that you use. And then secondly, one's ability to assess the performance of a model or a method is going to depend on counterfactual knowledge. And so, if you have an RCT at your disposal and you want to use it to derive an optimal treatment regime, you have to contend with these two issues. And you can illustrate that in a toy example. So here's a toy example where we've got a binary covariate that serves as sort of a stratification indicator for treatment assignment, and then another continuous covariate that exhibits this sort of discontinuity in its distribution or its density, and then binary potential outcomes. Okay, and so you can imagine an experiment that ends up looking like this, where we had stratified random assignment giving rise to treatment vector T, and then outcomes observed as Y, and then you've got your covariate data. And let's suppose that, as a policy planner, we have a cost of treatment that we want to account for. And so the policy rule that we'll use is that we would treat a person if the predicted treatment effect for that person is greater than the cost. And so we can set the cost at 0.25. But here the question is, okay, well, what model should we use to analyze the data? What methods should we use in order to derive these conditional average treatment effect estimates, and then ultimately this treatment regime that satisfies this cost consideration? You can think of like a logistic regression with one-way interactions as one way of modeling this, or you can get fancier and think about a classification algorithm that implements an assumption that you might have on the data generating process for the potential outcomes here. Maybe this is a situation where monotonicity in the potential outcomes is very plausible. Okay, so we've got these two options. These are two different methods. The question is how to evaluate them. We could just use conventional model diagnostics. And so we could calculate root mean square error with respect to conditional average treatment effects. Of course, in order to do that perfectly, you'd actually have to know the potential outcomes, which you don't know. Let's suppose that we're in the magical world where we did have the individual level treatment effects revealed to us just for the sake of this evaluation exercise. You could also look at something that's a little bit more like welfare oriented. And so stepping away from the model somewhat, you could think, okay, well, what is going to be the gain from a treatment rule that is defined on the basis of the given model, okay? And so you could use a welfare-based criterion like that in order to evaluate the performance of the model with respect to what you're actually trying to do. And what you see here is that, generally, if you kind of run through different iterations of this data generating process that I specified at the beginning, these two things will be correlated. So it's not surprising that, a model that's better fitting is also going to tend to give you recommendations that do a better job in terms of welfare. So on the x-axis here, this is showing how well in root mean square error terms the regression is performing relative to the classification algorithm. And then on the y-axis, you have this sort of welfare gain measure for regression relative to the classification algorithm. And you can see that, generally these two things move together. However, it's not so uncommon for the model fit to be essentially equivalent. sorry, the model fits to vary substantially, but the welfare implications to be equivalent. Can you see my pointer here? Is that visible?
Yes, it is.
Okay, perfect. So this is actually something that's fairly common when you think about welfare-based criteria as compared to model fit criteria. And the reason is that like a model can fit better in ways that are sort of irrelevant for the implications for treatment assignment. And then you can even get cases where a better fit model defined in these root mean square error terms actually does worse in terms of welfare. And so here we have cases where regression is fitting worse, okay, but it's actually doing a better job in terms of welfare. And so what's happening there is that the places in which the model is fitting worse are sort of irrelevant, and the places where it matters with respect to welfare, it's still doing quite well, and in fact, even better. And the point is that like a criterion like root mean square error is going to be sort of agnostic in the way that it's essentially weighting different units, and that weighting is not necessarily going to be the same as the weighting that a welfare criterion is giving. And so the choice matters, okay? So in the paper, what we do is to address these problems, okay? So, oh, sorry, that was the first problem, the criterion problem. The second problem is that being able to actually do these types of assessments depends on counterfactual knowledge. And so, you know, this graph was something that you'd never be able to make in the real world because I actually had to use the potential outcomes from this table in order to construct it. So it was a bit of a cheat. You can use what are known as proxy scores for individual level treatment effects. So you can use like a Horvitz-Thompson score, which, you know, just works with the observed outcome, but in expectation is equal to the individual level treatment effect. But of course, it's going to be super noisy. So you can see, you know, for the different units in the experiment, what the proxy scores look like, depending on whether or not, you know, your average treatment effect is 0 or 1. They're obviously going to differ on the basis of the stratum specific assignment probabilities. And you can see that, I mean, you know, these proxy scores can land you very far away from what the actual individual level or even conditional average treatment effects are. And so while a proxy score can work, you know, on average, they're very noisy and can be unreliable for that reason. And so, you know, there's been some recent work on trying to do a little bit of a better job of coming up with proxy scores, given what is essentially the fundamental problem of causal inference. Okay, so the paper is trying to address these two questions in terms of this first question about deciding on your criterion. We're going to have a criterion that is in fact motivated by welfare considerations. And in order to do that, it's kind of hard not to start to delve into the specifics of the cases in which you're analyzing. And so I'll show you that in a minute. And then as far as assessing model performance, what we can show is that, well, if the goal, you know, is just to evaluate whether we're making progress in terms of methods, and so we're just trying to characterize, okay, well, somebody's proposed some new machine learning algorithm or some new structural methodology for generating you know, treatment regimes. It would be nice to have, you know, some sort of framework in which we can evaluate whether those things are actually contributing to doing a better job, similar to like in the, you know, observational studies methodology world. We had the Lalande data that was like this benchmark. If we could have these sorts of, you know, sort of frameworks and benchmarks to work with, it'd be helpful. And so what we show is that you can use experiments actually to evaluate ex post the performance of these methods or models. Okay, so let's look first at at the criterion problem, the welfare implications of an intervention regime. So I'll call that vector P. So we're thinking about a binary treatment situation. And so this is just a vector that for a given population is going to determine essentially who's treated and who's not treated. Okay, so that's how we'll define an intervention regime. The social welfare can be thought of in terms of a difference between, the outcomes that the treatment regime generates for its intended beneficiaries minus any fiscal imposition. Okay, and then you can break that down into individual level contributions to this, total beneficiary outcome and total fiscal imposition. Okay. So then what that means is that you can construct a welfare score that each individual contributes that's defined in terms of the difference between this beneficiary outcome and then the fiscal imposition attributable to, the way that that individual is being treated. We can just assume that the fiscal imposition, given that somebody is not treated, is going to be 0 and sort of normalize everything to that. And then what's going to happen is that, if you're trying to come up with the optimal treatment regime, then what you're going to try and do is, define a vector of treatment assignments such that for each person for whom their welfare score under treatment exceeds their welfare score under control, you're going to set it to 1. Okay, and so these are just different ways of writing out that maximization condition. All right, so defining a welfare score here, I think requires that one get into the particulars of what, a given class of interventions is trying to accomplish. And so we are working on looking at CCT programs and looking at ways of basically defining priority or targeting criteria for CCTs. Okay, whoops. And so in our case, we're going to specify the beneficiary outcome component as a function of, whether the person is enrolling in school, that's ultimately the outcome, then a measure of household income, which is going to allow us to take sort of inequality considerations into account, and then other individual level characteristics, okay? Then the fiscal imposition, given that it's a CCT, is going to be one that basically adds up the transfer payments that have to be made. So those are going to be conditional on whether the person actually goes to school. There is going to be the grant amount G, and then that is going to be mapped through some function W that can account for, deadweight losses from funding those grants and other factors that we want to account for in terms of funding those grants. Okay, and so that means that the beneficiary outcome difference is just going to be defined in terms of the difference between those two functions. Okay, in this case, so I kind of previewed this, we are going to think about the different types of potential outcome combinations that we think might exist in the world. So we're going to assume that there's a no defiers situation. So nobody is like choosing not to go to school because they're eligible for the transfer. And then we're also going to assume sort of exclusion restriction in that, this value, this beneficiary outcome value that we're defining is affected by treatment only through enrollment. So one could potentially account for, other sorts of things that might happen as a result of being affected by treatment. But for the moment, we're just going to put those to the side. And so then that means that in terms of evaluating like the contribution of this intervention to different types of individuals and households, you can think about 3 different types. There are the always takers, who are the people that would enroll no matter whether they're eligible for the CCT or not. Okay, and so in that case, the value of being eligible for the CCT is pure transfer value, right? So the enrollment outcome is not going to change, but what's going to happen is you're going to get this incremental contribution to income, okay? The compliers then are people who are induced to enroll, okay? And so the treatment effect on this beneficiary outcome function is going to be bounded between 0. So if you're thinking in like a Roy model type setup, or, essentially like a choice model type setup, these are people for whom the value of enrolling, must have been less than what the transfer was. It could exactly offset that difference. And so, those are the people for whom this, sort of value outcome would be the same under treatment and control. And then the sort of upper bound could be defined by the always taker effect, because if it were the case that the value of enrollment exceeded the transfer, then they should be enrolling anyway, and so they would be always takers. So the treatment effect on this value outcome is going to be bounded in this range, and then the never takers are people who don't benefit by being eligible for a CCT. Okay, so these inputs can allow us to characterize how for subgroups conditional on covariates for whom we predict different size treatment effects, we could characterize the implications for beneficiary outcome. All right. We then want to specify this beneficiary outcome value function. The inputs that we use to specify this is essentially a measure of the present discounted value of increased tax contributions from an additional year of education plus the income boost from the transfer. So remember, we're mapping this to the social planner who's trying to define an optimal treatment regime. And so, casting everything in these fiscal terms is, arguably what the social planner is going to care about. And then we're going to make this convex essentially in whether or not an individual household or on a per capita basis an individual's income is less than the mean. So the smaller your income is relative to the mean, the sort of in a nonlinear way, in a convex way, the greater is the value of increasing that income. Okay, so putting it all together, what we have here is a measure of sort of the welfare from a treatment regime that is determined by some method M. Okay, it's going to be based on the value of this criterion, right? Where for all the units in the population, this treatment regime is going to define a treatment value, which is going to have implications for income and enrollment, potentially, and then we're going to subtract off this cost that's due to the conditional cash transfer. I didn't mention the so the grant is like literally the amount of money that the individual or the household receive for that individual going to school, and so every CCT has a schedule for that can vary on the basis of individual and also potentially household characteristics. And then, in the paper, we use this kind of, leaky bucket, dead weight loss multiplier to specify this, okay? So method N is going to give us, treatment recommendations for each unit in the population. That's going to be mapped into this beneficiary contribution value. And then also there's going to be costs that are dependent on whether they're made eligible for the CCT and then whether they actually enroll, okay? And then, this treatment recommendation is going to be based on whether the method estimates, these terms, to be greater than 0. Okay, so methods are obviously going to differ in how they derive these treatment regime recommendations. on the basis of the covariate information that we feed into it. So you'll usually, if you're going to use one of these policy learning, machine learning methods, you would, fit data on an RCT, for example, where you're estimating conditional treatment effects. That's then going to characterize, how all of these things vary essentially, and is going to, then inform, whether a given unit is determined to be, somebody that we would want to treat. Okay. All right, so that's the way we motivate a criterion. Then the next thing we do is to show how you can use an ex post experiment in order to generate the counterfactual information that you need to evaluate the performance of a method under this welfare criterion. Okay, so what we can do is just say, okay, well, ultimately, what this welfare criterion is doing is giving us individual level scores that we can use to map outcomes that are really just these enrollment outcomes, conditional on treatment eligibility, to some welfare relevant metric. Okay, so that's the way you can just think about what the criterion is doing. It's just redefining an outcome. And so what we care about essentially then are just like treatment effects on this outcome. Okay, and so what we want to do is maximize either the average or the aggregate treatment effect on this outcome. Okay, and so the welfare contribution from a given unit under some method M, right, is going to be based on what that individual's, what you could call welfare score is, given the treatment that that method determines as being optimal for that unit. Okay, and so then we could say mean welfare under a given method, right? We're just rewriting these individual level contributions as such, is just going to amount to this, right? It's just the expected value of a what you might call like a transformed version of the outcome, putting these things together, right? Under treatment, if they're treated, or under control, if they're under control. Okay, so we can have two assumptions that we work with. Okay, the first assumption is that the methods are going to be assigning treatment on the basis of covariates, and that's the case with most methods in the policy learning and structural literature these days. And so we can basically say that the recommendation for whether a unit I should be treated can just be written as some function of covariates. And then let's just assume that we have a randomized experiment, or even weaker, a conditionally randomized experiment. Okay. Then in that condition, under those two assumptions, then this term, which was that first term in the mean welfare, can just be rewritten in terms of observables. And so what it means is that, and you can do the same for the other terms. So that means is that the sort of average welfare, this aggregate welfare score that we defined under method M is identified from this ex post experiment. Okay. You can also do contrast between two different methods. So for a given unit I, their welfare contribution, given the recommendation from method L versus method M, is just going to be this difference, which we can just rewrite in these terms. Again, these are sort of just transformed versions of the outcomes. We can state that in terms of the means, and then use that to define what we call the welfare contrast. Okay, so it's just a difference in means between transformed outcomes. And so on the basis of the same logic as above, we can see that this welfare contrast is identified if you have an ex post experiment to evaluate. So to be clear, like the kind of workflow here is that you have some data, could be experimental data, or sometimes there are structural methods that even do sort of like ex ante policy or intervention analyses on the basis of just survey data or something. You have some data that you use to fit different methods or different models. those data generate treatment recommendations for units in a population on the basis of covariates. You then take those recommendations to some experiment that's available for ex post evaluation, derive what the treatment recommendations would be in that experiment, construct these transformed outcomes, and then essentially estimate treatment effects on those transformed outcomes in order to evaluate how well different methods are doing. Okay, so that means that for ex-ante treatment recommendations based on covariates, we can use experiments to do ex post inference. And then the ex post inference can be design-based and therefore agnostic about the DGP. And so, estimating something like this can just be based on the design of the ex post experiment. And so, we're not baking in any assumptions that the methods or models themselves may have used in order to generate the treatment recommendations. We're doing a fair evaluation on the basis of the design of the ex post experiment. And you can use pretty much like any design consistent estimator of a treatment effect in order to estimate this welfare contrast, for example. Okay. As far as doing inference, you can use any design consistent estimator, as I said, for example, the welfare contrast. The same holds when we're trying to characterize the welfare levels under different methods. This thing is going to be distributed on the basis of a few different sources of variability. The first is that the treatment recommendations themselves that are coming from the different methods are usually calibrated on samples from some reference population. So if you want to fully account for the performance of a method, you should probably account for that variability in the recommendations it might generate, okay? So those then are inherited into the ex post evaluation, which you apply to the ex post experimental sample. The outcomes that you observe in that ex post experimental sample are going to be variable potentially on the basis of sampling from the target population in which this evaluation is being done. And then of course you want to account for the variation due to treatment assignment, okay? And so as far as inference goes, the variance of any welfare contrast estimator can be decomposed into two components. The first is the sort of design variance, that's the sampling and randomization variance that's induced by the design of the ex post experiment. So that's equivalent to like the name invariance in an experiment. And so you can estimate that with any design consistent variance estimator that you use to estimate the delta hat in the first place. And then the second part is the variance that's going to be propagated given, whatever variability there is in the reference context that you use to fit the model. Okay, so this first step where the model that you're using to generate the treatment regime recommendations itself might have some uncertainty associated with it. Okay. Yeah.
If you want some feedback from the room, I suggest that you wrap up like in 2 minutes. Is it?
I can do that, no problem.
Great, amazing.
Okay, so the first component, again, can be estimated with any design consistent variance estimator. The second component you can estimate by just bootstrapping from the original reference samples that you use to generate the recommendations, okay? So, there are ways, insofar as the design consistent estimator that you're using here follows usual properties, then, again, you're literally just doing a test on an average treatment effect. If you have multiple models that you're contending with, then you want to address multiple testing issues. And so that's something we can do. And so I'm just going to do a very quick illustration that is going back to the toy example that I had, but doing it on a larger scale. In this case, we can think about a DGP that resembles a toy example, but scaled up a bit in terms of sample size and in terms of the nature of the covariates. And we can evaluate an approach that applies the monotonicity restriction, like I discussed before. There's like a classifier approach that Callas defines that you can do that. versus instead of using the logistic regression, here we'll be more agnostic and use like a random forest approach. So we have more covariates, more data. We're going to use a more flexible model. And what he shows is that, when monotonicity holds, you actually get a lot of benefit from incorporating that assumption into the treatment regime recommendation as opposed to not. Just jumping to the conclusion from this, what we can show in this example is that for this case where we have a sample size of like 500, you can see that, okay, in the first instance, the distribution of a design consistent estimator of the welfare contrast is going to be normally distributed, so that's good. We can do the usual inference, but what this shows you is basically the contributions of the two variance components. So the gray is basically showing you variance due to the bootstrapping of the recommendations, okay? And so that's that first stage variance. And then any additional fattening of the tails that happens here is due to the design variance. And you can see that, things can get very noisy. This was a sample size of just 500 as a quick illustration. In order to adjudicate between methods, you're probably going to need fairly large sample sizes. Okay, then just wrapping up. So what we're doing now, this is all in progress, and the biggest sort of holdup here has just been data harmonization. So we're working with CCT data from a set of countries, harmonizing all that data and trying to calibrate, the machine learning models and the structural models. And so that's the work that's going on now. It's turning out to be like a huge enterprise, but hopefully will be done in the coming year. And, to wrap up, the goal here is to have some sort of framework for evaluating policy learning and to address these two problems regarding the criterion and counterfactual information. And so we propose solutions to that, including welfare-informed criteria, and then the use of ex post experimental data. And so we think that this gives us a framework for domain-specific assessment of progress in policy learning methods. All right.
Thanks so much, Cyrus.
Thank you very much.
You're discussing and then on a center slides, and yeah, yeah. Yeah, go ahead. Oh, yeah, no, it's fine. Like we have breaks built in, like we're not going to take away your time.
Oh, thank you. Thank you. Okay, good morning and welcome back. I apologize that we're going to start the morning with math. So hopefully I'll keep you all engaged. This paper that I'm going to talk about is about half written, as I said to Sylvain when I sent it to him. Sorry, there's the first half and the second half is a sketch. But it's with a student of mine, Mihalis, and I think it's been kind of fun to write. Okay, so the question that is motivating this work is this: what works for whom and under what conditions? Which is a question that I hear a lot in the sort of evidence-based world. Particularly in education. It's almost a tagline that people say. So the motivation is if treatment effects vary, obviously you know this, that that is very likely that our sample average treatment effect is not the same thing as the population average treatment effect for whatever population that might be. And that has led to a variety of methodological adjustments. There have been methods for assessing if there's differences, methods for adjusting for those differences, methods for adjusting standard errors, all sorts of estimators. I've been working on that for a while. But everything to date really in this sort of methods world has largely been about estimates of the population average treatment effect. We've defined the generalization problem as, what if our sample is different than the population and the average treatment effect we get is a biased estimate of this thing that we care about? And so a kind of a nagging question that comes from that at some stage is, if treatment effects vary, why do we care about the average at all? Like, why are we so obsessed with fixing it? It not only means that our average is biased, it kind of fundamentally changes the nature of our work. So that leads you. So I was going to pair this with, I think if we're thinking about average treatment effects, I think of those as scientific questions, right? So does it work? There's a lot of sort of question within science, and that's why we probably think about internal validity so much, is we want to know about causality because we're building scientific theories. But when we move to evidence-based policy, that's a big move. Do policymakers need to care about these averages? And so in evidence-based policy, again, we're back to, why do we care about averages? So kind of either way, if we're thinking just from the context of I'm thinking about my sample and bias, or if I'm thinking about from the evidence-based policy world from decision makers, again, we're back to the same question: why do I care about the average? So I think what we're really interested in, I've become increasingly convinced, is we're interested in predicting causal effects. That's what evidence-based policy is about. I think of science as backward looking, and prediction is forward looking. We want to predict what's going to happen in the unit and from the study. And what we're really interested in is predicting, not for those in the study what their treatment effects are, but for units outside of the study. So for somebody coming along, will it work in my context, in my place? So more formally, what we're trying to say is, for a unit J, and I'm going to be clear here, unit could be a lot of things. You could think of unit as site. You could think of unit as person. I do think that in a lot of evidence-based decision-making places, we're thinking about them as sites, like or governments or cities, or like who would be the policy maker, or where would the policy be enacted? Schools, for example, I think of them often as collections of people more than as individuals. But this same idea applies if you were to think about them as individuals. We're interested in predicting what somebody's individual treatment effect is, which is the difference between what would have happened to them. These are the potential outcomes, the difference between if they had the intervention versus if they didn't. There's a lot of new methods. So there's been rapid development. It's been fascinating to me how disconnected these two literatures have been: generalization and heterogeneity. And they're like two sides of the same coin, and yet two totally different groups of people not really talking to each other for the most part. But there are a lot of great methods in this sort of treatment effect heterogeneity world, like Bayesian additive regression trees. There's some causal forest work that is looking really remarkably good. At the American Causal Inference Conference, maybe like three years ago, there was a data challenge where people were sort of head-to-head comparing methods for predicting, for sort of understanding heterogeneity and predicting treatment effects in heterogeneous environments. And this Bayesian causal forest actually turns out to be one of the best sort of methods there. Got generalized additive models. These are all non-parametric, is my point. They're all non-parametric methods, machine learning sorts of methods. And so we've got this sort of puzzle that we tend to define estimators and tend to develop studies in a very parametric sense. We have a sense of, we use closed form formulas for those. When we're developing studies, you do a power analysis, but then we're talking about estimators that are using some non-parametric things that are black box. Like, I don't know, the computer is doing this cool thing. It can probably solve all of our problems. Which is what leads to me saying prediction is magic, right? Like, it can solve all of our problems. So I have spent the better part of the last decade telling people that they should plan their studies better. Like, you can't, saving generalization for the end is just bad, because you're going to reweight, and you can't reweight parts of a sample that don't exist. You can't, and if you have to do a lot of adjustments, you get a big penalty on your standard errors. And so we really need to plan to do this. And, that's really been focused on this average effect. But what I increasingly kind of am hearing in the world sometimes is this sense of like, well, okay, that's expensive. Like it takes a lot of time and resources. Why don't we just skip to predicting? Why don't we just skip to predicting and like, we don't care about the average. We're just going to do some prediction instead at the end. We can just get our sample and then we can just predict from there. We don't need to worry about this. This seems like it's kind of magic. And that's sort of the motivation for what I'm going to show you that I've been working on, which is to say like, no, that's not true. That design does turn out to matter there too. Okay, so I'm going to start by talking in a sort of parametric sense, and I'm going to be clear that like I'm not like sort of not non-parametric. I come from sort of a school of thought that is very parametric, and that's because it's about designing studies. So if you were to say, I want to design a study, and I want to do a power analysis to know how big the study is, you have to make all of these parametric sort of simplifying assumptions to be able to do that. And what I'm trying to do is to connect the predictive world, which is very black box, to get formulas that are in the same space as what we already have to sort of be able to communicate well with that in that design space. So I'm going to say we have a sample, we have n units in the sample, and we're going to think of our sample as a random sample from some population, population A. You could, for all intents and purposes, think of the sample as the population A and the sample as the same thing. It could be the sample average treatment effect. It's just, but it's helpful for notation. And we're going to say we have some covariates. Those are the moderators. And we've standardized them in relation to A. So that just means I've subtracted the means divided by the standard deviations. It makes a bunch of math easier. And we've got our individual treatment effects for each person. And so if we do this, you can basically put a model on each of these. So I'm saying, okay, well, I've got a Y1 and a Y0, and in each of those cases, I can put a model. So they each have a mean, and then they each have a regression coefficient. And because I centered the covariates, this is going to be the average. These are like the averages. And then I've got the, this is the moderator relationships, and then this sort of residual at the end. So you've got these three components, and you can rewrite that then into three parts, which are the average treatment effect in the sample. So in population A, this is the average treatment effect. And if all the covariates are on their average values, then they're 0. So this all falls away. So then that's the average. And this is, you can think of these as like deviations, right? They're like covariates times regression coefficients on if your individual effect is bigger or smaller. And then there's this residual at the end. In the literature, people would refer to this as idiosyncratic variation. So I want to say it's Meritrix and Ding, or Ding and somebody has a paper where they decompose treatment effect variation. And so they would say this is like the systematic variation in effects, the part that can be explained. And then there's this part at the end that can't be explained. The difficulty in all of causal inference is this idiosyncratic variation, right? So I'm going to call it tau squared A here. But the main point I want to show you is that this idiosyncratic variation has to do with this correlation. It's a correlation in potential outcomes. And by the fundamental problem of causal inference, we can't know what that correlation is. So part one here is getting a sense of how good our predictions are is going to be hard because there's this thing that we can't know. And so you can, and then these other parts have to do with the variation in Y0 and Y1, and we can get estimates of those. So one question is, what do I do with this correlation? How do I think about it, right? So I sort of thought through a few examples. So we could say it equals 1, that they're like perfectly linear correlated. That is to say that the error, the idiosyncratic variation under treatment and control is exactly the same. It seems like a pretty hard assumption, is to say all things left. There's nothing left that can't be explained. Everything that is left is actually exactly the same between both, and we can subtract them off. And that gets rid of this idiosyncratic variation altogether. Then there's none of it. It's all gone, basically. Another is to say that they're completely uncorrelated. So if they're completely uncorrelated with each other, that whatever is left after I've explained things, I don't know, it's really, truly random. And then another one is to sort of think through, okay, well, what if it seems like an assumption that seems fairly credible to me is that the variation in treatment effects is probably smaller than the variation in outcomes. And so then that kind of logic leads you someplace. In all of the cases, it roughly leads you, if you kind of look through these three cases, it leads you to this correlation being somewhere between roughly 1/2 and 1. And so it gives you a little bit of space in there for some bounding. Okay, so you guys look like you're following along. All right, so we've got a randomized trial. And the idea is I've got N0 units in the control group and N1 units in the treatment group. And I'm going to make predictions. So I've got data now to do this. And I'm going to assume, by the way, I'm assuming a nice situation, which I have all the same covariates, I've got all this information. So I can build this model, right? I've randomized. I can build a regression model in my control group data. I can build a regression model in my treatment group data on the same covariates. I get estimates of those. And because I centered, these are the means. And so putting these together, I can get individual treatment effect predictions, right? So I can take a model. I can literally for anybody, go take their covariate values, and then I can plug it back in here from the estimates I get, and I can get for each of these, I can get them these together. And notice that these estimates are independent of each other because the estimates are coming from different data. Okay, so a question would be in the sample, let's say in the sample average treatment effects, to remind ourselves that in the sample, we either see people's Y0s or Y1s, so we don't even see individual treatment effects there. So if we want to talk about individual treatment effects, even in our sample or in population A, we have to be doing prediction. We want to know, so if we use that approach that I just gave you, we want to know how close these predictions are to the true values. So that requires us to have some measure of is it good, right? What is the right measure of is it good? The sort of typical measure is the squared prediction error. The squared prediction error is just the average value of the estimate minus the true value squared, the expected value of that. And it's conditional on the covariates. And you can do some math. All right, so good morning. Here's some math. You can do some math to get to this. And so what I want to show you here, I'm going to highlight some parts that sort of speak to me, I guess. So one part here in this prediction error is because I centered the covariates, this is actually the variance of the variance of my average treatment effect. So this is a familiar formula. If I just said, what's the average treatment effect variance, would be it. But now I have this additional, so that's the one. Then I have this additional part here, which has to do with the, that should be a negative up there, I'm sorry. This has to do with how the covariates and something to do with the sort of variance covariance matrix in population A. So how variable those covariates are. And then I have this part at the end, which is that part that's unexplained. I think it's easier to see this in the single variable case, and this may even start to look like a formula you have seen before or something like it. So this, again, I've got average treatment effect variance here. I've got the 1 plus, and then this part, it may be something that you've kind of seen before if you took a introductory regression class, right? Because it's part of the standard error actually formula. And so it's got this distance between how individual X and its average. So how far away is it? It's also divided by the variation in X. And then I've got this thing at the end. So I've got the standard error in there. The nice thing too in this formula, so this is the standard error part that I'm used to seeing. I can estimate this fairly easily, right? Because I can just plug in estimators. Well, I have the sample estimates of each of these. I know these covariate values, so I can plug these in. I've got this thing here, which has this correlation in it that I don't know, but I can, everything else in here is something I can estimate. And because I can estimate it, I can get, I can get a good estimate of this error. And you could use this error to get something like a confidence interval, right? So if I were talking about the average treatment effect, I would say we should have a confidence interval in that, but prediction error is bigger, right? So if you just think back to regression, to a regression class, there's this additional component, and this additional component is coming at the end, which is the variation in a new, the residual in a new observation. So that's, and so that's why prediction error in general is bigger than, so predicting has bigger error in it than inference, which is backward seeking. But you can use that and you can get something like this. And so my motivation here is thinking, okay, what am I trying to do? I'm trying to plan a study. So I would want to plan a study so this prediction error is small. Now that's specific for each prediction. So if you look at that formula, if I'm predicting for somebody really far away from the mean, this is going to be much bigger prediction error than if they're right at the mean. So you have different prediction error for different values. It's hard to work with. So you can work instead with the average of those. So if I said the average predictive error across everybody in this population, what would that be? And that's just taking the average. Again, I've left off this inverse sign, but you've taken the average of this. And so that involves taking the average across all of these values of X. And it turns out very nicely, this gets you back to a formula you may have seen, because this expectation becomes P. It just becomes the number of covariates in the model. And that comes because, well, it's about traces. Never mind, I'll save you. So it becomes the number of covariates in the model right here. This is a familiar formula. If you were to look up a definition of AIC or mean squared error or Mallow's CP or any of these sort of standard old formulas in a regression book for prediction, they come out to something. They come out to something that has a very similar form to this. The part that's new is that we have two groups here, and that we have this error is slightly different, but the format of this is very similar to something that has been known in regression for a long time. So you could probably piece this together The idea is that some intuitions we have that in doing prediction, you get a larger error than you do in inference, that you have a larger error when you've got covariate values further away from the average, and that it has something to do with the number of covariates, right? So that P in there, it gives you a sense that there's a bias variance trade-off of every time I add a covariate, am I increasing the amount of variation explained enough to offset the need to add the covariate? And that's what a lot of sort of predictive methods will do is sort of looking through various combinations of sets. Like if you did a forward, backward, variable selection, sort of old school methods that are looking at, my R squared increase versus the covariates of the model. Okay, so that's what we know. And and my worry has been that people are going to take what we know and apply it way beyond into an area that doesn't apply. So I'm going to frame this now as out of sample prediction is sort of what we're doing. But you could think of all of what I'm talking about as also being framed as training data versus test data if we were talking in the machine learning kind of environment. And I sort of pulled this graph from Google Images because part of what it's pointing out is that we have an extrapolation thing that we have to be really worried about when we start moving into this prediction space. Okay, so if we move into a new population, I want you to think of it as this. I have a sample and I develop my model on this population A on my sample, but I want to use that model that I've developed to predict for units in a different population what their values, what their treatment effects would be. So I'm going to do the study in A to predict in B, and you might think that seems silly, but that is exactly what we do all the time. And so again, in B, what are we trying to do? We're trying to predict treatment effects. And so I'm just using J, like subscript J now, just to be like J is something new versus I was something old. But again, I can write this out as, okay, well, so for a new unit, it's something about the average treatment effect in A plus this residual that I can explain that has to do with the relationship between X and treatment effects in B, and then the same residual. So I have something very similar than I had before. And so because of centering, I've got I'm going to continue to center the variables around A, not B. The choice for that is really because it makes nice properties of the estimators in A that we're going to use. It makes the intercept and regression coefficients independent. Okay, so same question. Are they any good? Okay, so first thing in looking at this is actually we could be concerned about bias now. So you might have noticed that little delta I had a B on it, and there would be an A in our sample. And so the first concern we have is that there could be bias in our predictions, right? So even though I built the model in one group, the question becomes, can I extrapolate that model to a different group? And I'm always assuming kind of implicitly, I think that my A group is much more narrow than my B group, right? So, so this idea in the machine learning literature is called covariate shift. The idea that the relationships between X and Y might be different if once my distribution of covariate shifts. And so my model might not perform as well. So what is this? This is extrapolation bias is what this is, right? So I've got another one of these sorts of examples over to the right that if all of my data, if I had data that went through here, I might build a linear model here and then predict it to continue into B, but actually maybe it's a nonlinear model. So I think one of the places that we see this is you could have a covariate that is constant in A, but that varies in B. So let's say in A, I have only urban locations. I can't put urbanicity into my model because it doesn't vary. It's constant in A, but now it varies in B. And so maybe truly treatment effects do vary, but I have no way of estimating if it varies or not. So it doesn't even make it into the model as a result. So that's one way. And another way is a restricted range. So in A, I see a different range of values of the covariate than I do in B. And the tricky problem here is it can be hard to know that in advance. Like you have to, some of this you can actually tell, like you could look at covariates and compare the covariate distributions in the two groups. But the question of then, if in the data I have where I can build a predictive model, I don't have variation in a covariate, but I do in B, I can't build a model around something I don't have data on. So in the generalization, in the average treatment effect case, I would have called that undercoverage. And it's the same idea here. I've got some like just data that's missing that I have no information about. I can do the same predictive error as I did earlier. And okay, so I keep leaving off this inverse sign. I'm really sorry. It's going to drive me crazy. So when you write this out, this is the predictive error. I want you to notice a couple of things. Same formula as before. Seems this to be the same formula as before. Okay, so this is actually the same. This has to do with our estimation process. So these are the variations in potential outcomes in population A, which we have data on. But I want you to look over here. This is the variation that's left over idiosyncratic, and it's in population B because I'm predicting into the future. I want to predict into the future. That little eta J, the part that's not explained, has to do with the variation that's in population B, not in population A. So I could have this problem. So if you think about it, maybe I have covariates. Like for example, maybe in population A, I have a lot less variation. And in B, I have much bigger variation. So if you think, oh, I selected my sample to be somewhat homogeneous, because that's something we tell people to do when planning studies. For the average treatment effect, you want to remove variation. It makes you have more power. But that in population B, it's much more heterogeneous set of people, then it's possible that these variances here are smaller, for example, than the variances that would go into this other term. but I don't have this data, right? So again, I have covariate data in both groups, but I don't necessarily know what the variation in the outcomes are. Thanks. So I can use that and I can get prediction intervals, same thing. But my concern here is that the prediction intervals I get, I can sort of build, okay, this is the formula I might use. And it's a formula I might use based upon population A formula that I might get from a regression book or piece together. But it's biased because the true error is actually has a biased term in it and this variance. And so one of my concerns here is if I build my model on A and I use it to predict in B, not only might my estimate be biased or my prediction be biased, but my sense of error is actually biased too. I might greatly underestimate how much error there is in that prediction. Okay, so I can again write this out in terms of averages. And this is kind of the end of the maths, just so. So when I write it out in averages, you have these three terms, and I think they are kind of nice. So two of the terms, the D and the M, one has to do with kind of a variance ratio, the similarity and variances between the two populations, and one has to do with the means. The means are really what we've focused on in generalization so far. And the other has to do with sort of bias, the bias in the two. And there are additional things that were not in that previous version. For those that are interested, the D plus M squared part is sort of proportional to the Kullback-Leibler distance between two things. So you said, what's the distance between populations A and B on these covariates? That's what this is measuring, is how similar or different they are. Okay, so if I compare this to in sample versus out of sample, then you can see that if I were talking in sample, this D squared plus M becomes P. But that's not going to be the case here. And if I'm talking in sample, then E, this bias or extrapolation error, becomes 0 also. So we've got these new terms, is my point. We think we're using sort of common methods, but actually we have new terms. Okay, so a few take homes here. Our rules of thumb don't transfer. The things that we think we know about regression into a new population are not the standard formulas. And actually all of the standard formulas assume in sample, that this in sample and out of sample are the same population. The second reason I'm worried, this is data from a paper comparing actual samples of schools in education RCTs and the variation in those populations. And the main take home is these are a bunch of different covariates, and they all have far less variation in their samples than there is in the population. So this is, if they were at 1, this is across many studies. So the average study had, we're looking at half the variation. So samples are indeed more homogeneous than populations. Second thing related to generalization is we're now worried not just about bias in the estimator, but we're worried about bias in our estimate of the error. That's not true in generalization. In generalization, because we're backward seeking, I'm really only worried about the estimator. But here I'm worried that I might not even be able to predict how well, my estimate of the error in my prediction might not be very good either. Okay, so then you can get these sort of planning purposes. And the main thing I want you to take home here is, so if I were planning a study, what would that tell me? Well, first it would tell me if I made sure that I actually sampled from the population I intended to use this from, that I would be better off. But even better than that, if I don't know what that population is, right? Because you'd say, well, I don't really necessarily know. But if you look, what's in the denominator of all of these things? The covariates. And so the other way I can minimize this is to get a very heterogeneous sample. So if I get a very heterogeneous sample, I'm making it robust to predictions, because it's in the denominator. This is really different, I should say, than in how we normally plan experiments. We plan experiments to remove variation, and if what we're wanting to do is predict, we actually need to increase the variation. So this is just I was inspired by our conversation, Bex. This is left over from another talk I gave, but this is to give you a sense of what that is. These are just two covariates. If I wanted to maximize variation, these are correlated, these are not. I want to put them in the corners. I want to get the most extreme data possible. Okay, so in 1 minute, I'm going to tell you where the rest of the paper is going to go. I've been talking about having a lot of predictors. What if we only had a few predictors? I'm really interested in getting to a place in particular of talking about the average treatment effect, not as an inference, but we use the average as a prediction all the time. If you go to a clearinghouse, it tells you the average treatment effect. That means we're telling you to predict the new effect. And so under what conditions might that be a good prediction? You can imagine if your sample size is small enough, that might be better than actually using a more fancy model. And this is a practical problem. So how do we design studies? Again, everything I've talked about has been about unit level, but I'm really interested in those units being sites. And in multi-site trials, for example, the number of sites is very small. So we're talking, okay, I am building this predictive model off of a very small sample. How good can I do? When can I do well with covariates and when can't I? And in particular, because I think this will answer a little bit of a puzzle, which is people, I've often seen them do things like, well, we took this experiment, we're going to see how well we could predict, and it's not predicting very well individual site effects. It doesn't look like there's much heterogeneity. And I think what may be actually happening is that they have such a small sample that they just can't do it well. That the covariates we've collected maybe are not the right covariates, but also that predictive error is quite big. So that's it. Thank you.
So thanks so much, Beth, for this very interesting presentation. What I find fascinating is like this idea that we are moving from, and you spend a lot of time on the paper on that, and I think it's really interesting because it builds like it builds us to want to know what you are proposing. Is that we're moving from estimating average treatment effects or average treatment effects on the treated to predicting individual level treatment effects. So, like you're saying, we're trying to move from evidence-based policymaking to precision policymaking, which I like this image. It looks like our ultimate goal in this framework would be to use, let's say, RCT, but it could be observational data to allocate a treatment to those with the highest, for those it has the highest impact, assuming the cost is the same for everyone. And so your point seems to be, we want to design studies for predicting these individual treatment effects, and that might entail different choices of design than the one for estimating average treatment effects. Again, the version I had up to the point where it was written was like really crystal clear and extremely like I said, it was building up to the point that we were really clear about this, that's the goal. So I'm not gonna come back too much on the formula because you really did a good job presenting it. It just was fun for me to find the row, this guy, the correlation between the unobservable of treated and control outcomes. It's something that is very hard to pin down because it requires the joint distribution of conditional potential outcomes, and by fundamental problem of causal inference, we basically cannot observe the same guys in the two states at the same time. It's fun because like that's an old point of Jim Heckman's in economics, that this is very important. You want to know that, it's very hard. So I suggest that you have a look to their handbook of econometrics chapter, because he discusses a lot this and exactly how you can pin down this guy under some assumptions. So Jim has like several papers in which they're trying to use factor models with measurements, independent measurements of different outcomes, in order to try to pin down this guy. So it's really funny. The second thing I note, and you did a little bit more of that at the end, but I think it still maybe needs more because you build up our expectations. Now we want to know is that when we use this formula and we want to optimally design the study, so in general, we stop with this part, right, which is the classical variance of our treatment effects for the population. And what we do is we try to minimize this guy, and our choice variables is basically n0 because we, in general, have n fixed, and we want just to know the optimal composition of the sample. Note that in that case here, the problem is the same. The additional terms that you add do not change this optimal choice, and the choice is going to be the same. So. And then at the end, you basically said, oh, but one choice that I could have when the problem is slightly more complex and you want to predict out of sample would be to maximize the heterogeneity in the covariates. in a sense, I think for that to be useful, I like the intuition, but for that to be useful, you need to put some cost, right, into that, so that at some point you're going to set up not at the infinite level, but is it always the case that you want maximal heterogeneity? I have a trouble with that to really figure out the intuition here. And if I knew the population B, right, and its characteristics, would I just want to basically make my population A exactly similar to population B, and I would stop there, right? So I need that. Yeah. My intuition would be built better if I could understand why I am wrong or where I am. Okay, then more musings. I love pairwise RCTs. Like in the few RCTs that I conducted in my life, I did one pairwise and I liked it a lot. And I think to me, it speaks a lot to this heterogeneity in treatment effects, because it seems to me that's one of the best ways in which you can get these treatment effects to be observable. Because like I take a pair, and this pair I try to make it as similar as possible in the observable dimensions, all right? So now I'm going to have a pair treatment effects. That's how you analyze pairwise randomized control trials. So your data set is a set of treatment effects. So in a sense, I'm already in the delta yi stuff. And then I can try to predict the delta y with x's, right? And so it looks like this data set, the data set that emerges from a pairwise treatment effect, is almost the data set you would like in order to do this precision-based stuff. So I would be interested to know whether like you could do something with that. And there is something more, because you are discussing a lot the difference between the variance for your prediction, the variance for the population, and for the sample average treatment effect. Very recently, there has been a couple of papers by like a star team like Abadi, Benz, IT, Woodridge, I think, both one in Econometrica, one in QJE, where they propose a new way to derive design-based standard errors. And actually, this line of paper started in 2008 in an obscure paper in the Annals of Economics and Statistics, where they apply for the first time this idea to the analysis of pairwise RCTs. That's why there is a link. And I think there is a link to what we are doing, to what you are doing, that is extremely important. And I think you should like really look into that. I didn't have time to really make up my mind about that, but you repeatedly say things that they also talk about. It looks like what we want to do eventually is an optimal allocation, right? You have an optimal allocation problem. You have a fixed number of people that you can allocate to the treatment, or you can allocate everyone knowing that the treatment is positive for them. And it seems that if you formalize this optimal allocation, then you have an optimal sampling effort, right? That should come as a consequence of that. And it seems to me that, for example, for the people that I know that the treatment is very large, I mean, I don't want a lot of precision. For the people I know that the treatment is very small, I don't care as well, right? What I want probably, but it's an intuition, is I want a lot of precision for people that are very close, for people that are very close to indifference. But maybe I'm wrong here, but I think it would be interesting to try to frame this optimal sampling effort in this way, with linked to the decision of allocation. Thanks.
Any questions for Beth?
Thank you. That was so interesting. I was just wondering, so the methods that you described to measure the out of sample error or prediction errors, they're sort of like global estimates of how well the model is doing. But in ecology, for example, some areas of parameter space, there's more of a cost in making wrong predictions. So maybe towards the edges where like more rare habitats, for example, that we really need to make sure we're being accurate. Are there more like local measures of like error that you could use to sort of, because if your prediction population PB is, you have clustering in parameter space, it could be doing a pretty good job for all of those, most of the units, but for the rare habitats at the edges, it could be doing a really bad job, but that might get obscured by the population measure ones.
It's a great question. I think the mean squared prediction error I'm talking about could probably be written in a way that it makes it weighted. So it weights it differently for different units. So like if you had sort of the covariates, you knew sort of certain subsets of the covariate values had a higher cost function, you could add weight to that. That's sort of what we do in RCTs when we're talking about cost benefit trade-offs of like, do I add another site or do I add individuals? You're putting in a cost for each. And so here it would be putting in a cost function for different covariate values. And I think it would naturally extend.
Thank you.
This is super interesting. I guess it seems like what you're suggesting is that when we're thinking about sampling procedures for experiments, so we want to move to some kind of stratified sampling procedure at the extremes, if our goal is strictly to be predicting out. So like, could you characterize the trade-off between if you had that goal versus the goal of just predicting in A, there must be a trade-off under some circumstances depending on like the variance in those strata. You could maybe directly characterize what the trade-off is so that researchers who have like a mixture of those two goals could decide how much to allocate to the stratification versus how much to just use.
Yeah, that's a great question. So it is a concern, right? So, I mean, essentially what you have is if you want to estimate the average treatment effect and you're kind of agnostic and I just want to do it in my convenience sample, I can get a really small sense of error because I can choose a homogeneous sample. And already, if I want to estimate a population average treatment effect, I'm going to have more error. But this would say for the average, I need even more variation. And so adding more variation in for the average, it could mean that that I've just increased the error and made it hard to get at the average effect. So there is a trade-off. I have another paper, which was on my last slide, that is already published, which is like an in-between of the two things, which is looking at if you were testing hypotheses, if you wanted to plan a study to test a hypothesis about moderators. There I was responding to, there's been papers about power analysis for moderators and how you do design studies to, if you want to do a power analysis for a test of a moderator. And in all of those formulas, they assume that the sample and population are the same thing. But if you sort of work it back outwards in the same way, you get the same problem, which is if they're not, you need to make sure you have a lot of variation in your sample and that moderator. And so in that paper at the very end, I work through sort of an in-between approach, which is I say like, oh, there's one approach which is optimal for the average. There's one approach that's optimal for the moderator. And is there something in between that you could do? Which what I argue there is like you could, use 10% of your sample to increase variation. So you recruit 90% of your sample with the average treatment effect in mind, but then you purposefully recruit some more heterogeneous cases, for just a few of the sites, and that will kind of get you more variation. You're in between the two. So just adding a few extra cases at more extreme values really improves your ability to do moderators.
Yep. Great paper, really interesting. I had a totally sort of uninformed question. So it seems like part of the estimation requires, or in principle would be helped by having this counterfactual for each individual, right? So either in treatment or in control. And I'm just wondering, clearly there's some stuff in the non-parametric world that does this, like, BART, for example, will basically generate, right, the counterfactuals. So I'm just wondering where that sort of, what role that might play in what you're suggesting here.
Yeah, so that's exactly kind of what BART is doing. So the Bayesian causal forest, what they're kind of doing is exactly this, right? But a more complex version of regression, right? So it's building a predictive model on the Y0s and on the Y1s. It's actually regularizing it in the sense that it's recognizing that they're connected to each other in the same way. So they've got something built in for that. It's allowing for nonlinearities. So in there, and there's regularization, meaning, which essentially just means that they might be using fewer covariates, so admitting some bias. So it's doing kind of this, but the problem in my mind is, that's great, but I don't know how to plan a study from that, right? And so this becomes, well, okay, if we could simplify this some, could it help us build a better study? Exactly.
So I want to understand if I'm missing something related to all the points about picking extreme values in the design space. And I was hoping you could explain how much of this is hard work being done by the linear specification.
Yeah.
Because in my mind, you can't do optimal design before you have the optimal estimator. And the optimal estimator will never be a linear regression, in my humble opinion. It will always be semi-parametric, efficient for the design. And I think if you use that estimator, you'll find here that it doesn't say to pick the extremes because it requires information in between, because it doesn't assume it's a straight line. But maybe I'm missing something. Or
No, you're right. So the specification I put forward, I was thinking, and I should have said at the beginning, that sort of covariate space X could include X squared, X cubed, for example. You wouldn't know in reality, but I think for planning purposes, you have to make some assumptions about what you think that is. If you go fully non-parametric, it's going to tell you that you need something every space, every value, and which seems reasonable. But if I'm only selecting a sample of size 40, right? So that there becomes this trait. There is a bias variance trade-off on if I fully selected all of those cases, would I even be able to estimate that well? Even with my non-parametric estimator, maybe the best I could do, given that sample size is a linear model. So I'm not focusing so much on the linear thing. I don't think you could put in a quadratic, for example, and then that's going to add it's going to add some design points in the middle, but yeah, oh no, you're exactly right, which is why you'd want to have variation spread out. So I'd say that the points about it being in the extremes is just kind of an example of if you thought it was linear, that's where it would lead you to. If you thought it was nonlinear, you would also add some design points in the middle in various places. But that mostly we're talking about maximizing variation and getting more variation and more values of X observed, depending what that model is. I think that it is a really tricky part though, because when I talk to people planning studies, they plan them under some very simplifying assumptions, right? Like people will say, well, choose choose your sample so your ICC is small. Okay, completely, like I'm just picking up like a random, like not even random, like an arbitrary population because it has a small ICC for my study. So we're in a world in which people are used to parametric, absurd assumptions. But then once we start talking estimators, people are like really non-parametric and are uncomfortable with these assumptions. So to me, the question is in the in-between, how do we get to some place that is what we could actually do with the small samples? Because it's all small samples in my mind. We're talking precision medicine with individuals. You've got a lot more sample that you can work with, but in the sort of site or location specific estimates, like people want to know what works in my school. That's the kind of question people are asking. If you only have 40 schools in your study, it's going to have to be a model that's probably got some bias in it just by the nature of it.
Okay.
All right. Thanks. Go ahead.
Thanks so much, guys.
So next up, we have Anna Wilke, who will be presenting to harmonize or not research design for cross-context learning.
Good morning, everyone. Thanks for being here. This is going to be an early stage working paper that's joint work with Cyrus. So I'm very much looking forward to hearing your reactions to it, and we're very open to any kind of feedback. All right. So the motivation for this project is that given that we are all paying more attention to external validity, one of the things that we are increasingly seeing is that people study the same research question across different contexts. And so one example of this we have already heard about yesterday from Graeme is the Metacata initiative by EGAP, which is the Evidence in Governance and Politics Network, which is a network of political scientists that do field experiments. And so Graeme presented one version of this yesterday that consisted of multiple RCTs that look at the effect of community policing interventions. Today, I'm going to use Metacata 2 as the motivating example, which is a different round of the same kind of idea. And so Metacata 2 looked at the effects of formalization subsidies, so encouraging people to formalize their relationship with the state on their willingness to actually do do so. So that initiative consisted of 6 RCTs that were run at the same time in low and middle income countries. You can see there were studies in the DRC, India, Brazil, Colombia, Malawi, and Nigeria. And so as you can see from the picture in the top right, these studies yielded quite different results. So in the DRC and in Brazil, it seems that subsidies for formalization increased the willingness to formalize people's relationship with the state. In India, Colombia, Malawi, we have pretty much null effects. And in Nigeria, if anything, there's a negative effect. But beyond the fact that these studies varied quite a bit in terms of their results, they also varied quite a bit in terms of their design. So one of the things that varied was the actual intervention that was being studied. So in the DRC, the intervention was an actual monetary subsidy to obtain a land title and formalize your land. And they looked at the outcome was then also whether people had actually obtained a land title. But in India, the subsidy was an administrative subsidy, so an administrative help to obtain a municipal water connection. So it was quite a different form of intervention. And so and these studies were also run by different research teams, right? So each research team had some leverage over how the study was designed. And so what we are interested in here is understanding whether these design variations are predominantly harmful to our ability to learn from the set or cluster of studies, or whether there's also some upside to having this research design diversity. We've already heard in other talks in this conference that there are increasingly many of these sort of coordinated research efforts. EGAP does the meta-catas in psychology. We have the Many Labs initiative. There's also some JPAL initiatives along these lines. So this is becoming increasingly common. And so what we are interested in more broadly is how do we optimally design these kinds of efforts. And you'll see this will be a very conceptual paper, so it's not necessarily giving you many very practical guidelines yet, but it's sort of giving you some conceptual insights into that. And so what we are specifically focusing on is this question of harmonization. So should all these studies be harmonized in terms of their designs, or should they not be? And our notion of design is quite broad. So you can think about this as, should all of these studies be run by the same research team or by different research teams? Should they all use the same interventions or different interventions? Should they all use the same outcome measures or different outcome measures? And so what we're going to do is that we're going to build a very simple, you'll see quite stylized decision theoretic model where we have a social planner who wants to learn from 2 experiments in 2 different contexts and decide whether to implement the treatment under study in one of these contexts or not. She'll have a prior regarding the effect size. And this is a little odd, but you'll have to bear with me. Currently, we think that the decision maker has quite a good sense of the treatment effect heterogeneity across places. And then the central design choice that she's going to make is to either harmonize the study or not. And so harmonization in this framework will have 2 effects. The first is that it will affect the level of independent information that the decision maker can get from the 2 experiments. And the second will be that it will affect the decision maker's ability to attribute diverging effect estimates to actual treatment effect heterogeneity across the places that we study. And so that will give us a trade-off, and the optimal choice in terms of what to do, whether to harmonize or not, will depend on the degree of treatment effect heterogeneity, and it will also depend on whether we are interested in predicting effects that we in places that we have studied or outside our sample of 2 places that we have studied. So what I'll do is I'll give you a very simple binary example that sort of illustrates the intuition behind this model. And then I'm going to tell you what the more general model looks like, and the intuition will generalize to that model, one-to-one, basically. So in the binary example, we have 2 contexts that we index by I. And a decision maker will face a binary choice of whether to implement some intervention in context I. The treatment effect, the intervention will have a true average treatment effect in both places. So we'll have a treatment effect theta I for place I, and because it's a simple binary example, the treatment effect will be also binary. So it can be 0 or it can be 1. Either there is an effect or there's none. And the decision maker, of course, doesn't observe these effects. So this is what she's interested in learning about. She has some prior belief about this theta I, and specifically she'll think that theta I is equal to 1 with probability greater than 1/2. And we'll consider 2 extreme cases in this example to make the trade-off really stark. So the first case will be one of complete treatment effect homogeneity. So the decision maker knows that the treatment effect is the same in both places. And the second case will be one of complete treatment effect heterogeneity, by which we will mean that the two treatment effects are just independently drawn from a Bernoulli distribution. So that means theta 1 tells you nothing about the treatment effect in context 2, right? So you can't just learn from, if you know the effect in one context, it doesn't tell you anything about the effect in the other context. Okay, so the decision maker runs 2 simultaneous studies, one in each context. And she will choose between 2 possible research designs for each of the study, so that we index the research designs by J. And so, as I said, our notion of research design is quite broad. So think about outcome measures, think about treatment variations. You can even think about it as the research team that runs the study to the degree that this affects our estimates. And so the central characteristic of a research design here will be that it produces some error in our treatment effect estimates. Because we are considering the simple binary case, the error will also be either 0 or 1. So either there is 1 or there's none. And so how should we think about these research design induced errors? Well, if we think about the research design of the outcome measure, we can, for example, think that one outcome measure produces experimental demand that's related to treatment, so it produces overestimates of our treatment effect. Another one doesn't have this feature. We can also think about the dosage of the treatment. So maybe one variation of our treatment has a very high dosage relative to the effect that this treatment would have if we implemented it outside our study. So the dosage may be too high. And in terms of the research team, we could, for example, think about the monitoring capacity of the research team. So maybe the research team makes sure that this thing is really well implemented, but then if we implement it outside our study, somebody else would implement it and it would lead to a smaller effect than what we see in our study. Right, so the error J is, of course, also unobserved epsilon J. And again, the decision maker will have a prior belief about that. And we will denote that by Q. We'll assume it's smaller than 1/2, but that's just to limit the cases that we have to consider. Okay, so given that a study in context I with design J will produce a treatment effect estimate that we denote by theta ij hat, and it's just the sum of the true treatment effect in this place and the research design error epsilon J. And so you'll see this is very simple. We're abstracting from sampling uncertainty. There's not even any uncertainty here that comes from the fact that we can't observe both potential outcomes. So very, very simple. And so the central design choice that we're interested in is whether it's beneficial to harmonize the design in the sense that the decision maker uses the same design for both studies, which would hold the research design error epsilon J constant across the 2 contexts. Alternatively, she can choose 2 different research designs for the 2 studies, which will make the errors be independent across our 2 studies. What I haven't told you about is what the decision maker wants. So the decision maker here will have the following utility function. So if she implements the intervention, so if AI equals 1, then her utility is simply equal to the true treatment effect in context I. If she doesn't implement the intervention, her utility will be equal to her prior. So that just ensures that a priori she's indifferent between implementing and not implementing the intervention. Also, she values learning, right? Because she only wants to implement the intervention if it's better than the status quo. You could use a simple squared error loss function here, and we would get the exact same result. So this utility function is not driving what we will be seeing in this model. Okay, so let's think about what the decision maker will do here. Well, first of all, without loss of generality, we can think about one of the 2 places, right? Because they are completely symmetric. So we can consider learning about only one of them. So we'll use M18 to denote the posterior belief of the decision maker about theta 1, that's the treatment effect in context 1, after she has seen the 2 experimental estimates. And this clicker is a little slow. There we go. We know that the decision maker will implement the intervention in context 1 whenever her posterior belief is greater than the utility she gets from the status quo, which is just her prior, right? So a priori, before she sees the experimental estimates, before she has designed the experiment, her expected utility will be given by this expression. Specifically, there is a case in which her posterior belief is greater than P, in which case she does implement the intervention and her expected utility will be equal to the expected effect of that intervention in context 1, conditional on, of course, her actually being in that case, that her posterior is greater than the status quo utility. And then there's the other case in which her posterior is lower, and in this case, she implements the status quo and gets utility P. So what we're going to do is we're going to calculate that expected utility for these different cases, the two cases that we're considering, under harmonization and without harmonization. We're going to compare that, and that's going to tell us what's optimal under what conditions. So the first case that I want to consider is the one in which treatment effects are homogeneous, and the decision maker harmonizes the two studies. So he uses the same research design. Well, in this case, the two studies are constrained to always yield the same treatment effect estimates, right? Because the treatment effect we know is the same. The research design error is also the same because we have harmonized the studies. So what I'm showing you here is the possible treatment effect estimates in the first two columns that you can obtain. The posterior believe that those treatment effect estimates induce for the decision maker the probability of seeing a particular estimate pattern, that's column 4, the optimal action that results from an estimate pattern, and then finally the expected utility that the decision maker derives. And so ultimately we will sum across all of these. We will multiply the probability here with the expected utility and sum in order to get our expected utility. So the thing to note is that because we have made this very simple binary example and constrained the space of estimates that we can get, the decision maker is very likely to come out fully informed here, right? So if she sees two estimates of 2, she knows that the treatment effect in context 1 has to be 1, because the only way I can get an estimate of 2 is if both the treatment effect and the error are 1, right? And so for the same reason, she also comes out fully informed if she sees 2 estimates of 0. So the only case in which there's some residual uncertainty is going to be the one in which she sees 2 estimates of 1. Right, and in this case, she'll still implement the intervention, which comes from us assuming that P is greater than 1/2. Now, what happens if instead the decision maker decides to not harmonize the designs and introduce research design diversity? Well, in this case, we can get many more different estimate patterns because now the research design error can vary across these different places. And so the table will look like this. So it will have way more rows. But the thing that I want you to take away here is that it's still the case that the decision maker comes out fully informed in almost all of these cases. It's still only the case in which she observes 2 estimates of 1, that she retains some residual uncertainty. And so that's basically it gives you the intuition for why diversity will be useful here. So if treatment effects are homogeneous, right, then introducing research design diversity will reduce the correlation in experimental estimates, and that will help learning about the common effect. So that's the first case. The second case is one in which treatment effects are perfectly heterogeneous. So let's first focus on a decision maker who does not harmonize. Well, if the decision maker does not harmonize, then the 2 experiments will not at all be informative about the context in which they are not run, right? Because the treatment effect is an independent draw, the error is an independent draw. So I can learn nothing from experiment 1 about context 2 and vice versa. Well, receiving 1 signal about 1 context is of course the same as receiving 2 perfectly correlated signals about 1 context. And so this looks exactly as the very first table that I have shown you, right? So now what happens if instead the decision maker harmonizes? Well, if the decision maker harmonizes, he's basically introducing a correlation in the 2 estimates. And so that comes, of course, from the fact that he uses the same design in both places and the errors will be correlated now. And so what's helpful about that is that now we will be able to learn from experiment in place 1 about the treatment effect in place 2 because we have introduced that correlation. To give you a bit of intuition for that, let's consider the case in which we see a treatment effect estimate of 1 in context 1 and a treatment effect estimate of 0 in context 2. Well, in this case, from context 2, we will learn that the research design error has to be 0 because that's the only way in which we can see a treatment effect estimate of 0 in context 2. But because we know that we have harmonized, we know that the error also must be 0 in context 1. And so the estimate of 1 that I see in context 1 can only be produced by a treatment effect of 1. And so that's the way in which the correlation in the errors helps us to learn about the context that we have not studied. And again, we only remain uninformed to some degree if we see true treatment effect estimates of 1. So in this case, if the researcher harmonizes, she is much more likely to come out informed. So the general takeaway is that if treatment effect heterogeneity is high, then design harmonization is helpful because it helps us to separate out the situation where divergences in estimates come from different research design errors and the situation in which they come from actual treatment effect heterogeneity. So that's pretty much the central sort of intuition that falls out of this model. And I'll show you that it holds in a more continuous framework also. And then I'll show you one additional result that comes out of the continuous framework. Okay, so in the continuous world, we'll think about more contexts than just 2. We'll still index them by I, and we'll think that this all comes from a very simple normal model. So we'll think that context level effects theta I, which are now real numbers, are drawn from a common normal distribution that has some mean and some variance. And so V, the variance, is going to be our key parameter of interest because it parameterizes treatment effect heterogeneity across places. And as before, and as I previewed, this is perhaps the weirdest aspect of this model, we'll still think that V is known to the decision maker. And of course, as before, or theta didn't exist before, but the country level effect theta I will still be unknown, and the average theta will also be unobserved. And the decision maker's prior now will also be normal, so he'll just have a normal prior on the mean effect. As before, we run 2 studies, one in context 1, one in context 2. As before, we choose between 2 research designs. And as before, research designs produce some unobserved error, but that error now will be a real number. And the decision maker's prior belief about that error will also be normal. So it's a normal learning model. And well, of course, it doesn't matter that the prior is centered on 0, right? Like that's just for convenience, but we could center it elsewhere and the same thing would happen. So the first thing I'm showing you here is that the result from before just generalizes. So if the decision maker wants to learn about contexts 1 and 2, which are the 2 in which he runs the study, then of course we have the exact same trade-off where if treatment effect heterogeneity is really high, we want to harmonize. So in this case, if V is really high, and if V is really low, then this effect that we want uncorrelated signals dominates, and we want to use research design diversity. So this is literally the equivalent to what I've shown you just before. Right, so this is actually just the intuition. Well, how am I doing on time?
You're doing fine.
I'm doing fine. Lots of time. Oh, wow. Okay. That's going to be short. Well, basically, right, just to go through this intuition one more time. So treatment effects here are basically the sum of the average and a country-specific or context-specific component, right? And so high effect heterogeneity will mean that learning about the country-specific component is really important. And so harmonization will allow us to attribute our treatment effect estimates if they diverge to that country-specific component. But if effect heterogeneity is really low, then all that we want to learn about is theta, which is the average effect across places. And because diversity reduces dependence in our estimates, we are better at doing that. Okay, the final result in the paper concerns learning about a context that we have not studied. So what if we want to learn about context 3, but we have conducted our experiments in context 1 and 2? And so the thing that will fall out of the model is that in this case, it will never be optimal to harmonize. And the reason is that what we are primarily interested in learning about here is then the average effect. So our treatment effect in context 3 will be given by the average effect across all places plus gamma 3, which is the context-specific component for country 3. However, our studies in context 1 and 2 will not tell us anything about gamma 3, right? So they will only be informative for theta. And as a result, our best guess about theta 3 after seeing the 2 experiments will simply be driven by our posterior belief about theta. And so the consideration that design diversity enhances learning will always dominate if we are just interested in learning about the single average effect parameter. So ultimately, the sort of main takeaway from this is that harmonization can involve trade-offs. So what's better in sample may potentially be worse out of sample. And specifically, the situation in which that arises is when we have high treatment effect heterogeneity. So if effect heterogeneity is low, then we want to use research diversity, research design diversity, irrespective of whether we are interested in or out of sample learning. But if we are in a situation where treatment effects are really heterogeneous, then we might want to harmonize for in-sample learning, but use diversity for out-of-sample learning. Of course, there's lots of other things that we want to do to this model. Incorporating uncertainty about effect heterogeneity is one of them. And then there are quite some other assumptions here that you might worry about. One of them, for example, is that research design error cannot at present interact with context, right? So if you have research design features like outcome measures that produce, say, experimental demand in one place, but not in another place, that would definitely destroy the results that I have shown you here. All right. Thank you.
Yeah, thanks so much. Okay, so it's very much work in progress. It's the first time, I was about to say, it's the first time I'm presenting this outside of TSC, whereas, you know, basically are in TSC. First time in front of people that are outside of my little group of people that usually hear my rumblings. Okay, so let's go. So Becca, I think we have the same slide. I'm doing environmental economics in general, so when I don't do econometrics, so that's like, we're facing unprecedented challenges, so put your own challenge here. Mine, in general, the things I work on are like the last two waves, and that's why I put this slide, because it's like, oh, yeah, what I'm working on is so important. And the second thing is like decision makers and ourselves and citizens, we are probably, and I think it's a good thing, more and more relying on evidence to make our decisions. So this evidence-based policymaking that Beth was talking about is like taking up. So here is chapter 5 of the last report of the IPCC Working Group 3 on mitigation against climate change. And I did a quick search in this report, and I find in 5% of the pages, there is reference to the word meta-analysis, which is not counting all the meta-analyses that are cited and that where is not the word is not there. So meta-analysis is everywhere in this chapter. And for example, here we have like behavioral interventions to decrease people energy consumption, and they are based on like a lot of meta-analysis. So that's my motivating point. More and more of what we are doing and what policymakers are trying to implement is based on evidence. The second starting point is if you scour the literature and you look at how many treatment effects are there and how many of them are, how many of our interventions work, it looks like if you read the literature, almost everything works. So that's from an Anshel and Al paper where they scoured the literature in psychology. It's not that old literature. So it's like recent literature in psychology in 5 important psychology journals. They look at 152 studies, and they look at what they report in terms of whether the first hypothesis that they test is supported or not by the data. And the rate is 96%. So that means that either we are like super good at finding hypotheses at work or something is missing. I don't know. So that's basically my starting point. It's weird that there are so many of them that we are so good. Another evidence that is not only in psychology, Bartosz et al. Recently, they report on a lot of meta-analysis in a lot of different fields. And they find that in all of these meta-analyses, 82% in economics report statistically significant meta-analytic effects, 85% in environmental science, 78% in psychology, and only 40% in medicine. Guys, you're lagging. You're not very good at finding good treatments. So in a sense, what I'm going to say doesn't apply to these guys because they figured that out like a long time ago. But it looks like it still needs to be said. And for me, it was like a way to also understand exactly what was going on when we use the filter of statistical significance to make decisions about what to know about. Okay, so where does it all come from? Probably it comes from Fisher. So we had a nice discussion about Fisher with Anna. And probably it comes from Fisher saying I think here is statistical methods for research workers, but maybe in some other book, very influential guy. Personally, the writer prefers to set a low standard of significance at the 5% point and ignore entirely all results which fail to reach this level. So basically that started all the idea of saying, okay, let's say 5% significance, throw everything away, but it's not there. We know that this is happening in the data, in economics at least, in psychology, of course. So, for example, the famous Broder et al. Papers, the Star Wars paper, Empirics Strikes Back. For those who don't know the paper, the title is wonderful. They find a marked decrease in the density of these statistics just below 1.96, which seems to point to the fact that, in a sense, we have a marked preference as referees and editors and even readers for papers that are statistically significant. I mean, I'm not saying anything that is weird here. I mean, everybody knows, right? But Andrews and Kazi, in a really nice AR paper, they use replications to estimate the baseline rate and the probability that a non-statistically significant result gets into the published record. They estimate it to be 3% in experimental econ and 2% in psychology. So very low probabilities, right? Almost zero. Okay, so does that matter in any way for evidence-based decisions? That's the question that I ask in this paper. Again, like doctors are laughing. So I think this has been solved, like this part. Okay, when the decision maker uses this data that is published to allocate drugs and vaccines, I think they kind of solve the issue that I'm talking about. Here we are here, right? Social scientists. And the question I'm asking is whether, like, our preference for statistically significant results in populating the published record with statistically significant results, does it distort in any way the allocation of programs? So that's my question. So I'm going to do theory. Yeah, I have the plan to do simulations. It's not going to be there. And I have a plan to do several examples, but there are going to be one today. Okay. Quick literature. Oh, yeah. Oh, it's very lagging. I was not believing the other speakers. I was like, you're really like, wow. So what I'm saying is in like flavor of this Ioannidis et al. And literature saying that there is publication bias, questionable research practices, etc. But I think I'm trying to go a little beyond, like humbly. But because like Ioannidis tells us, okay, most research published findings are false. And you're like, yeah, but so what? So does it really distort actual decisions? Or is it okay? Are we barely there? So the question is like a little bit like Cyrus's presentation. Sometimes it's different to get at the average treatment effect or to get at the actual allocation. So I'm focusing on the actual allocation. We have evidence that publication bias exists, like I showed some of it in my introduction. But if you look at, okay, I'm going to try to decide how to allocate treatments based on my evidence, okay? I mean, to my knowledge, so again, feel free to give me another set of references to fill this in. To my knowledge, there are only 2 papers doing that, at least in econ, because that's my field. There is the Frankel and Kazi paper and the Abadier paper. Frankel and Kazi, basically, they say, it's fine to ignore some part of the results because it's not very informative when the result is very close to your prior as a decision maker. And if there are like frictions, like publication costs, attention costs by a decision maker, it's okay for the decision maker to throw away some of the data. So that's basically their point. It's okay to have publication bias. Abadier in his paper says, oh, the most valuable results are most of the time the statistically non-significant ones. And I'm like, okay, so how can I reconcile these polar opposites? And so that's where I think I'm trying to bring a little bit of stuff. Okay, so the way I think about this, I have a continuum of treatments indexed by T. Each treatment has a fixed true return theta t in some
over some, I take 0, 1 in general, so my simulations, so that things are simple. Think about this. Okay. And then researchers are going to produce estimates of this effectiveness using LRCT, let's say. And so estimates are indexed by I. I put a hat because it's an estimate. And because of the central limit theorem, theta hat IT is going to be normally distributed. Because I use an RCT, it's going to be centered at theta t, unbiased and consistent. And its standard error is S hat IT. And I'm going to add that there is a probability that the result is published or brought to the knowledge of the decision maker, some function. And the function I'm going to use in most of my simulations is if the ratio, the absolute value of the ratio of the treatment effect to its standard error is bigger than 1.96, like the one that you know very well. And I'm going to say each program goes C, and the returns to the program are theta t. So my decision maker would like to compare theta t to C. And you want to implement all of the programs where theta t to minus C is positive. I'm going to model different ways that decision maker make decisions. One is going to be the omniscient decision maker. He knows theta t, so that's my benchmark. The guy is super psychic powers, never makes a mistake. I'm going to do what I call the unbiased decision rule. The unbiased decision rule is you take the first theta hat I estimate that you find, and you use it to make a decision. And if it's above cost, the estimated returns, you just implement. And then if you happen to have several of these estimates, that is the first one, you just do the middle rule. If you happen to have n of these estimates, you just use meta-analytic weighting with precision weighting. So that's what you're doing. Now the biased decision maker, actually, he doesn't have access to the theta ITs, except if they are statistically significant. So that's what this notation means. And when he does meta-analysis, he only can aggregate with precision weights the results that are statistically significant. That's how he does. And here, the decision maker is completely blind to anything that is happening in the publication business, etc. He just takes results as they come, and he doesn't think about sophisticatedly and in any way about what is going on, which I think is a much better characterization of the actual decision maker than anything else. But I mean, you can extend that. There are some extensions that I can think about in this direction. Okay, so what is nice about all of that being normally distributed, thanks to the central limit theorem, is that if you want to derive, for example, the expected value of the treatment effect given the selection decision, we have a closed form for that with an inverted Mills ratio, so that's pretty cool. We have even, when n grows large, we have even a closed form solution for the variance of that estimator. That's why I need simulations, because when n is small, that is probably slightly wrong, but nothing that will, I think, alter the qualitative conclusions. And then I'm going to estimate the returns to each decision rule. And the return is basically the true theta minus cost multiplied by the probability that I choose the treatment, to implement the treatment. And that probability is based on the estimated theta, not the true one. The last piece of machinery that I need is I need to assume something about the true distribution of treatment effects. That is, you have these programs. I'm going to say that the returns are between 0 and 1. And now I need to assume something about where these programs lie on average. That is, the programs we come up with, are they in general not working? So is the distribution of treatment effects tilted to the left? So that's this curve here. Or are most of the programs we come up with and we test tilted to the right? So most of them are effective. I have also, you can see that there are a lot of intermediate cases that I look at. Before showing you the main theoretical result, I want to spend some time on the intuition. Okay, so that's basically what I learned when I did this project. The key thing with publication bias is that it is asymmetric. It is asymmetric in 2 dimensions. First, it is larger the closest the treatment effect is to 0. So what you are seeing here is the true treatment effect theta t. And here is the expected value of the theta I t conditional on it being significant, statistically significant. And you can see that, and this is the 45-degree line. So the difference between my expected value and the 45-degree line is the publication bias, the amount of bias due to publication bias. And you can see that the higher my treatment effect, the smaller the publication bias is, right? So publication bias does not alter our estimates of very large treatment effects. It particularly affects treatment effects that are small or null. So that's the first asymmetry. The second asymmetry is that the less precise, so here I have increasing standard errors as I move here towards the blue curve. So the blue curve is very imprecise, 0.25 standard error. So with this imprecise, more imprecise results are more biased. So that's the second result, the second intuition. So now you can see what publication bias is going to do to my allocation. Is that, for example, if my cost of implementing a treatment is 0.5, I would like to implement all of these guys, right? All of the treatments above 0.5. That is all of this part. And the red curve gives me that, right? With the blue curve, if what I see is the blue curve, I basically implement all of the treatments and up to the ones that have no treatment effect, that have 0 effect. Okay, so that's basically what is going to drive the results. You're going to have misallocation because this part of the curve here gives an over-adoption of treatments. Yes.
Thanks. I'm a bit confused because you're talking about the policymaker being exposed to the outcome of the meta-analysis or to the studies that compose the meta-analysis?
So he has several things, but I'm going to show you right now. I'm going to explain that right now.
Because, I mean, when you do the meta-analysis, very basic stuff, I mean, they tell you, okay, we estimate publication bias. So the true effect that you report is supposed to be purged to some extent from this publication bias already.
Yeah, so,
or you assume that this is badly done, or we cannot trust that?
Let me get to my conclusion and I will talk about that. Okay. So for now, I'm like simplest basic case, right? Either I have one estimate, okay, and either it is whatever estimate, or it is an estimate that is statistically significant, or I have several estimates and I just do a meta-analysis, but the meta-analysis is basically a precision-weighted mean. And it's either a precision-weighted mean of all the effects, or random sample of them, or a precision-weighted meta-analysis mean of the conditional on being statistically significant. That's the only thing I'm doing here. Okay. So this is the main theoretical result. If you look at the expected returns of these decision rules, the main thing that you see is that the cost of publication bias is going to depend on how the true treatment effects are distributed, how precise they are, and how costly your programs are. So if you take this lower quadrant here, very imprecise treatment effects, and start here. So if you start here, the right tilted distribution means most of my treatment effects are, most of my programs are effective. So I'm drawing the distribution when everything is very good. And here, the first red guy is the expected return to the omniscient decision maker. So that's my benchmark. That's the best I can do. So of course, because my programs are great, I'm doing very well. And you can see that with an unbiased or meta-analysis decision maker that has access to all of the data, I'm doing almost as well, right? When I'm accessing the biased published record, but I'm doing as well. Why? Because all of the treatment effects are on the left, on the right. And so I have only good programs. So publication bias doesn't do anything. What happens when I move there towards the left tilted distribution is that the more I go to the left, the more programs I have that are close to 0, and the more publication bias kicks in. The more it tells you, oh, you should apply this program, it looks great. And you should not. So that's what publication bias is doing. And you can see that if I move up now towards more precise estimators, this problem is less severe. Okay, the difference between this guy, the omniscient, and the biased decision, it exists a little bit, but it is smaller. When the cost of implementing a program is lower, this problem is also slightly less severe, but it depends on how you define it, right? Because actually here it's actually more severe. But the main idea is this, right? Depending on where your programs are, and if your estimates are precise, publication bias might be a very huge problem or a small problem. Yeah, okay, so we won't have that today. Okay, so now in the second part, what I want to do is to document whether what I'm saying is like theoretically important or whether it's just a theoretical curiosum or if it has like some empirical grounding in the real life. And so what I need to do that, and that's where it's hard, you need the distribution of the true treatment effects, because the key to the cost of publication bias is how are the true treatment effects distributed? And that is like hard. And then I need a population of published studies. This is the second thing I need in order to have an idea of how in actual life, decision editors, referees choose to bring, and researchers choose to bring their knowledge, the results to the published record. So I need these two things because for now I have assumed stuff about these two things, and maybe my assumptions are completely wrong in a sense. So here I have one example for now, and I will talk about my planned extensions. So the example comes from a wonderful paper by Karlan and co-authors in Nature Human Behavior. This is like a paper I posted a blog post on that when I read it. It was so beautiful. It's the paper I wished I had written. It's really an amazing paper. But what they do is they basically provide me with these things that I need. First, they use 15 pre-registered replications of effects measured in psychology. And because they are pre-registered replications, they are the universe of treatment effects that we are after. So I'm going to use that as my reference distribution. And the second thing that they do is they use 15 meta-analyses of the same effects, regrouping 1,000 studies published prior to the pre-registered replication. So I have the actual publication record and the meta-analytic effects before we do the pre-registered replications. So here is the density of the treatment effects in this data set. And you can already see that that's not going to go very well, except the studies are extremely precise, okay? Because that is the published distribution of the meta-analytic effects. So this in red is the original effects. So the meta-analytic effects are inverted U, their density. So most of them, we believe, are between like 0.2, 0.75. The replicated treatment effects, yeah, the mode is at 0, so it's left tilted. So we still can be fine if the studies are super precise, because if the studies are super precise, then I'm going to make a lot of mistakes. Before I show you the results of the simulations of like which program I'm going to implement using this data set, if I say that my psychological effects are like programs, I'm going to show you a piece of evidence that tells us that first, the model that we have of publication bias effects on effect size estimates is not completely wrong. It's even predicting almost perfectly. This is one of the most beautiful empirical results I've had since a very long time, since I'm doing economics, I guess. Last time I've had some similar thing, what I was doing like lab manipulations in biology class, so, you know. So what do I do here? Here is the replication effect size. So what I'm going to say is my reference, the truth. Here is the published effect size. And I bind each of the studies into very precise estimates. So this year I talk about individual studies. So with standard error between 0 and 0.1. then 0.1, 0.25. So this is decreasing precision here as you move along these colors. And then remember, my prediction is that publication bias should be the largest when treatment effect is actually small and imprecisely measured. So let's go at 0, where I have a lot of studies. At 0, the most precise studies, what do they say? Yeah, basically 0. That's the meta-analytic studies. That's not the replications. Huh? So the studies in the meta-analysis that populate the meta-analytical record, when you focus on the most precise ones, publication bias basically 0 as predicted. Oh, yeah, sorry, that is as predicted by the theoretical model. And when you move up, right, as you move up into the ranking of precision, you move also up into the ranking of bias, where the bias is the biggest with the least precise estimators, the least precise individual study. Okay, so it seems that this kind of, for me, validates a lot of the simple selection model that I use so far. On this data set, if I use the individual studies, so depending on the cost, so let's focus on the cost. Let's focus on the cost at 0.5. So what do we see? We see that if I use the replication treatment effect, right? So I'm going to say this is the truth. So I am with the omniscient decision maker. This is my benchmark. So this is the maximum returns I can have, conditional on some noise. If I am an unbiased decision maker and I have access to only one study, so that's the first part here, the brown one, my returns are going to decrease because this is very imprecise. My estimates of the true treatment effects are imprecise. So I'm going to make mistakes. Sometimes I'm going to implement the program and I should not. Sometimes I avoid implementing it and I should, etc. And you see that as I add studies, so I become green and greener. As I add more studies, I converge towards the omniscient decision maker. So here, the meta-analysis is virtuous. It is consistent. It makes us being more and more, implementing more and more the correct programs. On the other side are the biased decision makers. And you can see here that the biased decision makers, they are making an awful job, right? Because when they use the published record, they are making a lot of misallocations. And the cost is like very large in this simulation. It decreases with the number of studies, which is reassuring, but it never converges to the optimal allocation. I could explain and the reason why is pretty simple to understand, because so these are all the meta-analytic effects, and this as a function of the true effect size. So this is the published meta-analytic results for the 15 studies, and this is the replication effect size. And you can see that for the two most biggest effects, the meta-analysis basically says the truth, right? So it's very consistent. So when I have to allocate these programs, let's say my cost is 0.5, the meta-analytic effect and the true effect are consistent. I'm always allocating these two programs to being implemented. So here I'm fine. The problem comes right on the left, because now you can see that I have some programs. So the three programs in the left upper quadrant, they look like they are very efficient, right? Because their meta-analytic effect size is above 0.5. But actually, their true effect size is between 0 and 0.25. So if my cost is 0.5, I should never implement them. And you see that as I move down the cost to 0.25, this number of studies that are in the upper left quadrant increases. So the number of studies that misallocate is even larger. It's also less severe because the costs are smaller. Okay, so the extensions I have in mind are other applications, so probably the OSC data and the Kammerer et al. Data, maybe some data on nudge units, hopefully, and maybe some data on development programs. But now to find the benchmark for these data sets is much harder. So maybe you have to correct for publication bias and use that as your benchmark. For that, you have to believe that the methods to correct for publication bias work. And so here, this is my own replication and extension of the actual goal of the Kvarven paper, which uses the data I just shown you to test whether the method to correct for publication bias with meta-analysis actually work. So this is mean bias, mean absolute deviation, and root mean square error of a lot of different methods. And you can see that some methods work pretty well. So we have some ways to correct for that. So an extension is to also test whether when you correct for publication bias, you act with these methods, you actually improve on the allocation. Okay, and last thing, I want also to try to find what are the publication costs, so the Frankel and Kazi type of friction that would rationalize the publication decisions that we are making. So are they very small? Probably not. I think they are huge, and so probably they do not make sense in any way. But that's for the empirics to say. And then, like, whether the last question is whether if we force everyone to publish everything, like with registered reports, are we saving money, and in which direction and in which way? So that's another question that I would like to add, another extension that I would like to add to this paper. So that's me.
So,
Okay, great. Thanks so much for that really interesting talk. This was really a delight to read. I was actually recently at another conference where they had, several months ago asked me to talk about how research transparency is important for understanding policymaking. And I was like, well, actually, I don't know that there's really stuff that I can say on that, but here is something that speaks to that. Instead, I could talk about other external validity things instead. But here specifically is treatment misallocation under publication bias. And I really liked the intuition here that, if we think that there's more publication bias amongst results that are closer to having no effect, then that should bias. Actually, there could be some real trade-offs here. And if you think that there's, this additional cost threshold you have to get over, well, many of the ones that appear to be effective, well, they're not effective compared to the costs. So it's a very clear intuition. Now, some comments. First, this does depend on the costs very directly. And it would be nice when taking it to data to know more about the cost side rather than just having to sort of assume it. Unfortunately, this is not a drawback of the paper, but a drawback of the evidence we produce. Cost information does not tend to be reported. So this, if we're trying to think of what do things practically mean, of course, it would be nice to have information on costs. If we don't have information on costs, I was trying to think of, what else can you use potentially? And maybe one answer is that if somebody's thinking of making a decision, maybe they're not comparing it to the cost, but to an alternative program that they could do instead. Maybe rather than saying, okay, well, this program has to get over this cost benefit analysis in order for me to do it at all. Instead, I know I want to do something, and I just have to pick between different potential interventions. And in that world, it would be nice to know a little bit more about how publication bias could potentially, there was some line in the paper about this, about it also could affect the rank, but I didn't actually see anything yet on the rank. And it would be nice to know, because you would think, well, maybe publication bias might affect everything, and then the rank would be preserved if you're just comparing between two different treatments. So you might still be incorrect compared to the costs, but not compared to other programs necessarily. of course, I'm not sure that story I'm telling you is actually true, because you could think there's some literatures maybe that are more biased than others. So maybe the rank of different kinds of interventions does change, but it would be nice to know a little bit more about that, or just, you know, explore that a little bit more. So that was one thought that I had. Another thing that came to mind for me when reading this is other kinds of biases that might be harder to observe. So for example, if we think of even, you know, the lovely registered reports that we all like so much, myself included, they're a great innovation to the discipline, but do they solve all the problems? Well, probably not. For example, you know, I know Séverine Toussaint, for example, at the University of Oxford is doing this kind of looking at failures and how we learn from failures. And you may have a situation where you've tried an experiment many, many times, especially if it's like a lab experiment. You know exactly what kind of, how to set it up, what message to use, what sample to recruit, that's such that you get, you know, your finding. And it might not be intentional, but you kind of end up, you know, sort of potentially getting exactly the right parameters. You find a significant effect. It's very consistent. You can replicate it. You, at that point, maybe go and you pre-register what you're going to do, and, you know, based on your past experience. So of course that can undo some of the effects of, you know, pre-registering and having, you know, nice registered reports, etc. And there could be other biases like that, where you say, okay, this can replicate, but is this really what we want to get at? Like, you change it a little bit, you move to a slightly different context, which is really what the policymaker is likely going to do. You know, you might have some results that are fragile. And there's, of course, other kinds of biases that can creep in when you're extrapolating more from one context to another. So just a little bit more thinking through how this also applies. So that would be nice. But on the other hand, even just thinking of publication bias, as I was saying at the beginning, from just the publication bias aspect is also great. I mean, they don't have that piece in the literature. So I was really glad to see this paper. So there's not too much of a criticism, actually, just an additional thing. I will say that I personally am more skeptical, perhaps, of some of the methods of correcting for publication bias, just because a lot of them do depend on assumptions that one isn't necessarily always willing to make. Some methods, for example, might depend on saying that there's not heterogeneity in treatment effects that's due to context, or you know, other things like that that actually I care a lot about. So I'm a little bit more skeptical of some of the methods to correct it as well. But it would be nice to see how much the existing sort of solutions to correcting publication bias do perform. It would also be nice to see, you know, there's some comments in the paper about future extensions of this, you know, how it ties into, you know, somebody who is Bayesian updating based off of the evidence. My own prior would be that other people's priors would somewhat undo this, in the sense that, you know, if you don't think that people's priors are correlated with the publication bias, then, you know, they should be a little bit, even if they update on studies that are biased, they should end up in a slightly better spot. But maybe their priors are correlated with publication bias. I don't actually know if there's a literature on that. So in any case, I do think that would be an interesting direction to explore. Overall, fantastic paper, really appreciated, you know, reading it. I think it adds a lot to the literature, and there is a hole right now here in the literature specifically on this problem. So none of my comments are too negative here. I really like the paper, so thank you for that.